Right. I think in the paucity of time we will start. So good morning everyone. Good morning, sir. Good morning everyone. Little louder. Good morning. That's more like it. Welcome to another edition of the Zak World of Façades conference. It turns out to be our 100th edition, something which we have achieved in the last 10-1 years. So it still feels a dream for all of us. I think we started back in 2012, 27th July at the Taj in Bangalore. I think it all started for fun, I think. There was an opportunity to work with a client. We grabbed that opportunity and then we didn't know what to do. And then we developed it into this conference series, and that's evolved over the last 10 years. That is something which I'm extremely proud of what we have achieved with my team. So kudos to all of them. I have a lot of my former colleagues also here present in the audience, a lot of former collaborators, current collaborators, future collaborators. So it's good to see all of them here. I don't want to make it too much about our 100th edition today. All of you are here to hear about facades. I'll probably be doing a little bit of that later during the day, but just quickly introduce the Zak World of Façades conference. So we started the Zak World of Façades conference, as I said, in 2012. We've expanded literally all across the globe, except South America. We are present everywhere. So this is like a lineup for 22-23. Lots of countries which we have executed are not present here, but this is something which is what we're going to be doing for next year. And right from events up from New Zealand up until Canada, they're literally there. So every event has been a different challenge. Every event has its own set of topics, themes, and obviously this is something which we curate from India with our team, with a lot of passion globally. So that makes it even more important for us. Our event wouldn't have been possible without event partners. I think that's one of the key reasons why we've also been able to grow globally. We've collaborated, partnered with a lot of multinational companies which are globally present, and it's been easy for us to collaborate with them and expand into newer markets. So for this year's Indian editions, we have Technal, who are our presenting partners. Technal are world leaders in aluminum door, window, curtain wall systems. They are part of the Hydro Group. Powered by Partners Glass Wall Systems, one of India's leading facade contracting companies. A premier partner, Alstone. Alstone is a manufacturer of non-combustible aluminum composite panels. Blick Systems, they're distributed by their partner Diamond Engineering. They have some interesting facade systems and stone cladding systems. Codina is a Spanish manufacturer of mesh for facades. They're also participating along with their local partner Diamond Engineering. Construction Specialities is an American manufacturer of louvers. They are here represented with their local partner Diamond Engineering. Dalpal is a manufacturer of polycarbonate sheets which are used for cladding, so they focus on light architecture. Euramax is a coil company from Europe. They are exhibiting with their local partners Diamond Engineering. FG Glass is a value-added glass processor. Fischer is a German manufacturer of fixing of anchors, of tools for doors, windows, and facades. Firestop also. Fundamax is our world leaders in high-pressure laminate, Austrian company. GE Silicons, American company into sealants for structural glazing, participating with their local partner Diamond Engineering. Hilti is a global manufacturer of tools, of pacifier stop solutions, of anchors, literally everything. Kinlong is one of China's leading manufacturer of glass hardware and fitting. Curare is the mother company of the laminated glass interlayers, Rosifol and Sentry Glass. Ozone is a leading Indian manufacturer and exporter of glass hardware, fittings, accessories. Serge Ferrari is a French multinational manufacturing fabrics which are now used for facades for lightweight applications, facades and roofs. Siderice are a British manufacturer of pacifier protection solutions for rear ventilated facades and cavity barriers. They are participating with their local partner, Allarc. Vibhaw is an Indian manufacturer and exporter of non-combustible aluminum composite panels. Wienerberger is an Austrian manufacturer of bricks and terracotta cladding. They are here with their local partner, Diamond Engineering. Our technology partners are Orga Data. So if you see all the delegate badges, we have a USB stick, which is courtesy hanging on your delegate badge, which is courtesy Orga Data. Orga Data are the technology partners for this event. They have a software for estimation of those windows. Of course, the mother event for this event are our exhibitions on glass processing, doors, windows, facades, aluminum extrusions, basis on which we started this event back in 2012. Our next upcoming event, so we have our second biggest event globally, which is in New York City. We've got our biggest event, which is London, which is close to 1,000 people attending. And this year we have collaborated with SIBSI and the Society of Facade Engineering to organize their Facade 2022 International Awards. So upon the completion of the Zak World of Façades conference, the black tie event will take place in central London. Our next event we're doing a new event in Israel. So that's our first event over there. Russia, yes, have to complete some existing commitments, planned the event for last year. Things changed. I think the Russian people are great. Can't say so much for their leadership, but the people were at least fabulous to us. When I went to Russia last year, I was under the impression, I was told Russians are crazy people, but they've been extremely good to us. We've probably had some of the best time planning and executing this event. Unfortunately, due to the war, we had to postpone it, but due to some commitments, we have to complete the event, so that's next month. We've got Vietnam, again, second time in Vietnam. We're expanding a lot in North America, so we have another event in the US end of the year in Dallas. We've got our final event for the year in Riyadh, and it goes on. So we've got an event in Auckland next year, we've got an event in Dubai, in Melbourne, so literally all across the globe. So this is what we've been doing. We've been partnering with companies and we've been executing events which are meaningful to that respective country, to that respective audience, and this is something which we are extremely proud of. It's done from India and makes us extremely proud that we've been able to do all these events successfully over the last 10 years, thanks to support from people like you, our event partners, our speakers. And yeah, that's it from me. I'll probably have another talk a little later. At the end of the day, we'll have a small celebration for our 100th edition. Again, I don't want this to be about the 100th edition. I want this to be about discussing, designing, engineering, executing facades. So that's it from me. I'd like to call upon today's event host. So we've always had male hosts, which I'm not very proud of. This is the 100th edition, this is just the second edition where we're having a female host. That's one thing which I've learned from going outside India, diversity. Unfortunately, we don't look at it as a big thing here, but in certain countries, I don't want to be naming, we've had people almost threatening to boycott because the diversity ratio was completely oriented towards one gender. So I think India has a long way to go, but this is something which we are now as an organizer are trying our level best. It's difficult to find many women in the facade engineering field, so it makes it, or women architects who are designing high-performance facades. So it's a humongous task, but we've significantly increased the ratio over the past few years, and this is something which we've learned from our experiences going overseas, where people actually insist and want to see more diversity on the agenda. Diversity is just not, and then in certain countries, diversity is just not about male or female. It's also with your color of the skin. That's also something which we learned, especially you go to North America. Diversity comes with respect to your color of the skin also. So that's another factor to consider. But again, these are lovely points which we've learned overseas, and not only about diversity, but a lot of facade engineering topics which over the last 10 years which we have presented, most of them we've probably heard of or learned of from another event overseas. We've tried to bring the technology or that kind of concept or the speaker or the topic here, and it's same goes today. We have a few international keynote speakers who've flown down. We know them from our previous editions in the past. They've been great supporters. So this is something which I believe we can add to the table by collaboration with other international organizers. The only thing which upsets me is probably the last part. I'm a little over time, but I don't want to be another Dharmender. But the thing is that I would love to see a lot of Indian architects also go overseas at something which we've not been able to do so. But I'm sure in the next few years, I think we have a great economy coming, one of the fastest growing in the next few years. So we have a good times going forward. So I wish Indian designers, Indian curtain wall manufacturers can do export-oriented stuff outside India, which will make our country even more prouder. So that's something which we as an organizer can definitely assist in whatever way we can, and I'm sure as an industry, you guys can look up to us for any kind of support you need. So that's it with me. I'd like to invite today's event host, Mrinalini. So she, can I have her bio on stage, please? So Mrinalini has been, she's an architect, she's been an editor, she was the former editor of the Star magazine. So she'll be hosting today's event. I'd like to call her up on stage and she will lead you through the day. So Mrinalini, over to you. Thanks.
A very good morning to everyone. Ahmed, I know you don't want to make this about the 100th edition, but it's not something that can be denied or ignored, so hearty congratulations on that to the entire team at Zak. Also, great to see a lot of women in the audience, not enough, but hopefully that'll change over the next few years. But more than anything else, it's a pleasure to be here today. It's an exciting set of speakers and discussions that we've got coming forth, which I'm sure are going to be rather intense, so I'm going to keep my bit a little short. I'm an architect, as Ahmed said, and as an architect, I feel that I've always been more about asking questions and rather than providing answers. But what's interesting is that a lot of these questions have evolved into obsessions, sometimes paranoia, to be honest. Currently, I find myself occupied with the whys, whats, and where-offs of the contemporary Indian architectural identity. And I thought it would be interesting to start the day questioning why we are here, what we are doing, and where we hope to end up. In a conference that will focus largely on architectural facades for the rest of the day, I wanted to flip the phrase around and talk about the facade of architecture and what that may mean for us. So there's a duality in the word facade, which I think is something that we could possibly ponder upon. It can be used as a term to represent the front of a building, which most of us do on a daily basis, which is literally the face of the building, but also it, according to the dictionary, means a false appearance that makes someone or something seem more pleasant or better than they really are. In this case, of course, a metaphorical face. So my curiosities lie in how we as architects, designers, and stakeholders of the built environment define and describe the facade of architecture in India and globally. We've got a lot of international speakers today, so it'll be interesting to hear from them where India and Indian architecture posits itself at an international level and how they perceive of us as designers and an industry. To clarify a little bit, I am talking about architecture which means to us as at an individual level, but also as a collective, our practitioners as our craft, individual components of a system working together towards a common goal, or are we really interested in, are we independent entities that function heterogeneously that covers up some of our imperfections, perhaps. So I'm hoping that we can start with a few questions and ask what, why, who, where, and how. I am going to list out a few and hope that these can become the framework of some of your thoughts as you go ahead during the day and reflect upon them when you see the presentations. What does Indian architecture stand for today? What are we as individual practitioners trying to say through our work? And what messages are we giving to the world about Indian architecture? Why do we design the way we do? Why are we bound by our limitations? And why are we projecting ourselves the way we are? Who represents Indian architecture? Who do we as architects represent? And who do we create architecture for? Where do we stand as a collective creative community? Where are we headed from here? And where would we like to be in the future? How do we reflect on our histories and our heritage? How do we break away from legacy and build on our own ground? How do we compete amongst ourselves? But how do we posit Indian practice at a global stage? I do believe, and this may sound a little cliched, but we are the builders of tomorrow, literally and figuratively. And we carry immense responsibility on our shoulders. This is a room full of people who are going to be responsible for a lot that comes our way in the future. The reason I chose not to give a presentation and instead open with questions is because I feel that at some point we get so tied up with what we are doing. We zoom so far into the details of our drawings that we lose sight of what we are doing, why we're doing it, and the context that we are working within. So while I'm sure many of our following talks will delve into some very pertinent issues and discuss some very important details, I hope that these provocations that I have shared can perhaps become a framework against which you can hold some of these thoughts and perhaps build your own curiosities. The talks and presentations that we have are not going to be followed by Q&As with the audience, but you will have the opportunity to engage with speakers during the breakout sessions and the networking sessions. So I would encourage everyone to actually pursue some of these conversations and these questions with our speakers through the day. Conferences like these, they provide opportunities to develop discourse and action thought. And I would like to thank the entire Zak team for this platform. And good luck to everybody going ahead and a very, very warm welcome. So without further ado, I would like to invite on stage Esha Sharma for the welcome note. A round of applause for Esha, please. She is the National Key Account Manager, Retail and Major Projects for Technal in India. The floor is all yours.
Thank you, Mrinalini. So it's a pleasant change to see you. Not that Tariq Bhai or everybody else who has presented before were not good, but you're good. Amazing. Thank you so much. So again, touching on the 100th edition, I'm not saying it is not a big deal because it is a big deal. I want to ask here in the audience, how many of you were probably there for the first edition that happened in Mumbai in 2013? Wow, not bad. So I was there too. And since then, in 2013, I think it happened in March on the same stage. And since then, we have discussed a lot of interesting topics, subjects on this platform, from the aluminum facades to performance to basic execution, who does what, to the more interesting and more diverse topics like sustainability, low carbon, fire safety, life safety, and fancy facades, parametric facades, everything new and becoming in this industry that has been discussed on this platform since 2013. And almost 10 years later, we are here again, 100th edition, wow. And I would like to thank everybody of you who has come here to listen to us, to encourage the people who make the facade industry what it is today. My name is Esha Sharma. I represent Technal. We have all the systems that make a facade what it is in terms of performance, in terms of looks. We have my team here, Yasmin Gill. She's the head of the emerging markets and East. We have my friend Arvind, who's going to speak about all the systems that we have and what we can provide you in order for your buildings to excel and stand out. and we have our managing director, Mr. Sam Robinson, our technical director, Mr. Krishna Shetty, and the whole team here. We are going to be here for throughout the day to discuss, to interact with you and come up with something really nice, and hopefully for the 200th edition we'll be back. Thank you, Zakir sir, and thank you everybody. Thanks, Ahad. Thanks, Mrinalini.
Thank you, Esha, for opening that for us. I'm not going to take much time. We've got Aiman Ansari, who is architecture CRE. He's the director of architecture and CRE of DSB Design Associates. Yatin couldn't make it today, but Aiman's going to make the presentation for us instead.
Thank you and good morning, everyone. Thank you, Zak, for hosting us, and congratulations for the 100th edition. DSP, I'll just give a quick introduction and not take much of your time. We are into master planning, architecture, interior design, design and build services, as well as intelligent buildings. Been in the fields for more than 3 decades. And I will not bore you with too much of Gyan today, but just run you through a few projects, because we have been fortunate to be doing architecture for residential, for commercial buildings, for hospitality, as well as for public buildings. So what we do in all these buildings, I'll just run you through a few slides, and then in turn, one of the case studies for our recently completed buildings with intelligent glass, and a short video of what we feel is the facades for tomorrow with integration of Indian architecture into it. Now, just go back to the PPT, please. So, this is one of the residential towers that we have recently completed, Omkar 1973. I think so most of you all are from Mumbai and would be knowing about it. So, yep, the play of balconies, that's how the facade has been enveloped. So, thermal comfort, solar comfort. One more project for Lodha. Similar fenestration, wherein we have tried to enclose the rooms within the concrete boundaries. Specific emphasis on the drop-down pardis, the jalis, so that the communal spaces are inside, looking inside out, but you still don't have the glare and direct sunlight hitting you. This is a very specific facade that we've done for one of the clubhouses, wherein you have stone in rods over here, which gives a total different feel, and it's an enveloped facade for thermal comfort. Yeah, this is one of the new buildings that we are building in South Mumbai, about 1 million square feet of residential building. With the changing times and the way people look at the facades and the way they look at the thermal comfort, the normal windows are a passe, and obviously you have everything enclosed. So it's more to do with glass and a few open spaces wherein you have your balconies where you can stand out, and most of it is covered floor to ceiling glass because they want total view of the exterior. A few commercial buildings to start with. One of this which is completed, we did for Lodhas. So a play of a lot of concrete over here as a secondary facade to take care of the sun's angles. Plus the similar thing we have carried forward at the human eye level, similar jali patterns over here, so that it can be appreciated and the lower floors can be taken care of from the direct sunlight. One of the proposed developments in Hyderabad, the mixed-use development, when you have retail, commercial and high-end residential put together. Obviously, the entire north facade over here is full glazing for the commercial building. That's clear glazing. Capital Land, again in Pune. This is for one of the IT giants in Bangalore. So it's a proposed building which is going to come up. Trans Stadium, indoor cum outdoor stadium in Ahmedabad, which has been constructed, inaugurated. So as I said, we are lucky to get very different type of architectural buildings and different projects wherein we can show our expertise. So this is while it was getting constructed and finally done. Babu Jagjivan Ram Research and Training Center. This is done basis a spherical dome. So this is how the construction was done, and it is a combination of ACP plus GRC panels and a bit of terracotta. This is in the making, a proposal for an exhibition center in India. It will be a combination of space frame, glass and metal. This is a football stadium, already done. It's in the tendering stage. The facade would be pre-coated metal frames. I am not getting into details because I want to get into details of this particular project. So this is for Bagmani developers in Bangalore. The building is called Rio. This is about 3 million square feet of building that we did for Google. It is just finished, completed, interior fit out works is going on. So this is the largest interactive intelligent facade executed in the globe. There's about 250,000 square feet of sage glass used over here. So when we started the planning of this building, obviously this is the first rule, you start with climatology. That's taught in architecture. Obviously all the architects sitting here, they know. So we started with the location of the building, how we are going to place the building, what is the sun path. So all those studies were done. Most of the south side, whatever glass we have is intelligent glass. North is all clear glass. And then on the east side, we have a combination of the same. So we don't have any straight edges over here. We wanted to have the flow. So all the edges were chamfered, and there were twin facades created, and the spaces within the twin facades were for communal spaces. I'll show you in the visuals. So you had internal gardens, you had vertical gardens over here. So that's the need of the hour. So it was Google's requirement, and since we do a lot of corporate real estate work also, and we deal with all the millennials, so we know what is the need of the hour for the future and how the new generation thinks, what they want. It's not what you give them, they are going to accept it. So I will not get into the details, probably this is not the platform for that. But yes, keeping all that inside our heads, we started designing from inside out. So having internal vertical connects, internal gardens. So these are the spaces within the two facades, where people can meet, they can have their standalone meetings, gardens connecting over here. So this is the difference between having intelligent glass and having normal glass. The moment you have normal glass, you have all the blinds coming down throughout the year, and your facade starts looking different from what you have envisaged while designing the facade. This is how the entire thing works. I will not get into the technicality, I hardly have time. I'll just run through this. If you want, we can have an offline talk. Yes, it is integrated with the building management system, so you can understand what goes where, if something needs to be changed. It's possible even through an app on your phone. So these are the three different scenarios wherein you have the full clear glass, you have the gradient glass, and this is fully tinted. So having intelligent glass gives you all three options instead of just one plain fully tinted option with roller blinds. This is how it is completed. For Capgemini, I don't have time, the paucity of time, but I will just ask them to run through a video so that the entire project is covered. Thank you. Thank you, everyone.
Thank you, Aiman. That was fascinating. And it's interesting that you touch upon the idea of the skin of the building, right? I don't know if you know, but the skin is the largest organ of a body and can be responsible for everything that goes on inside it. So it's a good thing that we're here for a facades conference today. But what's also interesting is Aiman spoke about climatology and the effect of the sun and daylight on the skin and the facade of a building. And our next speaker talks a lot about that as well, talking about designing with light and solar controls. We have Niraj Borikar, the country manager of Danpal, India. Can you hear me?
Thanks, Mundalini. Good morning, everyone. First of all, I would like to congratulate Zak World of Façades team for this 100th edition. It's a no mean feat, wonderful achievement, and it's pleasure to be here speaking in the 100th edition. So the design of the building facade has evolved considerably, and it has become much more complicated today. With the development of methods of new construction, the stress on energy efficiency, and highly controlled interior environment requirements, and of course the advent of new products, materials, and production methods as well. So in today's architecture, basically we have the conventional ways of designing the building, but we may also look at these three principles in mind when designing the building: the innovation, newness, and novelty. So novelty in this case is to experiment with the new that hasn't been tried yet. Designing with the unconventional materials or the industrial materials used in the domestic spaces. These three principles, when applied to the building facade, ask us to be innovative with our choice of materials and solutions. So it is up to us to use these innovative materials and design buildings in such a way that it offers us the most benefit in terms of natural light and also the solar control. So well-lit daylight spaces, offers lot of benefits in terms of improved productivity and human health, reduction in the energy consumption, and also increased revenue in retail applications. So facade need to bring in both natural light and allow for the solar control. It's totally up to us to design the building. Either we want the light or we want to have a solar control, but to also think about how we can use a glazing system that provides us, optimized daylight and also control the solar factors. So let's talk about, or let's see how we can use these natural daylight in our design systems. Visible light is an electromagnetic radiation spectrum that can be perceived by the human eye, defined between 400 to 700 nanometers between the infrared and ultraviolet rays. The light has three properties: the color, speed, and value. So color itself has three properties as such: the hue, chroma, and value. Hue, known as known majorly by the name of the color, represented by its wavelength. The chroma is nothing but the saturation, which is the intensity and purity of the hue. At hue at its 100% saturation will be most vivid. And of course, the last one is value, the lightness. That is how a dark color is or light a color is. The second property, of course, is the speed of light. In theory, nothing can travel faster than light. It travels 300,000 kilometers per second in vacuum. The first discourse of light was brought up by the Greek scientist Aristotle. The third property is the reflection. Reflection of light depends on the type of surface in use. You can have a specular surface, a glossy surface, or also a diffuse surface. For example, a brick or a concrete wall is a diffuse surface which reflects only about 10 to 20% of light, and that light gets diffused in all directions. Whereas a glossy surface like or a specular surface like glass can reflect 100% of the light in one single direct beam. So let's see how we can use this precious commodity light in our building designs for designing a facade which can offer us natural daylight and solar control. Here are some benefits that are listed out of using the natural daylight inside your buildings while designing the facades. The office workers with windows had more sleep than the workers who did not have windows. That's 46 minutes. The workspaces with good daylight had 3 to 40% gain in productivity. Daylight is the #1 wanted element in workspace design. A well-designed classroom lit with natural daylight had explained a 16% variation in learning. Workers in offices with natural elements such as greenery and daylight had been found to be 15% more creative. The view quality and daylight explained 6% variation in the sick leaves in a workplace study. The natural daylight improves moods, reduces stress, and positively impacts the circadian system functioning. And of course, the daylight also regulates the absorption of vitamin D, serotonin, melatonin. Moving further, how we can use the daylight in the building designs. So the daylight, what we are talking about, the main factor that we need to consider while designing is how much illumination is required inside the building. So this depends on various kinds of building setups and types of use. So you can see that in the warehouse with a large items, the required lux level might be 108. Lux level is a measure by which we quantify the illumination required in the specific areas. Compare that with factory setup with a detailed assembly. Now, this lux level, that is the illumination that is required in such a setup, may shoot up to over 1000 lux. Another example here. So it's important that the facade designs, building designs, which we incorporate, also considers the human-centric designs or design possibilities. The facade with a natural daylight, of course, the main objective is providing the vision, and the light also allows people to perceive information in terms of space, shape, color, dimensions, contrast, etc. But the natural daylight also has a major effect on human biology. So it affects the circadian clock of a human being, and if deprived of daylight for long times, the circadian system may get affected and you tend to feel sick more often. So how do we use this light, and understanding the light temperature that is needed in specific, setups? So basically, well-lit, interiors are the need of the hour, and it is found that the people working close to windows were more productive and more attentive and alert in their working against the people who were working away from the windows and away from the natural light. So color temperature is also an important factor that one needs to take into consideration. The desirable level of color temperature in offices with highly concentrated workstations may be the midday sun, that is 5,500 to 5,800 kelvins. However, this can be certainly reduced, or the color temperature can be dimmed while in the meeting rooms. So you can see the color temperature depending on the source of light. In the middle of the table, you can see the midday sun, which is 5,500 to 5,800 kelvins. The extreme ranges, as you can see, the candle can give us a color temperature of 1,500 Kelvin, and the moonlight, in the night can give us a color temperature of 15,000 to 20,000 kelvins. While bringing in the daylight in the building through facade or glazing, we also have to deal with the challenges of the glare and reflection. The glare and reflection, as much as possible, must be avoided. The reflection can be majorly classified in two types of reflection: the direct or the glare. The direct glare, which is caused by the sun and badly placed lighting elements, whereas the reflected glare is the glare that comes from the table or smooth surfaces around the people working in offices. So we should try and avoid as much as glare that is possible. We can, of course, use the technology in designing the building facades with natural daylight and also for the optimal solar control. So with this advanced simulation software, we can actually get the detailed light maps, which can provide us the information to make informed decisions in terms of the choices available for glazing materials and the systems. Here is an example of a detailed light map. This is the same building which you can see at different time in a day, and how the glazing allowing the daylight during the different types. You can see on the left hand side the lux numbers that is given in a scale, starting from bottom as a lowest level, going up to top as the 10,000 lux. During the midday, we can see that there is a lot of light that is coming in, whereas during the evening times and morning times, we see that there is also less light. So during these times, we may need to provide the additional artificial lighting. These are some examples. The Danpal, as such, is a manufacturer and provider of solutions for various kinds of facade and building envelope applications. So Danpal provides different types of facade systems particular to specific needs in terms of the product as well as the system. So here you can see application of Danpal panel as to create the balanced interior. It's applied in the roofing to bring in the natural daylight during the daytime, at the same time avoid the glare. Another example of facade with the Danpal's proprietary facade systems with different types of panels that are available. It obviously provides the light during the daytime, avoids glare and also the direct sunlight, thereby reduction in heat absorbed by the interiors, and it helps us to reduce the cooling loads on the equipment, air conditioning equipments. Of course, with the natural daylight coming in during the daytime, we also save on the artificial lighting. this nothing but contributes to the energy savings and also the reduction of the carbon emissions. Another example, so you have a different systems, depending on the building type, these systems and the applications can be designed. Now we talked about the daylight as how important it is in the building facade design. At the same time, we also have to ensure that there is enough solar control. So let's look at how we can design, or we can have a system that provides not only the daylight but also provides the solar control and reduction in the heat absorption during the daytime. So you can see it's an example where the glass details are given. These are the details that are taken for the clear white glass. The main factor that we need to deal with while having a control on solar factor is the solar heat gain. So any rays or light that is striking a glazing transmits the light, but along with that also transmits the heat energy. So the example here basically shows that how much of light of 100% is transmitted through the glazing. In this case, of course, it is 74%, and also the addition of 4% of re-radiation and convection heat to the interior environment. So corresponding to the 78% of the light transmission, the corresponding SHGC is 0.7. So Danpal can provide systems which can offer you a good amount of light, but also limit the SHGC to the lowest possible. Of course, this is a specialized panel that is tabularized here, which offers us SHGC as low as 0.17, while the light transmission can be at 10%. We can offer varying range of light transmission and SHGC for different kinds of panel. So here, these kind of panel limits the heat gained by the interior environment. Here are some examples. Basically, this is a building of Welsh National Sailing Academy in UK. The building has been designed in such a way that it provides both natural light and also allow for solar control. The whole building is actually cladded with Danpal panels, translucent panels with the Danpal's proprietary facade system, and of course the roofing system. It provides optimal amount of daylight during the daytime, whereas in the night time, the translucent nature of polycarbonate panels diffuse the light and enhance the aesthetic look. There is another example, the Acne flagship fashion house in South Korea. From the outside, you can see the facade as a light box. While when the visitor enters inside, they can see that there is a large concrete structure inside. It's a dynamic kind of facade, which keeps changing as the light striking the facade changing during the entire day, thereby changing the shapes of the structure. So now, let's see how we can achieve this combination of light and solar control. So we can also use technology along with the available solutions from Danpal in terms of facade and various types of panel that are available. Advanced simulation software provides use of advanced simulation software provides three types of purposes. The propose alternative glazing, produce detailed heat and light map. We have seen one example in the previous slides, and improve the energy efficiency. Here is an example of Danpal's integrated vertical louvers in the facade system. During the daytime, these 3D light panels of Danpal block the the sun rays, most of the sun rays, when the rays are perpendicular to these louvers, and when these rays are at angle, that is in the morning times and in the evening times, is allows for the sun rays to come inside the interior environment. So depending on the sun path, from morning to evening, it will have, this kind of panels will have a variable light transmission of 4 to 25%, and it also blocks the unwanted heat during the midday or afternoons. So this way we can have the light transmission, the maximum light transmission during the morning and evening times, and also reduction in the solar heat gain during the midday sun. Another example, apart from the 3D light, we also have the Danpal panels with the low E finishes. The low E finishes are nothing but the infrared coating that is co-extruded where the panels are manufactured. These types of finish actually blocks the infrared rays and allow for the heat control or solar control, and transmit without affecting the light transmission. So use of this along with the Danpal facade system can allow you to have optimal light transmission and solar control. Another example, the building with different types of facade in two different sites, one with the panels, translucent panel, and other one with a more clear one. Another example of the balanced solar control and LT with the Danpal's facade system. The facade panels are used in combination with glass. Architectonic structure, the building design with a harmonic snow color, allowing the light transmission during the daytime, and in the night time it looks like a light box. One more example with polycarbonate panels of Danpal with glass. So you can use different kinds of colors and create different aesthetics. Indoor swimming pool wherein the facade has been used as a Danpal panel, allowing for the natural daylight, and also in the roofing you can use these Danpal panels. That's it. Welcome to the light architecture. Thank you.
Thank you, Niraj. I think it's interesting that you talk about light as not artificial or intentional light, but more as daylighting, which is an important part of the building system, which also leads us to the next presentation, which is titled How the Facade Industry Will Save the World. I'm very curious to hear what we're going to be hearing about next. I'd like to call upon the stage Russell Cole, who is the Director of Facades for Arab in the UK.
Great, thank you. Good morning, everybody. It's good to be back, and happy 100th to Zak, and thank you for getting me here today. Let's see if we get the presentation up. It's on its way. Here we go. Okay. Oh, the font changed. Oh well, never mind. Let's hope there aren't any other bugs like that. I'm not new to Mumbai, though some of you know me very well. I first worked in Mumbai in 2004. I took this, Beau Monde was one of the first projects we finished. And as you can tell, this is an old photo because now I had trouble spotting Beau Monde against the forest of tall towers around it. I went to the UK back in 2014, but I've stayed working a little bit in the Indian market. This is me up against the Statue of Unity. One of the main reasons for coming back and re-engaging with India is I was, about 18 months ago, asked to help grow the team for Arab Facades in India. So I'd like to introduce you to Hitesha, who is based here, and we're busily growing the team and getting new projects. Arab is, for those of you who don't know us, is a very large multidisciplinary engineering consultancy and architectural consultancy, all sorts of different types of design. And we're bringing a lot of that to the Mumbai office we're up to about, we've got about 50 people in Mumbai, and we've got offices also in Delhi and Bangalore. So facades, they shape our homes, our cities, they give us our streetscapes, but they also provide the boundary between inside and outside, act as a filter, letting things across that boundary. They give the first impressions of our buildings, so they're very important in that, and so therefore they can bring delight to those outside of it. But for many of us in this room, it is also an industry and hopefully a career. So because facades are influential, they can have a big impact on our environment. And I put it to you this morning that we can have a big part in saving the world, partly through what we do and how we build, but also how we engage people in conversations and drive towards better solutions. So I want to think about not just climate change and broad ecology, but also about how we live and how we have to work within the finite resources of our planet. There's climate targets that we need to meet. The climate crisis is real. We're all seeing big changes. There's ecological damage happening, pollution, extraction, things that can't be reversed. But we need to strive to make a better place. Personally, I believe that technology and knowledge will solve these problems. And in all of this, we all have to develop as humans and as societies. And I like to think about this direction of travel, that we're moving away from very conventional to a more green and sustainable solutions. But really, we need to have designs and buildings which are more restorative and regenerating the earth. The UN Sustainability Goals are a great framework to think about our activities as designers, as builders, and as an industry. And in our space, the two that stand out as immediately applicable are responsible consumption and climate action. These make us good designers and builders, if we think about those. But I would also invite you at some time to look at the broader goals and think about how we interact with society and can have a wider influence as well. If you look at this, obviously the ones I've mentioned are focused here on the bottom right for what you're seeing. But I would say as an industry, we can think about some of these other ones around people's growth and careers and equality. And they should always be in our minds as we make our decisions. I think a lot of the basis of what I'm saying today is to avoid bad design, dead ends, creation of waste. So this is a very good framework to think about it a bit, which is to be, I like this one in the middle here, build clever, build efficiently, but also minimize waste. So I want to take you through some key steps to save the world. Quite a few steps there, so I'm afraid this is going to be a very quick tour. So build well, right? So this is the most fundamental one. Build for a durable solution. If we get it wrong, it means the building has a short life. It means that all that investment of effort and resources has been less effective than it could be. We should always we must meet the design life, think about that when we're designing, and make a valuable asset. So, the well-built facade is self-evident, but how often do we actually achieve this where we don't get leaks or molds, things aren't failing, nothing's falling, there's no air leaks, and it's just a very safe solution. So it's very fundamental, but we really, really must get to this every single time we put a new facade on a building. And don't forget to think about fire safety. Hugely important, and coming from the UK, you'll all understand why it's so prominent in my thinking. Here's a crazy example in some regards, but this is sort of like a very long-term thinking by the UK government. They built this office here for the members of Parliament, And I think the design life was 100 years. It might have been more than that. So that switched the decision to go to a bronze facade over aluminium. So, you know, the detailing and thinking about how that facade can be maintained over 100 years really focuses your mind. Accuracy in what we do is really important. Bad workmanship, loss of value from things getting damaged on site, put up in the wrong place, it compromises the facade's performance. So we have to be accurate and good in what we do. Because that waste, 40% of waste comes from the building industry. I don't know what the figures are for Mumbai, but I would guess they're very similar around the world. So we can save resources if we just cut down on waste and get things right first time. And we also need to move to not downcycling things, throwing things into a tip or waste there, but look for ways to reuse things, repurpose them and recycle. And I can talk about that a bit better. But here, as an example of something I think has been built fairly well recently, these two floors are our new office space in London, 80 Charlotte Street. Just won it's winning quite a few awards, BCO, British Chamber of Offices, I think it is. Just got the Best Commercial Space Award for this year. A lot of good design has gone into that, very high performance. But in terms of the facades, we had to design well and think it all through carefully. So it's also a low carbon solution. You can see here the typical panel is a precast facade with glazing already installed as it was erected. It had to be all carefully designed through. That's all part of getting it right. Lots of analysis, careful consideration of all of the details, thinking about how it all goes together. How do you control differential movements? How do you construct it? How do you make it look like it's another part of the facade, which is brickwork? How do you make that look like a full masonry facade, even though it's actually come as a series of precast units? Care and attention to detailing, and also care and attention to finishes and selection of materials. We're all very familiar, I think, now at trying to reduce energy consumption. Absolutely vital. We need to reduce the future consumption of energy. Clean energy streams are a long way away, and obviously energy is a focus. So if we can reduce the operational energy in the building, we reduce operational carbon, we reduce climate change. So energy efficiency, reducing loads through insulation or shading. I'm a big advocate of passive design, and perhaps more of our facades need to use their surfaces to generate renewable energy. There are many, many tools for doing this well. Here's an example another UK example in Google headquarters, which is under construction. This building has a north-south access, which means it has long facades facing east and west. That creates a big challenge because Google wanted an openness to their space. They didn't want blinds coming down too often. So Arup developed a concept where we had a serrated facade type, which would reduce the amount of direct solar coming into that space, and made the effectiveness of the glass coatings we had higher. But of course, there was still an architectural decision to make. So we wrote a little tool for the architect to use where they could distribute these different modules across the facade composition and check that they hit the energy target. So that was a way that we could set up a design conversation for the architects to have. And here it is under construction. I think this picture is about 6 months old, but I think it's going towards completion next year. And lower ecological impact, right? So again, climate change and waste I've already talked about, but we also need to think about how we can degrade the environment through where we pull resources out of the ground to create our materials, the pollutions our systems create. But of course, the big one at the moment is carbon, and those of you who saw me in Delhi will know that in the UK now, we're very passionate about checking whole life carbon on buildings. Looking at embodied carbon, you know, you have many definitions here. There's the idea of what the suppliers and the manufacturers can, how much carbon they create in getting what we call cradle to gate, the factory gate that is. And then you add more carbon to the pile when you transport those materials and panels and systems to site and erect them, which gives you a cradle to practical completion, which is the one that all of us on our projects can control by making good decisions. And then you have the whole life carbon when you start to add in the operational and maintenance carbon and think about what happens when you demolish the building, with of course the loops back to either reuse, recycle or waste. In the UK, we're very familiar now with this table, and we've just, Arup has been one of the authors of a new methodology for calculated embodied carbon in facades. So please look that up. It's with the CWCT, which I'll talk about in a minute. It's driving material choice very, all the time. Aluminium is very carbon intensive. So more materials are being looked at in the palette, but how to use them efficiently and effectively. You can think of all the different sorts of things like stone, which has a very low embodied carbon, but a big ecological impact. GRC, stainless steel, bronze and terracotta. We all need to know how all of those compare on a typical facade. What we're often doing, and it took me a while to understand this slide from my colleagues, but this is looking at how much carbon per square meter is in a typical panel for a project. And then what happens if you change the spandrel material, C and B, and you look at the impact there. So there's probably a bottom line here, which is the embodied carbon in the aluminium frame and the glass, but then you can see the difference of different types of materials. And that is what we need to do now in most projects in the central London to kick off decisions about what the facade composition will be. A key concept is carbon payback. So this particular issue here was kicked off by thinking about whether in London it's appropriate to use triple glazing or double glazing. One will save energy, triple glazing will save heating energy in the building, but is it worth the investment of the extra carbon of putting on the piece of glass and the extra seals? For a hot climate like Mumbai, the question is it worth putting a sunshade on the outside of the building? That sunshade has carbon, it reduces the shading coefficient, but is the carbon saved in the operation of the building bigger than or smaller than the embodied carbon of that sunshade? If you want to know more about this, please, and it's a fairly long presentation, but I think if you go to Zak, you can find a recording of what I presented in Delhi back in May. But as I said, it's not just carbon. We do need to think about the impact on the environment. There's obviously the big holes in the ground we create when we get hold of stone and aggregate and aluminium. And some of our materials have pollutants, so to extract the bauxite, you potentially get other chemicals being into threatening water supplies, etc. So we have to think about all of those material impacts all the way around our construction cycle. And that leads me on to designing for reuse and recycling. So I think we need to anticipate the end of life of our buildings and we have to think about reuse and recycling. What we've found is that you can design for disassembly. It also helps if you've whether you've installed it in a prefabricated modular way, but we also need lots of information about what materials are they, where did they come from, what are their main properties, but also where they are on the building. This is all about moving towards a circular economy. The idea that as far as often we try to recycle or reuse materials, the shorter these cycles are, keeping it in place is a much better idea than even having to reuse it or refurbish it or recycle. And now, again, in central London, planners are challenging us about, is it actually necessary to demolish a building? Can it be adapted? Can part of it be retained? And there's a whole series of stories about that, and I'll tell you one in a minute. But if we go back to that example of different materials, the comparison between materials changes if you can be confident that they can be recycled at the end of use. We need to think of buildings as a material bank. So when you're demolishing, when you get hold of a site with an existing building on it, what's in that building? What can you take away that could be recycled, reused? It all just shouldn't be rubble that goes to the local tip or is used for landfill or something. So there's lots of different uses, but you need to know about what's in there. So we're beginning to see clients asking for a lot of information at completion about what's their building made of. Where are the birth certificates for all of the material systems and components of their building, so that, if possible, whether it's a replacement at 20-year life or something like that, they can confidently say what to do with it. Arup are doing a lot of work at the moment on trying to complete that circle. So even architectural glass often isn't recycled. If it does get recycled, it gets thrown in with bottles and containers, which is actually a downgrading of the cutlet used for the glass production. So the key here is you need to create an industry that is focused on recycling the glass and how to get good quality glass back into architectural glass supply. And as I said, you can go to a report that Arup have produced, and we're still trying to take that further and actually bring products and support for this into the UK market and elsewhere. One example where we decided not to go for the demolition and rebuild is 1 Triton Square. This is not very far from the Arup office in London on the Euston Road. This is a Arup Associates building. It was completed in 1998, but the intention was to extend it upwards, fill in some of the very large atrium in the middle, actually double its gross floor area. But the feeling was it was too new for it to be demolished and all of the new build materials come to site. So everybody on that project worked extremely hard to find value in what was there, to retain what we could, to reuse as much as possible, but also make the future building reusable. This building has a double skin facade, so we had to do some analysis of it to find out what do we do? What do we keep in place, never demolish? What do we take off, store, and put back on the building? The screen had to change its level, for instance. And what did we remove and replace? So one of the key decisions that was made was that the existing aluminium window frame, curtain wall framing system was really in very good condition and very suitable. So we actually refurbished 3,500 square meters of unitized curtain wall. It saved 1,270 tons of carbon, and it made a huge cost saving, and it added to the whole building having about half the new embodied carbon of a new build building. So a very dramatic result, which is, again, winning a lot of awards and recognition in the UK. So the key is, though, you've got to understand the materials, you've got to understand the supply chain where that facade system came from. Things have got to be accessible, but most important, you've got to have the data. So in this case, we were very lucky that the original builders were Schelderbau. They were still in operation. They had the records from 1998, and they were able to give it to their sister company, Gartner, who were then responsible for refurbishing these curtain wall panels. So a very dramatic example. We need to design our buildings for wellness. We need to think about people. We've just heard about natural daylight, which is great because it saves me saying a few things. But if we think about a person in the space, we can do a lot of studies to think about the daylight entering the space, whether they need heating, whether they need cooling, how to make the person nominally comfortable. But even if we do that, we still get things like sick building syndrome and a loss of productivity. So how is it? What are the factors we need to think about in the design of facades that make people well and productive and effective? So it's beyond comfort. It's about stimulation and delight, as well as people feeling fit, having fewer sick days, etc. It's actually a very complex issue. Again, my presentation in Delhi talked about this in a bit more detail, but in short, we believe it's natural daylight, it's about the circadian rhythms, managing glare, saving energy, but we also have done some research, which I thought, next, sorry. So, you know, there are things about that, control over overheating, but adaptability is very important. People need to be able to either move to a comfortable desk or be comfortable in their desk that's near the facade. So it's how do you get that right? How do you account for different people's own metabolisms and comfort levels? Which draws you into a more user-centric design. People-based design, a lot of it is also about thinking about the end user of a building and thinking about the information they need to run the building, but also that information about how to maintain it effectively, how the original concepts are carried through to operation, and how to deal with the end of life. So this was a piece of research we did in the UK with Perma and the University of Cambridge. We had a PhD where we worked and monitored people's their wellness, their productivity, how comfortable they felt. This was a laboratory they created where they changed the glass, they changed the blinds, they did lots of different things, and people who were not part of the study were invited to go and work in this space so they could be monitored. We also brought the equipment to our office, and the intention was that for a year we were going to work with all these sensors around us, and we would see how the different conditions in the office impacted people's wellness and productivity. Unfortunately, we ran into the COVID lockdowns, but that ended up giving one very remarkable result. So people had a certain productivity when they were in the office, but then when they were in their own spaces working from home, their wellness and productivity went up dramatically. And that just goes down to giving a solid message about that adaptability, having a space to suit your own needs. The other big takeaway has been around blind usage and how important it is that in an office, you view the blinds as an active element of your space and your comfort. So that's why I tend to, if I come into an office and the sun's not on the facade, I'll go and put all the blinds up, let in all that good natural daylight. It's very easy to sit in a space, blinds down the whole time, and actually you're not using the space in the best way possible. So those were the two key outcomes, but we're still extracting more information there. And the final one is to think of your facade as an enduring asset. you know, like the Portcullis House project, it's got to be a successful building. It's got to have a connection to its community. It's got to be appreciated in the streetscape and by passers-by and those living in it. And so you need to be a little bit careful about not being too fashionable or using materials that are too exotic, so that design doesn't look dated and it maintains its value in the broadest sense. So this is one about thinking about weathering. This is a building which we've had to refurbish because, mostly because of combustibility. But this was a building from, I think it was about 2010, maybe a little bit earlier. Timber facade. Sometimes they got the detailing right, and sometimes they got the detailing wrong. Maybe it was what the architect intended, possibly was, but I could take you around that building and point out places where the detailing just really didn't give a uniform weathering of that surface. So the way that, you know, if you go to very classical architecture, people think carefully about detailing, etc. And we've lost that in some of our modern buildings. And this is the danger of unique products. This is the building on the top is the Light Box in Woking, my hometown at the moment. And you can see here they have this lovely architectural scheme, but you can see the missing teeth, where they've used a slightly exotic material, but haven't gone to the trouble of finding out exactly what coating of anodizing they had on that replacement panel. And similarly here, this is a building in Singapore, where they used a very unusual pink reflective glass, which they just can't replace anymore because that product has gone out of production. But the other end of the scale is something like 1 Finsbury Avenue. This is in the Broadgate development in central London. This was completed in 1998, an Arup Associates project, and it was the youngest Grade 2 listed building in London because it was recognised for its the quality of the construction of its facade. But it needed, again, like Triton Square, it was a bit inefficient. How could it be refurbished? So we were engaged to look at the facade, and we were expected, the client, British Land, was expecting us to go away and say, right, how to build a carbon copy of the original facade, but with modern performance. But we got into it, we understood how it worked, we looked in carefully at its effectiveness of each of the components, did some studies, and actually all credit to the original builders and designers, but we found out that to bring it up to the current energy standards, all we needed to do was change the glass, which was appropriate for a building that was 30 years old. Right? So this is why, you know, designing and building well and thinking ahead about what the future targets are going to be and anticipating them saves a lot of wastage in the future. And here's another project we've just completed. I forgot to put the slide in of King Charles reopening the Burrell Collection in Glasgow, which happened yesterday. It was 37 years old. It's in Scotland. It's got the highest level of conservation on it, but it had problems. The building was too hot. It was difficult to control. There were leaks. It wasn't performing. So it was replanned and refurbished, and a lot of new improvements were added to it. And its energy effectiveness, if you know EPCs, moved from G to C. But one of the two good stories from the facade was about it allowed my colleague Graham de Brincat to apply his glass recycling report in action, and glass from that building was recycled and formed the new part of the new units, saving a lot of carbon in the process as well as landfill. But also, we were able to take the original aluminium framing and keep it. Now, it was a bit of a fight because the subcontractors just wanted to put new. It's like, no. You've got to keep the old one. All we had to do to fit the new double glazed unit was to put in a thermal break, and that will be good for another 25, 30 years. Really important to try and do that. So, because it was also Fortunately, it was a conservation building, so that helped us make the argument, but it just saved so much carbon by doing that. So just to finish off, I want to whiz through how do we get there? What supports this ascendance to better buildings that can save the world? So obviously, knowledge, skills, and experience are hugely important. In the 18 years I've been coming to Mumbai, I have seen huge strides in the quality and caliber of the facade industry in India. And all of the facade industries around the world are all different in their levels of development, and there's a lot we can all learn from each other there. But for me, I think there is an issue about knowledge, and I could show this slide very happily in the UK, so don't think I'm just talking about this particular market. You know, there are so many people I interview that don't understand these basic concepts, which I believe are so vital for anyone who's actually technically engaged with the design, fabrication, and installation of facades. Load paths, tolerances, movement, fire safety. There's rules around unitized curtain walls, safe by design, all of those sorts of things. So another strut in my scaffold is education. We need to create an education environment. I think it's severely lacking all around the world. In the UK, we've got a new thing coming in where we've got to demonstrate our competence to work on high-rise buildings, but where do people get educated to gain that competence or to demonstrate to others that they're competent to design? So we need to actually work with some universities to create courses, technical colleges, etc. We also have a duty as the facade industry to educate architects, other engineering disciplines, cost consultants about what makes a facade work and what's ineffective. Our clients, of course, need to learn and go on the journeys with us, and we also need to educate the authorities, which then brings me to regulations and standards. There's gaps in coverage all over the world. Do you have a few international standards you rely on? Do you have local ones? But you've got to know how to apply an international standard locally. And when you are writing a local code, you've got to make sure you've got the right people in the room and not too many people who are outside the field or too academic. That leads to things like industry guidance, procurement standards. So the industry can help itself. They can write guides. People can club together to work out their own guidance to flesh out and fill in the gaps between regulation. I would advocate that if it isn't already working on it, that you have a national specification system that really helps the whole industry come together and work towards common goals. And you need to have industry bodies and create a sense of professionalism. Education and career development I've already talked about, but these bodies can be a point of focus. They can be learned societies where members exchange their views and knowledge, like we're doing today, but also we can be recognised by the community and when needed be called on to give advice to owners, to government. So I'm a board member of the SFE, the Society of Facade Engineering. I can help you all find how to apply for membership. We're creating a series of regional hubs around the world, and it would be great to see a hub in Mumbai and in other cities in India. I think it gives you a community to engage in. It's for individuals, so it's for you to follow through your career. If you're interested in becoming chartered in connection with CIBSE, it gives you a route to getting a CEng qualification. It's closely tied with the Centre for Window and Cladding Technology. If you don't know this organisation, please go and take a look. There are, I think, now about 120 very valuable technical notes. They also have I think it's a guidance for systemised building envelope design, as well as fire information. So very useful. And they are part of the wider European Facade Network. So again, another resource that's worth looking at. And most of all, we have to have a stable and successful industry. I actually, in the UK, I say the expected life of a facade subcontractor is about 10 years. There are exceptions, in both directions, but this isn't good enough. People have to have a safe place to work and have a career, because these companies and the industry as a whole can drive positive change, and we can build better buildings and facades. So we can make a difference. We've got a lot to do, but it's a realistic ambition, and it's everyone's future. So thank you.
Thank you, Russell. It's heartening to see that one of the largest companies in the world that actually assists and aids building can stand up here and say, don't build. I think that's a lot of food for thought for all of us. And if you must, then you must build responsibly. I'm not going to take much time. I'm going to introduce our next speaker, Arun Madappallath. He is the General Manager of Search Ferrari Group in South Asia, and we'll be talking about face, function, fashion, and safety.
Thank you. Good morning, everyone. First of all, congratulations to Zak for their 100th edition, and I wish them all success. I'm Arun Madappallath, General Manager of Search Ferrari South Asia. Search Ferrari Group is a manufacturer of flexible composite materials for different applications. So here we are talking about the facade applications. So basically, facade is a face of the building, fashion, you can create fashion, three-dimensional structures, and at the same time it's functional beside the fire compliance what you are offering. So Search Ferrari Group, a small video on our group and our range of applications and products. Okay, so as I explained you, we are manufacturer of flexible composite material for different applications. We are present worldwide, and our 2021 key figures, we have 80 country representation, more than 1,000 employees working with a turnover of around 300 million euro. 4 key markets we are present. It's tensile architecture. So tensile roofs are very common nowadays in India as well. So facade comes under tensile architecture. Beside that, we have acoustic fabric, solar protection fabric, internal, external blinds, then modular structure, then furniture and yachting applications. So wide range of 4 key markets we are present across the globe. So in fabric membrane, I'll be covering 4 chapters, which is divided into design. First I go to the design identity, which is fashion of the building. Okay, so it's a 3-dimensional modeling possible, 3D envelopes possible in facade. So this is one of the projects we have done in Coimbatore, PSG University in Chennai, done with our system, where it is you have a 3-dimensional structure possibilities. This is a project in Japan, a very interesting project And you can see, the facade represents the highlight of the building, which is really unique. And in different directions, you can see the appearance of the facade. The light plays an important role in this. Another example of three-dimensional project, and this is in Germany, Airbus project, again with three-dimensional, and you can see the interior view as well. This is one of the prestigious projects we have completed for Thyssen Group. It's a tall tower for testing the elevators. It's a 246-meter tall tower. The whole building is wrapped with fabric. It's a PTFE glass fiber yarn fabric. Very interesting project. So what dimensional stability can take, for such kind of projects. Another example. This is a multi-story car park wherein, it's a primary skin. You don't have to be, a solid membrane here. So facade, it has a ventilation as well as it serves the purpose. Then the lighting. Lighting also plays an important role in your facade applications. So this is a stadium, a snakeskin shaped design stadium in Brazil, wherein during the night time you can see with the lights, the aesthetic of the building is complete, the stadium has completely changed with the lighting. So lighting also plays an important role in the fashion of the facade. This is another example in Netherlands, wherein, during the night time with the different LED lights projection, the building completely looks different and attractive. These are all few examples of lighting systems. And this is another interesting application wherein for a convention center, when there is a function, you can do the graphic projection of the complete facade of the building. And this is also a membrane which is done in Mysore. Then printing possibilities are there. You can do different design printing or the company logo or highlight to the product. You can have the printing possibilities as well. This is a multi-story car park, again, which contributes to the nature as well. It's a combination, wherein the graphic projection has been done in that way. Another project example of printing, customized graphing. Next is visual comfort and glare control. This is very important. During the daytime, you should have the comfortable. At the same time, your visibility towards outside is not blocking. So you can see, even with a 30% perforation of mesh, you can see a clear visibility to the outside of the building. At the same time, glare control and comfortable level inside the building is protected. Another example, wherein office, there is no glare, because to use your laptops and computers, the glare should not affect your, the working, and this membrane will give you a clear glare protection for your environment-friendly working. Another example. Then the next subject is solar thermal comfort, solar control, and energy saving. This is a key important factor. So being a secondary membrane, what functions it can give to your, because we spend 90% of our time inside the building during the work or during this thing. So glare control can be managed, transparency, you have a good visibility towards outside, same time natural light coming inside, and the privacy is also protected during daytime. So mostly, if you compare, if you're using a membrane internally and externally, you will have always better, because the heat is blocked. If you're using a membrane exterior, the heat is blocked outside of the building, okay? And then you will have a very good comfort level. 80% of the heat, up to 80% of the heat is blocked outside, so you will have a good comfort, inside the building. Whereas if you're using a glass and a blinds external, definitely internal, then you definitely, the amount of heat coming is, it's much higher than the using the fabric externally. We have a simulation tool wherein you can select the city and type of building and glazing percentage and the glazing type, and we have different range of fabrics in our collection, whether you're using internally or externally, and the color of the fabric, and then you will get all the analysis of your, the energy for your building as per your projects. So as you can see, reduction of heat is about 48.4% when you use the fabric externally. So you will get all analysis. This simulation tool is open to everyone. We can share the details, whoever is interested. So complete report you will get the fabric analysis when you are using this tool. And energy savings, which I was explaining, if you are using a membrane inside, in this case study, we have a 50% AC power reduction when you are using the membrane inside. So from 68,136 kilowatt per hour, it has come to 33,530, which is really a very good saving in this. This is another good example for more than 15 years now, the building. Okay, so this was initially the project, and in 2005, and now presently, after covering the membrane, you know, the energy saving is more than around $700,000 in energy saving over the 15 years, which is really a good money, and you can get your ROI in just 3 years. Fire performance, another important factor. So we have two types of fabric. One is PVC, PVT coated fabric, and PTFE coated glass fabric. Okay, so PVC coated fabric is a fire retardant fabric. It catches the fire, but it's a self-extinguishing. It has got self-extinguishing property, and the fire stops by itself, and there are no drops, which is very important. Whereas in PTFE coated fiberglass, it's a fire-resistant fabric. Up to 300 to 350 degrees, it can resist the fire, the heat. So non-combustible, so two options available with us in terms of fire. So we comply all international standards in fire properties. So few projects example wherein fire rating stands an important point in their projects. Okay, and this is just a small comparison of a video on the fire. So this is absolutely non-combustible fabric, wherein the first one, no fire will catch the fabric, it becomes black and it becomes powder. And this is also a fire retardant fabric, wherein
you too can now
fire
rely on
can be
maximum
controlled
fire safety for
Again,
all
the
of your
third one
facade
also
project.
resistant, but the last one is really a non-fire retardant materials. That's why you can see a lot of this thing. Okay, the other important subject or interesting subject is renovation of the building, because we have a lot of old buildings across the world, wherein you can use fabric solution to make the building much more aesthetic and functional. So few examples I am going to present you. So you can see before this was a building, and after putting panels of facades, you can see the difference. The complete aesthetic of the building has been changed, and good possibility to use membrane to renovate your building. Another building, so this is in again Netherlands. So before the building, and the PTFE mesh fabric membrane has been used to cover, black color membrane fabric has been used to cover the whole, almost the building. And it gives you a clear differentiation in project before and after use. And our membranes are micro perforated. Okay, so it has got up to 30% to 50% openness factor we have, unlike the macro perforated materials. Okay, so you can see the visibility towards outside if you are using micro perforated fabric is much superior than using the macro perforated fabric. A few project example to show that perforation. Then I'll go to our range of fabrics. Okay, so Ferrari fabrics, basically, we are very unique technology we have. It's a pre-contained technology. While coating the fabric, the yarns are stretched in both direction in warp and weft, so that the dimension stability of the fabric remains same in both direction. That is a unique advantage using pre-contained material from Search Ferrari range. We have different range of fabric in PVC, PVDF coated, as well as in glass fiber mesh fabrics. So this is front side PVDF, which is very common and commonly widely used across the world, this product. A 30% openness factor, and we have 17 colors of palettes of colors in this range. Then we have front side 371, which is basically a printable fabric, which is used across India. And then glass fiber mesh, non-combustible material. We have 52% openness factor and 21% openness factor in this range. And a few of the examples we have done using these mesh fabrics. PTFE, a very high performance fabric in terms of fire, in terms of longevity, in terms of maintenance, in terms of dimensional stability, and all resistant chemical and soil resistant fabrics, which is a very prominent fabrics across the globe. A long experience in terms of the initial projects. It can exceed 30 years, and there are 50 years case studies as well about this membrane. Burj Al Arab, 25 years old. You can see that the white color on the front side of the fabric is glass fiber PTFE solid membrane, and it is lasting for more than 20 years, and still it is very good and unique in its performance. So a lot of dust storms, sandstorms, it has withstand over the years of 20 years, 25 years, and still very strong. And lighting possibilities in the fabric. Okay, STFE is a new range of fabric which has been, innovated by Search Ferrari Group. A very unique product with 55% transparent material, 50% light can come inside, and a design life of 20 years plus, 25 years plus, and we are doing some projects in India as well with this fabric. Okay, so good dimensional stability, type 2 material, lightweight, big span possibilities using these fabrics. This is Istanbul airport done with this fabric. You can see the visibility with this fabric, and it can be used in facade applications as well. Tensioning system. So for facade textile in India, okay, we are the distributors for the Facade Textile International, who are manufacturers of profiles for the fabric facade system. So we have taken this dealership, and we are distributing and giving solution together with the fabric and the profiles as well. So different types of profiles possibilities we can share with you in our booth. Green vision, so a lot of compliance. Some of the key projects executed with this profiles, just to show you. It's KIT University in Bhubaneswar is done with this profile. Okay, so a small video on the tensioning system. The complete building is wrapped with fabric. For a multi-story car park as a primary skin. Yeah, so I'll just running out of time, so I'll go quickly. So we have other tensioning system as well for the facade, applications, free-form, frame, monolithic, different systems possibility across the market. Okay, and Search Ferrari now, we are also supporting the architects, clients, customers in terms of design and engineering. Okay, this is just a three-dimensional engineering, three-dimensional rendering done by by us for a project. So these type of facilities also we provide to our clients. So you just see a few examples of rendering here, and we also do the complete analysis, engineering analysis of the membrane, and we give all inputs from our side for if you have a project, completely giving the solution, end-to-end solution for the facade applications. Okay, so this is there, and now I'll cover the iconic projects done by Ferrari. It's the Qatar Stadium in Qatar, the FIFA World Cup, which is going to happen from next month. The whole roof and the facade is covered with Search Ferrari group of membranes, including the ceiling. You can see a different type of ceiling in this project, which is specially designed for this project and been supplied by Search Ferrari group. It's another project. You can see the whole facade is covered with fabric, Search Ferrari Vazrak fabric. Mesh metallic reference. again for the stadium, again stadium, Qatar Stadium. So we have done 5 stadiums in Qatar for this World Cup. This is for the Dubai Expo projects. We have done more than 15 projects for the Dubai Expo projects, especially with the mesh fabrics facade. So many iconic projects has been executed across the world by Search Ferrari Group. Design possibilities, good design quality, dynamic facades. And just a few Indian project reference which we have executed. This is PSG College in Coimbatore, done by Duo Engineering from Chennai, using our profile, FTI profiles. You can see, the project is really come out very well and appreciated by, across the stakeholders. Another project, this was done maybe 4 years back, Esha Boutique Hotel in Mysore, done by architect Dinesh Verma from Bangalore. He has got an award for this project. It's a fish fin skin module has been created for this project. A day-night appearance and very well executed. Kids College in Bhubaneswar. Again, it's a combination. It's a combination of a plain membrane as well as a mesh membrane here. This is Nagpur Metro. Solid membrane and mesh membrane has been used. This is near the elevators and or the whole building. So we are doing roughly 6 stations in Nagpur with this kind of design. PVR, this is Eva Mall in Vadodara, done by a McCoy architectural system. Mr. Ajay Atria is here. So with Ajay Atria, we are working across India for different types of projects. And the biggest projects we are going to execute is, IICC Dwaraka, which is 10,000 square meter job of complete facade of the convention center execution happening by McCoy architectural system. So this is day-night appearance of that project. Another simple facade, plain facade system possibility. This is not a facade, but it's a facade mesh membrane, so I thought I will highlight here. It's an inverted cone for DLF Chennai, done by Technospan. And this is also again Nagpur Metro with a different design, and this is Hyderabad Metro. This is a baby cloud, done by our company in Shadeflex in Bangalore. It's a combination again, on the roof solid membrane, and on the facade it's a mesh membrane. So you can see it's a nice project, come out completely wrapped up with fabric and solid and mesh combination. So during the night you can see recreation center beauty. We are also going to introduce a new system for the facade cleaning, especially for the membrane. It's called Manta. The R&D has been done and the first prototype has been tested. And next year the launch plan is going to happen. And more details can be shared later on about this system. It's really going to be a change in the cleaning system of the membrane for the facade. Other possibilities of cleaning also possible. With brush, a simple brush. And we have EPD, Environment Product Declaration, for the whole membrane for Ferrari. Green Guard certified. It's certified for gold standard for chemical emissions of building materials, finishes and furnishing. Then we have LEED front side range, we have the LEED certifications. And yes, that's all. Phase, fashion, and function of your building. We are there here to support you in terms of whatever you have requirement. We have a small booth outside. You're all welcome to see more details we can share from there. Thank you very much.
Thank you, Arun. It's interesting to see that there's so many options and innovations available for us out there. I request you to stick around for a bit. Before we break out for our first networking session, I would like to call back the speakers and for a small token of our appreciation on behalf of Zak. So if we can have on stage Sam Robinson from TechNow to give away the mementos, please. And could I also have with us Esha Sharma, Aiman Ansari. Esha, can we have you on stage? Aiman, I'm going to request you to just stay here for a moment, yeah, please. Can we get Niraj Borikar, please? Arun, please. And a quick photograph before we can run off for coffee. I would like to remind you all that we've got a lot of stalls outside, so please feel free to have a look around and do question the speakers today. There have been some very interesting presentations, and it would be good to get into conversation with each of them. We're going to have our next speaker on with us, talking about the future of facades, design process disruptors, innovative materials, and disruptive construction technologies by Mathieu Meur. I hope I got that right, who is the director of DP Facades. Mathieu.
Hi, everyone. Don't know if we should wait another minute or so for more people to sit, or should we just start? All right, let's just start anyway, out of respect for those who are on time. So, future trends in facade design, I actually prepared a presentation or gave a presentation very similar to this one in Zak Dubai 2018. And I was trying to look 5 years ahead, which happens to be roughly now. So I've updated it, and some things have changed, some things have not changed, so some things are still out there, and there are a bunch of new things that I will be adding, which are probably the new future. So I'm not looking at the future as in some airy-fairy 20, 30, 40 years from now. I think that's great to do, but so many things change, and they change so fast in some respects. So I'm only looking in 5 to 10 years. Let's be modest in our predictions. So I'll like to look at what has changed over the years, and I'll just do a quick roundup of other industries. So in 1918, this is what a car would look like, modern car, best in class. And, you know, today, I'm not a big BMW fan, but anyway, this is probably one of the more advanced, best kind of cars you can get today, electric cars, very fast, all the options and all that. A lot has changed in the automotive industry in 100 years, sorry, and probably we can say the same thing about the aviation industry, you know, 1918, the beginnings of aviation, and then today we have, you know, this type of plane. So again, a world of difference in roughly 100 years. And this was the computer that controlled the London air traffic in 1968. So don't even talk about computers before that time. And today, this, which a few of us have, is actually something like 100 or 1,000 times more powerful than this. And this is the type of computer they also use to send people to the moon. So 50 years roughly, a lot has changed, a tremendous change. And now let's look at the construction industry. You know, we talk about the future, so let's look at the past for a second. This was roughly 1920, and this is probably any construction site you see today. Of course, we have precast, of course, we have other technologies, but concrete is still pretty much done the same way it was done back then. And a funny one, I think everyone's seen that photo many, many times. 1932, as far as I can tell, was the date it was taken, and they took that photo as a bit of a joke, but you know, steel structure, still done. I think the difference is the PPE and the lunch boxes are different, but other than that, it's pretty much the same. Now, let's look at what we can do when we are designing facades and how we can actually update that design process and later on the construction process and the materials. So BIM, you know, it's interesting if you look at the little brochure, the little leaflet on your tables, you will see a note by one of the sponsors, by TechNow, that talks about BIM and how it's not the future, it's today. And I think for us, as within the DP group, whether the client asks for it or not, all our projects are done in BIM anyway. It's a de facto thing. And the facade team has developed this parametric BIM set of families where basically you can just draw the outline of the facade. It builds up the unitized curtain wall panels. You can make any sort of adjustments you want. And based on the floor-to-floor height and the wind load, which can be set as parameters, it will actually size up the mullions and transoms automatically. And the same will go for sunshades, for louvers, for any other element. So we've set a number of families in Revit that basically when you change certain parameters like the size, the length, the height, and whatever, the details will be updated automatically, the size, the different components are automatically updated, which is actually a great time saver. It's extremely efficient, extremely fast, and it's a very robust way and efficient way of designing facades. So it's something that I would really encourage everyone to look at, and all the drawings, elevations, part sections, part plans, and details are all done automatically. Another thing that is connected to BIM in some sense is integrative design. I'm showing here the structural aspect, but many, many different aspects, thermal analysis, daylight analysis could be showcased here, where you start from a BIM model, a certain idea of the design. We can directly from our structural model, but again, our wind analysis software or any other software we have can do the same. We extract the part that we want to analyze, it gets analyzed, the sizing of the members is done, this goes back to feed directly the BIM system, so it's a two-way communication with the BIM model, and then you can see the finished product in the center, pretty much the way it was designed and analyzed. So very, very efficient, very fast way of designing, very integrative between different disciplines as well, which is really important when you're doing facades. And as I mentioned, this goes also for thermal analysis, daylight analysis, lighting integration. A lot of different things can be done through this integrative design. Wind analysis is something that is also helping optimize facades, and we use this software where once we have done the BIM model of the building, the facade is added in as I've shown you, and then we can run this CFD. Interestingly, I mean, we always get the question, how accurate is that? And we've done models on buildings that we had done wind tunnel tests before, and when we compare them side by side, the results are very, very similar. The hotspots are the same, the wind pressures within 5% probably are about the same, so very, very interesting way of doing things, and it's very fast. It's probably 10 times faster or 100 times faster than doing a wind tunnel test. Prototyping, rapid prototyping, this is something that is increasingly being used, and I think in coming few years, 3 years, 5 years, 10 years, you will see more and more people using that. Obviously, we can talk about metal printing and all that. Concrete printing, yes, it still remains a very small and sort of iconic thing, but this is mainstream. This is something anyone can pick up, anyone can do, make sure the details are right, make sure that the shapes, the size, the form is right, and then you can go ahead with the design. Parametric modeling. Parametric modeling is a way to also optimize the design by basically testing out a whole bunch of options and looking at things like weights, sizes, tonnage, linear meters, and basically optimizing the overall design, the overall cost, the overall weight, the overall material usage. Minimizing material usage in particular is very, very important. And this is something that can be automated and done very, very quickly and very simply with the right tools and the right people using those tools. Real-time rendering is something that has really changed the way we design buildings, and I believe that with more powerful computers always coming onto the market, more optimized software, this type of tools will be used more and more. Very realistic renderings. Immediately you change the BIM model, immediately the rendering is updated, and you can do all sorts of things with it. And one of those things is virtual reality and gamification. We now offer virtual mock-ups instead of doing visual mock-ups. So we do this interactive virtual mock-up where we build a small version of the building or a small version of the facade. The client can control it with VR goggles and paddles and get into the building, look at what it looks like, where's the spandrel height, how tall is the ceiling, how's the lighting inside, how are my fins externally, do I like the glass color? So all this can be done very, very interactively. You can change the color of frames, change the color of glass, change the size of fins, everything instantly changed, and the clients can then decide very, very quickly which option or which design they like best. And things can be done in an animated manner as well. So this was a project we designed in Dubai. I think some of you will recognize which one it is. Unfortunately, it was shelved for a while because of COVID. We have hopes that it will come back to life, but that's a different question. And this type of let's say, visualizations process can really help the clients make decisions on the design of the facade, the schemes, sizes, modulations. We can really put 1, 2, 3, 4, 5, 6 options in front of them, let them go in, check what it looks like, and once they're happy with it, then we proceed to the next step without having to do 3, 4, 5 designs completely all the way. Saves time and effort for everyone. The next step would be probably AI predictive design. This is something we're developing as a tool based on the context of the building, based on the locations, based on the orientation of the site, climatic conditions locally. It basically allows you to, through AI system, to determine the most optimal facade from a variety of parameters like sun exposure, radiant heat, shading, natural ventilation. If it's a residential building, for instance, what's the most optimal facade design, the best exposure, the location of openings, the window to wall ratio. So this is something that's still work in progress, but we should have this up and running within the next 3 to 6 months, and I think this will really change the way building forms, massing, and facade design is done. Now, what about materials? These were more on the sort of upfront design. What about materials? There's more and more materials that are being developed. What you see on the screen, for instance, is carbon composite. It's one of many, many new materials that are coming to the market. Facades are very exciting things to design because there's such a huge number of options, of materials that you can play with, of designs that you can play with, and new materials are really interesting from that perspective. You can really push the envelope and do things that are or would have seemed crazy just 20 years ago or even 10 years ago. And the other big trend that we see, and Russell mentioned that as well a bit earlier, is facades that are becoming increasingly sustainable. And one part of that is obviously the integration of solar panels into the facades. This has been around for some time, but it's a very, very slow process. It's a very there's only a very small number of buildings overall that actually do this. And through new developments, like the developments of clear PV in particular, which are maybe visually less obtrusive or maybe more pleasant visually, facades in future can be designed with both the vision and the spandrel that generate energy rather than just the small spandrel panels. We've all gone through this horrible period of COVID, and so health and well-being obviously are at the forefront in everyone's mind. And one of the big concerns when you live in big cities, be it Mumbai or be it any of the big cities in India or around the world, is always going to be pollution and air quality. And so facades can be treated with special coatings or other methods to actually clean the air. On flat facades like this, of course, it's nice. There's the whole few thousand square meters of facades that would contribute to breaking down the pollutants in the air through pyrolysis. But you can be a little bit more creative and do things like this where the surface area is actually much greater, and you actually multiply by a lot the area that's exposed to the pollutants and can break it down into better, more breathable air. And the other one trend that we see is better insulating materials, whether you talk about aerogel, hyper-insulating panels, or vacuum glazing. These are interesting because, again, talking about limiting the amount of materials, things like vacuum glazing, for instance, is much thinner, use a lot less glass compared to a normal double glaze unit, has much better acoustic property, has much better thermal properties, and obviously having less material is also a benefit because you're reducing the embodied carbon in your facade. One of the other things is we see more and more connected objects or connected components, and what you see on the screen is a new way of dealing with the traceability of materials, where you can embed in your facade components, RFID chips, and this allows you to follow from start to finish, from the production stage all the way to the time when hopefully this gets recycled, the different parts of the facade. And also it helps with something that was mentioned just now, which is when you want to replace the component and you may not know exactly where to find it, what was it exactly, what was the coating, the thickness, the heat treatment, all this is embedded in the chip, even the size, the plant where it was made, everything is there. So it's quite an interesting idea to have this traceability of materials. And since we're talking about low carbon and reducing carbon, embodied carbon and operational carbon, on the embodied carbon front, there are a lot of manufacturers, whether it's from silicon, from glass, from different materials that go into the facade, are looking into low carbon products. In the case of glass, this means glass that is 100% made from recycled components. This is one, and also that is fabricated or transformed in furnaces that are fired by renewable energy. So really extremely low embodied carbon. And I think this is a trend that, for instance, in my 2018 presentation was not there, but you see that picking up a lot. And interestingly, you would say, oh, this is only in the UK, or it's only in Singapore, or it's... But no, actually, we do have clients in India that are sort of forward-looking, and now their decision in choosing a certain facade is based on how much embodied and whole life carbon, in fact, whole life cycle carbon is in the facade system and the facade material. So it's not something that is fictional or not applicable to India. It is happening right now. So very, very interesting trend to track in the next 5 to 10 years. One of the ways that you can do that, and you could see this on the chart that was on the screen a bit earlier, is the use of timber-framed facade in place of aluminum. Aluminum is notoriously polluting material from extraction to the time that it's transformed. And timber actually is a carbon sink and is much better from that point of view. And before I showed a photo of stick system, but even some manufacturers have even developed unitized facade systems now that are timber framed. Now, for those who are architecturally trained in the room, if you go back to see the facade of Casa Batlló by Antoni Gaudí, circa 1910, that was a unitized facade, completely timber frame. So interestingly, that it took us 110 years to rediscover that. The other, still staying on materials, glass that is reacting to its environment is also a trend that we're tracking. There was a mention of electrochromic glass in the previous presentation. In one of the previous presentations, I will mention that shortly, but there are many, many options, many avenues for having glass that reacts to its environment. Photochromic glass means more light, the glass gets darker, less light, the glass gets lighter, a little bit like these. I'm in the spotlight, but it's not UV, so it's not reacting here. But these glass panels, they actually react to visible light spectrum. The older technology, which everybody knows, it's been around for 20 years, is the sort of on-off, I can see, I cannot see. This is the very, very old, very almost traditional, I want to say, way of doing electrochromic glass. But of course, you can't see through. Now you've got glass that is not just adjustable from, let's say, fairly clear, 60% is actually quite clear, down to almost nothing, just a couple of percent. But what's interesting is the solar heat gain coefficient is also as low as anything you can do. I mean, there's no low-E coating that can go that low, even on a very dark tinted glass. So this is actually something that is, I don't want to just advertise for Saint-Gobain, so I'll put another brand as well on this one, so it doesn't look like I'm biased toward one. But quite a few suppliers are actually developing this type of products. The price point is very, very high. I was quite surprised to see one of the buildings, I think the first speaker mentioned that they're using the previous brand on the building because it's extremely expensive. It's very difficult to justify the ROI right now, but as you see, there's 1, 2, and I think I'm going to show a third option here. So this way I'm really, really not partial. But with more and more demand, more and more producers will come to the plate, more and more producers will be on the market, and it will be probably much more affordable in the next 5 to 10 years. I'm certainly hoping so. This version is slightly different from the two previous ones, which changes very gradually, very shortly, very, very slowly. It's a LCD version, so it changes immediately, but you only have 2 settings. So it's closer to the traditional sort of on-off version that we had before, but it's just lighter, darker. Now, we've looked at design disruptors, materials. What about construction technology? So this will be very, very familiar to Russell here, because this is something that's very commonly used in London nowadays. Closed cavity facades are a sort of double skin where you have your traditional curtain wall, unitized for instance, and another sheet of glass on the inside. So it's like a self-contained double skin in some sense. And it may not make sense for all markets in India. We talked about Mumbai, where the weather is pretty uniform all year round, the temperature pretty uniform, but for example in Delhi, where you get a proper winter and a proper summer, this type of closed cavity facades could make sense. They've been around, it's not new, done one in Hong Kong 20 years ago, so it's not exactly brand new. What's new, I think, is the trend that we see of these closed cavity facades suddenly popping up everywhere on projects and being proposed everywhere on projects. So it is something, it's the trend of seeing these that's actually new rather than the system. Another interesting one, and it may not be the case for all markets necessarily, but traditionally when we install facades, let's hope that video works. Does it work? Yes. You can try and count how many people are involved during the video. We have 3 at the bottom rigging the panel. You'll see some people on the way. I've greatly accelerated the video, so it's a little bit disturbing to watch. I'm sorry, but we got a couple of people at the bottom, a couple of people at the top. I guarantee there's a bunch of other people at the bottom for safety and at the top as well. You probably have a dozen people doing the installation of these panels. And we're seeing in a lot of places problems with quality, problems with speed of installation, problem with finding manpower that's actually qualified and knows what they're doing. And the idea of facades that would be self-installing, that require a lot less manpower, is something that's quite interesting. So this is one example of a system that has been developed where the curtain wall panels are basically brought to site in pallets. They are picked up by a monorail to go to the right location on the grid. And then the facade itself has little fins on the outside that guide the next panels up. So the panel is basically clamped on the rest of the facade, goes to its position, and then you can go on, drop back the little trolley, pick up the next one, and you repeat that. So all you need is 2 people, one at the bottom, one at the top. You save, five times or 6 times on your manpower. So something quite interesting as an idea. It has been developed and used on a few buildings, not many, but in a lot of places where we're struggling to find qualified manpower, I think this is something that's quite interesting to contemplate. Other than BIPV, which I mentioned before, facades that I'm advertising for you on that one. I'm really unbiased. You see, even I advertise the competition. But there's many ways of generating power on building, and one of them is actually this one, using algae. Not to everyone's taste, to be honest, green on green facades, but it's just a question of being imaginative and doing things that actually make sense in that particular market. Another way to actually make the facade more, let's say, sustainable, reduced embodied carbon, reduce operational carbon, is to have facades that react to the environment. Before I mentioned the materials, photochromic, electrochromic, thermochromic, but the whole facade can be designed to actually react to its environment, and movable screens may be based on sensors embedded in the facade, for instance, that analyze how much light is getting onto the facade and then adjust the position of screens. We've done this with glass fins with frit, for example, that pivot, so they allow more or less light to go through. So there's really any number of ways that you can do this and react to the facade, react to the environment, adjust based on what the conditions are. Another trend that we're seeing is the advent of AR on construction sites. So this is not specific about facade, but it's a way to basically visualize the future building on site using augmented reality systems. And we are seeing more and more clients that are demanding this, that are asking for this. Anyway, we already have the BIM model of the building. The actual building is coming up, so why can't we do this? So in some sense, we already have the information there, we already have the tools. So this is something that's very simple to deploy to check that things are as designed and to visualize on the site the future components of the buildings. I mentioned connected components of the facade before, the glass, for instance, but the whole facade can also be connected. There has been some interesting discussions with a few clients in Mumbai in particular on what are some of the takeaway points on the design of office buildings after COVID, right? Do we want openable buildings, openable facades, breakout spaces, external breakout spaces, change, mixed mode ventilation, for instance, and having a facade that's connected, that can open, close, this is one of the ways that we can deal with such situation in future. Whether it's really warranted or not, I'm not 100% sure. Hopefully we don't see another outbreak for another 100 years, but for those who are really concerned about this and want to implement it, the tools are there. And so the question is, where will you work in 10 years, or how will you work in 10 years? So that's it. Thank you very much.
Thank you, Mathieu. Very encouraging presentation, I feel. It's interesting to see so many people talk about wellness in design and architecture, and also very encouraging to see a lot of innovation and options for us out there. In light of this, I would like to call upon Arvind Kumar. He is the Communication and Business Development Manager, MEI and SEA for Hydro Building Systems, whose topic today is Imagine Beyond Limits, the Facades of Today and Tomorrow.
Good morning. Good morning. It's good afternoon, yes. So there is people awake in the room. That's very good to know. Today I'm going to talk about three topics. I just want to give you a brief introduction about Technal, who we are and what we do in India. A little bit of our approach towards complex facade design and breaking the imagination boundaries, and also talk about what's next. How can we future-proof your business and imagine beyond limits? A little bit about us in India. We belong to the Hydro Group, which is one of the largest aluminum conglomerate. We produce hydroelectric power, we produce bauxite, we produce aluminum extrusions, and the aluminum profiles for windows and doors. So we are a complete aluminum value chain provider. Under the building systems, we have several brands. Domal, which is a very, very popular brand in India. We first started with this brand in India and grew on to sell Technal. And we also have in our portfolio Vicona and Sapa, all of them put together about 240 years of experience in the business of aluminum windows, doors, and facade systems. A quick introduction about Technal. little bit about us and what we do. In India, we've been here for more than 25 years. We work with more than 60 plus authorized network fabricators, done more than 1,000 projects, so 30 members, and we have more than 17,500 warehouse space where we stock all our fast-moving running profiles for this market. From a product point of view, we have sliders, windows, doors, facades. We also have aluminum fire-rated windows, doors, and facades, bullet and blast-proof windows, doors, and facades, pergolas, and glazed handrails. You will get a glimpse of these products outside at our display. In terms of our project service, we start right from the early stage of the project at a concept and schematic stage. We help architects with LOD 300 detailing, so help you progress in a digitalized fashion into tender stage detailing. And right after tender, we have our authorized fabricators who come onto the table, discuss and develop solutions to ensure that it meets your design intent. And at the construction stage, we have technical engineers who audit the production, audit the assembly, and audit the installation as well. Some of the projects which we work across a wide range of projects, from low-rise villas to residential to mid-rise to high-rise buildings. And that's what Technal is so exciting to collaborate with, because we don't have any specific project we are focused on. We are absolutely open to collaborate with a wide range, a variety of projects, from hotels to hospitals to residences to high-rise complex facades. And we will see some of our experience today in this coming few slides. When it comes to complex facades, at Technal, we like to take challenges on board whenever we have a complex geometry to deal with. This is a very good example of a project in Qatar, which is 140-meter tall building, but the facade layout is quite interesting because the floor plans change from 0 to 180 degrees as it turns up. So we had to come up with an innovative and interesting solution called coal bending, where we take a panel of glass and then we bend it to take the shape of the building. It's quite interesting and exciting to see how flexible aluminum and glass could be, and we've done this over a panel size of 4.5 meters by 1.3 meters, and to help even to protect it from future breakage, we also have a horizontal capping, mechanical cap coming on it, so it helps in terms of long-term creaks and breakages. It can still protect it. The facade, after it was installed, we had to also add a secondary shading skin, which was also incorporated on the project. Another interesting complex project which we have done in Dubai is the 340-meter tall tower. And quite interesting engagement on this project was working with the consultants at a very early stage. This was one of the first projects in Dubai which was designed and built directly with the main contractor. So the main contractor collaborated with us at an early stage, developed the detailing, went for testing, we passed the test, and we had a couple of contractors hired, and they used to fabricate the panels under the supervision of Technal, and the whole facade was installed within a period of 6 to 7 months. The project is fully completed now and has already been occupied by the client. So that's some of the examples of how working early with Technal helped to address this kind of complex facade geometries. Right here in India, we have a wonderful case study to talk to you about. This is the PSG iTech auditorium in Coimbatore. It's a tier 2 city, but the architect and the client and the stakeholders had a very large vision to build something unique and complex in a city like Coimbatore, a very humble city, not known for its extravagant architecture. But here in this project, SDSA and Vista Architects came up with kind of a half ellipsoid dome structure, and it had two major components. It had a calcium proofing and the glass facade, and we had to develop a very unique solution, not only to meet the design intent, but also to work with a fabricator who's probably not extremely skilled to take on complex projects. So we had to make it very simple, very easy to fabricate, assemble, and install as well. The project had about 1,876 triangular glass panels and a facade area of about 1,100 square meters. Our first approach for this kind of a project is to really understand what is the building geometry and what is the building skin limits. So we started with that, and you can see here we defined the purlins and the rafters, which are primarily the hosts for our system. And then we started to realize what kind of resources we had locally, and the best possible solution was to go for what we call as a unitized facade framing. So we had to make things very simple and easy for the fabricator to manufacture and to assemble, so it's easy for them to actually come and demonstrate the installation at site as well. So the system, as you see here, is quite simple. We have the primary steel structure, which behaves like your host, and we have a very slim and minimalistic curtain wall system, which has interesting connections, splices to also take on various movements and also the various angles of the glass. This is the bottom detail, which you see here. Again, we kept it very minimalistic so as to express and allow more natural daylight to come inside. Here you see how we treated the expansion joints by introducing very simple steel splices, which allowed the facade to be able to take on the movements which the structure brings onto the table. And then once this was done, we had the collaboration with Enclosure Facade. He's one of the facade consultants who was working on this project, who developed a survey model on 3D. And based on this survey model, he developed what we call as a production model. So from a base of site assessment to bring it to a computer model and then defining the kind of frames required. So this whole process was digitalized, so it made the scope of producing the panels much more easier and simpler. So with that model in mind, we developed the panel sizes, and we also produced the complete fabrication manual for the fabricator to understand easily, and also develop the complete installation manual for them. So it was really like putting together an IKEA kit for our fabricator. So you didn't have to work really too much or stress too much on getting the project executed. So some of the photos here, as we developed with the fabricators, you will see these interesting round connectors which helped us to take on various angles and various shapes. So simply any kind of shapes is really possible with our curtain walling system. Here you see some of the photos from the factory yard, the unitized frames getting assembled. So all of these panels which you see are completely fabricated and assembled in the factory and taken to the site. Here was a purlin which was installed ready to receive the facade panels. And this was the first site visual mock-up which was put on the site. And then the progress from there on was quite fast and simple, because they had to just repeat these unitized framing just like ladders, and then the glass was subsequently installed piece by piece by piece. Today the project is fully completed and hosts more than 2,000 delegates for their conferences and their events, and stands kind of unique in the heart of the city. And this project for me is quite special, because working on such a complex project in a Tier 2 city opens up a lot of possibilities for architects who can freely design, freely pen their design, and can be achieved in a Tier 2 city like Coimbatore. And this is a final outcome of the project as well. I come to my last topic, which many people stressed on today. We had Russell talking about embodied carbon. We had Mrinalini, who talked about what is the state of our industry today and what can we do better tomorrow. Today, our market is experiencing tremendous environmental pressure. The Earth's atmosphere is warming up, and this is something which you're noticing visibly with the climate change in India. The world's population is also going to increase by 2 billion in the next 30 years. This is also going to add more pressure, because more amount of buildings will be added now, and 70% of these buildings will be in urban city centers. Our industry contributes to more than 39% of all the carbon emissions. From this 39%, 28% of this is happening at the construction phase, which is even before the building is operational. And 72% of this is coming from the use phase. We have talked a lot about helping the industry with the operational carbon, with better performance, better U values, and so on. But we need to also stress and work and think about embodied carbon, carbon which is being consumed till it reaches the production site. Today, our industry, especially the window framing, is contributing to almost 24% of the weight. but 65% of the CO2 emissions. A glass contributes to 62% of the weight, but 20% of the CO2. All the fittings and accessories which you see in a window is 14% of weight and 15% of the CO2. We have a big problem to address, and as Technal, we don't want to be a part of the problem, rather be a part of the solution. So we are focusing on the aluminum framing, which is part of your windows and doors and facades. And not so far away, and not so far long ago, the Indian government also put a strong commitment in COP26 that by 2070 they want to go net zero. But is it really possible? India is today the 4th largest emitter of CO2, about 2,500 megatons of CO2, and a per capita emission of 1.9 metric tons. We need to focus on embodied carbon and operational carbon right now. The decision for us is not to wait till tomorrow, but to take a strong, conscious decision now. How can we as Technal, as a system supplier, help India in this process of moving towards net zero? We have carbon emissions along the entire value chain of producing an aluminum window door right into a building, from the production stage to the construction stage, to the usage stage, and to the end of life stage. But we want to focus on the production stage itself. At Technal, since we are part of the hydro group, we produce hydroelectric power, and today we are able to produce aluminum produced from hydroelectric power, which has one of the lowest carbon footprint for virgin aluminum, which is 4 kg of CO2 for every kg of aluminum produced. On the flip side, because we're a large aluminum producer, we have taken the social responsibility to collect aluminum from end of life, from buildings which have completed their complete lifetime and which are going for destruction, going for refurbishment. We take those aluminum back and we bring it back to life in form of post-consumer recycled content. That aluminum emits only 2.3 kg CO2 for every kg of aluminum produced. Now, how does it compare to the global footprint of aluminum? An aluminum produced in China emits 20 kg of CO2 for every kg of aluminum produced, because the energy mix they use is coal. Global and Europe average is about 16.7 because they use gas as a resource for producing aluminum. Hydroaluminum is made from hydroelectric power, hence we are able to get it as low as 4, and with 75% post-consumer recycled content aluminum, the emission is only 2.3, as I mentioned before. I'm super proud to announce that today we are able to produce aluminum from 100% post-consumer recycled content. Absolute no mixtures, directly from pure recycled post-consumer aluminum, and this aluminum emits only 0.5 kg of CO2 for every kilogram of aluminum produced. How does it translate into numbers for you as architects and designers and investors and stakeholders? Imagine this building which has got about 10,000 square meters of facade. This consumes about 100 metric tons of aluminum. If we use Circal, post-consumer recycled content on this project, the emission is about 2.3 kg of CO2 for every kg of aluminum. Using the global average is about 18 kg of CO2. So if we just shift from using virgin aluminum to a certified post-consumer recycled content aluminum, you will save 1,570 tons of CO2 even before the building starts becoming operational. What this means is, for every 1 ton of CO2, you need an olive tree to live for 80 years. So you can imagine the amount of trees you need to just plant to offset this amount of aluminum. This story is no longer just a greenwash, but we are actually implementing this. Today, 40% of all our production in hydro is based on post-consumer recycled content, and we have completed more than 100 projects, and we have saved 25,000 tons of CO2. I want to show you a small video which probably would trigger your mind and start to answer some of the questions which Mrinalini posed earlier today. How does the industry move from here on? I'll show you a small video to conclude.
We all create miracles every day, designing what will change our world. No matter what we want to achieve, doubt is always part of the way. Naturally, we will reach for the stars. But we must protect our first dreams. What we've developed already. And defend what we have to come. Right now, we're living beyond the boundaries of the planet. Building and construction sector represents 39% of global carbon emissions. If we are to shape the world we want, the one we need, imagination is the key. Imagination is endless and the source of every creation. Every house is not simply four walls, but a choice. Every office is not only a place to do business, but a chance to shape the future. Our answer to the emissions of our market is not only to offer aluminum windows, doors, and facade with high performances, but also to focus on material with at least 75% of recycled and 95% of recyclable content. We see beyond our products and manage each part of our company as sustainably as possible to reduce by 2025 our own CO2 emissions by 50%. We also imagine a world beyond our company, beyond our roles and responsibilities. Beyond our society. One that's beyond waste. Beyond our imagination, and beyond our ambitions. A world beyond limits.
Mumbai, that's been my time. I invite you to imagine beyond limits with us, and we look forward to working together with you. Our contacts are here, and we would love to continue the conversation on this topic. Thank you so much. Mrinalini, over to you.
Thank you, Arvind. That was heartening, and congratulations for all the lovely work that you're doing. Like we know, we're only limited by our imagination, but we're also limited by time, so I am going to go ahead and call the next speaker. We've got Michael Bischoff. He's a partner at Cobb Fried & Partners, and he'll be talking about case studies from 15 years in India.
Thank you for having me. It's a pleasure to be here. And by this big crowd, it seems like Mumbai is certainly, and India is certainly back, so it's great post-pandemic. So, let's get this. Okay. 15 years, we've been working, Cobb Fried & Partners, my partners and I have been working here in India for about 15 years. And today I'm going to talk about three primary case studies, starting with Hyderabad, and then a longer period in Mumbai, and then some current work that's going on currently in Bangalore, developing community campuses. A little bit about Cobb Fried first before I go into that work. What is our DNA? One portfolio with a global set of work across the world from our single studio in New York City, diverse capabilities and experience, broad type of project typologies throughout the history of the firm, some of the world's most recognized landmarks, of course. Commitment to the art of placemaking, which is critical, especially in urban contexts. And as Russell was talking about, I think earlier, kind of attention to crafted buildings, building things well, attention to detail, quality architecture that's going to last. These are all critical. Ability to navigate complex projects, sensitive contexts, sophisticated design, performance, building enclosure design, including kind of a long track record developing closed climate walls for all sorts of different environmental conditions and signature tall buildings. But here, I'm here to talk about India today in the last 15 years. So it was in 2006 until now. But in 2006, we were engaged by Tishman Speyer, India, to look at a site in a new SEZ west of the CBD in Hyderabad, which you could see was a completely undeveloped area. These two new red dotted lines were kind of new thoroughfares, vehicular routes that were being planned. And the new site, 17 acres here, was really in an area that was largely undeveloped. It did have one beautiful rock outcropping, which became part of its name. The site became known as Wave Rock. The design now, as it stands right now, is two bars, finally completed not too long ago, a long bar and a shorter angled bar. But what I actually want to talk about today a little bit is kind of the aspirations and the visions and the original design that we actually developed between in 2006 and 7 and until 2008, which didn't actually get executed. And that was, rather than two straight bars, it was one curved, waved, or wiggled bar along with an angled straight bar. And this composition was highly calibrated. The longer building, undulating, wiggling, and playing off of the shorter angled bar to create to use two buildings to create a context, which was critical because it was in an area that didn't have any context at the time, totally open, largely undeveloped. And the arrival then from the wider northern side of the site was critical. It brought you in, and the wave itself created points of inflection, a sense of scale. You're in a scaleless landscape, but it broke down the super long building into and you can see this lowest floor is straight and 4 floor sections kind of stepping. You can see the simple play created around a central point of inflection, moving at 4 floor increments. And that shift has happened on the facade at the center point of each of the unitized sections. And I think we saw the last gentleman just speaking a moment ago about this one device that we were kind of exploring at the same time, which is you can see the hinge on the right-hand side detail there, which allowed that same typical unitized module to to be used, or the extrusion to be used for both the vertical as well as each stepped increment of the facade, so as to make it something that could be built through a kind of a set of standard extrusions. This was fundamental to think about how to make it buildable and affordable. Now, in our design studio in New York, a fundamental thing for us obviously is mock-ups, and especially if you're dealing with glass buildings, trying to think about the comparison of vision glass versus spandrel glass and things like that. We would do our own mock-ups right outside our office in New York City. And phase one was always going to be the straight building to be built first. So that was always understood as the first step of kind of establish the market, establish a place through phase one. But one of the challenges, and this is what's interesting about this talk today, is to think back at what we've learned from working in India, working in Mumbai, was indeed, we learned right away that indeed the aspirations, which were grand by the client, as well as India as a whole, really at that time in 2006, really bringing the tech sector, international tech sector market into the Indian context. It wasn't really clear that the curtain wall industry was really necessary up to speed with kind of at least some of the things that we were hoping and that our client was hoping could be done. And we saw right off the first mock-up that was built that we were going to have issues of craftsmanship right off the bat, condensation showing up in the mock-up, things like that. So it became quite clear early on that there were going to be challenges executing the project. Nonetheless, when completed in 2009, phase one, that is, it was kind of received with a high level of fanfare, a green new wave, high-tech and green sustainable features. The wonderful rock outcropping had been saved and kept, and the name Wave Rock actually came originally from this outcropping and the waved undulating form of the phase two components, at least in my opinion. So what was built at phase one is, as you can see here, foundations for phase two started but never got completed until much, much later. And we were at the time kind of asked to look at kind of comparing, well, what happens if you made it straight? And we did that. We kind of went back and forth. But nonetheless, due to the market downturn that really happened in 2008, 2009, phase two was put on hold and not completed until much, much later, and by under a totally different design than the initial one that we had proposed. So that was both the high points and the low points of our introduction to India, working in India, back between 2006 and 2009. Good thing is it's a stepping stone to coming and working in Mumbai, where in 2009 we were engaged by the Lota Group to start looking at the development of one of the central mills, one of many central mill sites that were at that time starting to be put into the market for development. Srinivas Mill, a large mill right in the center of the main mill district, and also before and after current day picture 2002 shows you, as it did, as the same comparison in Hyderabad showed you, is how much development, how much transformation has been going on in India in the last 15 years. There are these sites that have just gone from almost, well, this is not empty, as Hyderabad was, but it's all low-scale 1- and 2-story mill construction. It's 2008 or 2009 to today, where there are very few of those mills still left. Some are. And I gave a talk in Singapore earlier this year where I talked a little bit about this project too, and I hypothesized, and it was partially because I was in Singapore, and what has happened there is that there's been planning or the allowal for tall buildings to come up, but they've kept some of the old things. So I only hope that, I think it'll be unfortunate if every trace of the lower construction is actually wiped away, and I wish there were ways to refurbish, renovate, reuse some of the old mill buildings, because if it all became dense towers, it would be unfortunate. But here we were, the cotton mill textiles had been a major part of Mumbai, but in 2009 it was mostly shuttered, abandoned, and no longer being used. So development was the right thing. And the Srinivas site was an incredible site. It bridged between two major thoroughfares through the city, and as a master plan, it had the opportunity then to create another new street, which was a highly radical move at the time, because development in India is usually about creating walled enclaves. And this development was about creating a new boulevard, Srinivas Lane, that would connect, be a private road, but it would connect between two public roads, and actually give this sense that this was really contributing to the city and becoming a new city within a city. Five new parcels, 3 residential towers in yellow, 2 blue office buildings, and then a large commercial parking component. You can see the massing or the master plan in 3D. And the first building to be completed was the easternmost tower, sort of detached from the main body of the site for Lota, as you can see there. And in this view taken from a public park that was created as part of the development at the same time. And we had also just gone through the whole Hyderabad experience. So we were looking for ways to create a simple, this was also starting the market, it's a shorter building, just bringing and kind of developing the market here, a commercial office building in this location. And coming up with a clean, simple curtain wall that combined a typical glazing curtain wall on its south and western frontages, that combined with a strong spandrel component would allow you to take that spandrel component, wrap it continuously on both frontages, and then take the vision glazing and either recess it or push it in. So you took 2 very simple components, but got maximum kind of architectural distinction and orientation that responded to orientation with very simple, easily executable facade components that was playing and getting more out of light and shadow than we were doing or thinking initially in Hyderabad. The next component or phase of this was the 3 residential towers known as Lota Place. In the center of the site, 3 towers, one the tallest residential building or building in India, designed around this wonderful arrival courtyard with a central fountain, the view up of those towers. And the king, or the tallest of those towers, becoming the beckoning visual element, drawing you into the site and really speaking about how powerful this public street was. This is the arrival. It's a private street, but it speaks in a public language. It's part of the city, draws you in and says, I'm going there. It's a wonderful place to live. And Srinivas Lane was ultimately, when it's 100% finished, I haven't been there since June. It's still not quite done, I don't think. It'll be probably another 6 months before the project is really finished. At its ground level, it'll have retail, but this building has a parking podium. And so one of the keys was to take this public facade and screen it in a way that kind of created a wonderful undulating, in this case curved and perforated screen component that screened the parking component and made it a wonderful kind of public facade that could give way and create a gateway entry into the residential compound. And this drawing from our architectural set just shows you kind of the attention to detail, the amount of work or care that's needed to kind of show and start to document every piece required to establish a facade of that length. I don't know exactly how long it is off the top of my head, but actually there's constantly changing pieces throughout. The final component, the building component that is still just nearing completion, not quite done, I hope to see it farther along over the weekend, is One Lota Place, which is the second office tower that's kind of at the prime point of the site across from the Supremus Tower. Now the challenge here, similar to the first Supremus Tower, was indeed to, given the parking base, was how to develop an architecture of the facade that would draw your eye all the way to the ground, express the tower while concealing the parking behind. You can see there's a 2 or 3 story retail base, then a zone of 5 to 6 parking floors, and then the typical office floors above. And I took this photograph in 2019 of the mock-up, and I actually hadn't been involved in the details of the Hyderabad project, but I had followed it carefully within my firm. And I didn't know what to expect when I came to see this mock-up. And the difference between this mock-up and the 2009 mock-up, or no, 2008 mock-up, 10 plus years later, was just remarkable. Because it really showed that how much, at least through our experience in the time that we had been working in India, how much we had seen the industry, and particularly the curtain wall industry, and the different people that we were working with, and also what they could produce, all locally, because it's all being produced locally to be cost effective, how much it had changed. And this mock-up, while not being perfect, was pretty darn good, frankly. And you can see the design was trying to then develop these components, darker frames, a light aluminum color as the body, darker frames framing the window, as well as louvers that were concealing the parking components of the design. All executed in a fairly high level of refinement within this mock-up. We were pretty happy, actually. Getting it on the building is still a challenge sometimes. And you can see these pictures of the work in progress right now, reaching to the sky, nearing completion. COVID slowed the whole process down because there had been about a 2-year period where I was here right before COVID and then right after, and work had happened, but not everything completed. So that takes us to the current day work. There was one of our people that we had met through the Hyderabad project. It's a small circle of people, of communities, relationships, was now working for MFAR in Bangalore, and then we were engaged by MFAR to look at two sites in Whitefield, western Bangalore, kind of both in proximity to the extension of the Whitefield Metro line that is being constructed and I think is now largely completed along Whitefield Road. So the first site was called Silicon Forest, farther out from the CBD, probably about a half an hour drive, depending on the traffic, which there usually is a lot. And the challenging part of the site was it has a long linear site with one point of access on its eastern corner to a road that took you down to the main metro line. And the challenge was then how to make that site, to really create a site that kind of drew your eye into the site and allowed you to create locational value for all the building parcels that were going to be required, given the development totals desired by the client. And you can see as you move up in the plan that we developed kind of a bar on the northern edge of the site that would link together 4 building parcels that you can see here on the typical floor plan. The easternmost parcel being a small vertical component, and then as the buildings step or move to the west, they both get longer to the south and they step down, reducing the number of floors, so that they step out in a way and all have visibility from that main point of arrival at the southeastern corner of the site. And here you can see kind of the overview in axonometric. And a perspective view from the point of entry as a pedestrian. Now, this wonderful garden, we'll go back here, that you can see here as a beautiful palm garden that is a frontispiece, but between each of the office buildings are indeed outdoor living rooms of their own right, where the visitors and workers and the entire community will gather. The central one of those courtyards or spaces is a stepped amphitheater. And this was a kind of an idea that we had started to explore in another project that I'm not talking about today, which was the headquarters for Goldman Sachs, also in Bangalore. But it wasn't really executed there with the same level of quality. Not that it wasn't working well, it provided daylight to the auto drop-off, but whenever I would go there, I'd always think, wow, this is a space that people should really want to be in. So we had more room here to take this, to create this stepped amphitheater that would really become a gathering place for having lunch, for parties, for performances. That would step down, and it brings you down into the vehicle arrival point, which is at the B1 level below the commercial bar that lines the northern side of the site. And it's this simple move, this linkage of inside-outside, building to landscape, that kind of ties it together and kind of lets all the visitors come and go. And now the stepped landscape is one that's really got a proportion that can really be used and become a wonderful heart or center for this entire complex. Now, what do I do to get this to work? Oops. Can someone help me get this? Yeah, there you go. Thank you. And that takes me to the final project here that I'm going to talk about, which is also in Whitefield, a little closer to the CBD. It's called the Hub, and it was adjacent, immediately adjacent to the metro line that you can see there now completed, and also a short walking distance from one of the stations. So it's really a wonderful site. And now this flip down, so north is down, and this development, two paired L-shaped buildings kind of nested together to really create a central garden, community garden at the heart of this campus that's really the public amenity that is then fronted on the northern or on the page down side by a retail building. And the retail building was really the catalyst. The client showed us, I think it was called Boxcar, I think it's in London, or Box something initially. It said something like this. So it's this retail building that you can see now. You can see the four office buildings, each paired or linked by a podium to make two L shapes that create a central garden. And that central garden then is accessed through the retail building that functions as a filter, with its top level actually being an accessible roof. And in this case, the refuge floors kind of play into kind of an overall geometric idea to really kind of create transparency and openness on certain floors within the buildings. And you can see here how this simple open garden that is really the heart of this new complex is then kind of flows through the retail building. The retail building then just being 3 stories and sliding underneath the kind of most public of the office buildings that has been pulled back with a dramatic cantilever. And in the center of the garden, you kind of have this wonderful play of water, landscape, trees, which Bangalore, the climate it is, a little bit different than Mumbai, as you all know here, is actually a climate where really the outdoor space is space that people really want and can and will use, with incredible trees and incredible, just, beautiful space to be used a good part of the year at least. Not all the time, but a good part of the year. But the building that really, what I really want to get built here, more than anything else, is the retail building, which is the Hub. A play of indoor-outdoor kind of commercial spaces, and a checkerboard of green walls and outdoor walkways to take you to the commercial spaces that are within. There's a special restaurant on the top with kind of pivoting windows that allow it to open up in the nice weather. And kind of a heroic central passage and vertical circulation component that allows people to move both through from the public realm into the central garden, as well as up vertically. So it's an indoor-outdoor kind of horizontal and vertical circulation node. It's a gateway into the campus. And as such, I think it'll be a really kind of inviting and kind of bold gesture about how commercial projects in India don't have to just be walled off, that walls actually can be components that are inviting and serve the project in a way that's really positive rather than trying to kind of say us and you or we, stay out, only certain people can come in, but that this really will kind of speak to and create a new typology in Bangalore, but also could be for Mumbai as well, for a building that actually is a filter that kind of draws and wants people to come into it and says, okay, I'm an edge, but I don't have to be a wall. I can be something that's occupied and can encourage use and commerce and social interaction. And here's the view as envisioned from the metro. And really kind of the importance that if you've got a building that is really creating this frontis low piece, but this larger U-shape on collection of buildings that's drawing your eye into the campus kind of as a way to kind of mark this new development in the Whitefield section of Bangalore. Thank you.
help us, definitely help us. It's not like as an architectural consultancy firm, we try to do everything. We take help of various facade and the glass manufacturers and the, from your facade consultancy firms as well to understand this. So I think overall, what we are trying to do is like, from the scratch, the sketchbook to the digitization when we go, we see the role of these various software and the digital aspect which is help us in achieving our final product. And definitely we have a younger team also to speak more about parametric and how your imaginary as a free form it can flow. Because some of I've seen my young colleagues, though they are well versed in their SketchUp tools and usage of that, there's one point of time there is a rigidity which comes in a design. Okay, because your comfort with the software or that software to use that very free form has a rigid tool, that becomes a rigid tool. So as an advanced form, these parametric softwares are there as to explore that vessel. I think even as a progression, we have to open ourselves for all these digital inputs, because as a building industry, we are all growing vertical as well as horizontal. And the land parcels are getting larger and bigger to address, and it becomes that sole architect's vision, how he's visualizing whole campus as not just as a building. So this digitization is really helping us, and we are using it in various ways. So I'll end my talk.
Kutub? How have you transformed your office?
Good afternoon. So I think we have seen the transition. We have seen the transition of bending our backs on the drafting board, standing for hours and doing the drawings. We did enjoy that process also. As Rajiv said and as Brinda said, that was a kind of an experience. If you had to present an elevation and if you had to present it in a colored form, we used to even sit and draw the claddings, like the marble claddings or whatever was used in those days, physically get those Xeroxes, do the presentations. And I think it was one kind of an experience that we went through. But times have changed, complexity has changed, buildings have changed. Things have moved parallelly in a different direction. Today we have number of opportunities which are there with us, let's say in form of claddings, in form of glasses, in form of technology which has come in. So it's, but the imaginative part still does remain when it starts with a sketch. Two different energies are there in an office like mine, today also. So there is one energy which is made up of people like us who still are having a yellow paper roll on our table. We are having a pencil, we are having the sketch pen, and we start from there. And then there is another energy which is there. Just what Rajiv and Brinda said, they are the younger generation. And just like, to put it in Rajiv's word, my extension is still the pencil or a pen. Their extension is the mouse and the computer.
Lot of ground has already been covered, but I still remember when I got out of college, I think not even out of the college, when I was doing my internship, I spent one entire month just creating cut plans of an elevation, which changed from floor to floor to floor. And after a month's time, I showed it to the principal, and he was like, "Oh, did you do all these plans and sections?" Wow, he was really happy with that kind of a physical labor which went into it. But from that day till today, when I lead a team of 60 young architects who are trained in all these new softwares, I think it's been a lot of change. For me, from the drafting board to the CAD was a change. By the time I really got a grasp of CAD, I joined HOK, which had moved on to Revit. I again started learning Revit. By the time I learned Revit, I moved on to project management. So I never used Revit. So it's a constant change, and it's really interesting to see how the youngsters have started using all these new softwares in more and more innovative way. I think the responsibility of architects has increased because the clients are very well aware of the output that you can get from all these new softwares. The demand has increased, and so are the
That's
Right. Sonia, what is your aspiration from an architect nowadays? Like I know what was 20 years back, what is it now?
So hi, good afternoon
What do you
everyone.
expect?
I am the client that is being referred here. I'm the only person on the dais, so yeah. But I'm an architect myself, so I can synergize with what Brinda was saying, the old school of thought or the old architect and the new architect. Having said that, looking at a client's perspective, these, these three words which we hear quite often, the cost, quality, time, they're actually very much relevant. They're on the table all the time. The scale of the projects has changed. The aspirations have changed. The times are always on a crunch model.
True.
So because of that, it's very important for the client to visualize what is being built. So for example, I represent a fund. So it is also the investors who are sitting at the behind who are very much involved in what we are building. So if we do not understand or can't visualize what the architect is very capable of visualizing because they are, let's say, it's inherent in them, it's very difficult to take the decisions because the decisions are the client's decisions. So for that, and of course the stakeholders on the table for us is not the architects like ourselves. There are other people also in the room who are equal or more important in various milestones as this chain of the project moves on. Sure. So when we look at the digitization and what I was hearing Khushbu talk, which is new to me for sure, is I think it's very interesting because you can then see the project
probably the only one sitting here who hasn't ever practiced on a drafting board. So I wouldn't know how that feels. But I mean, I've also learned how to sketch, and that's how I imagine also. And I think most of our office also starts with a paper and pen. And once we have the, concept that we call that, okay, within this context, okay, this is what we're thinking of, because we think with a pencil. That's how we think, I think, as architects. Right. We think with that. And then we move on to thinking about how we can make the project best possible. So for exactly what Sonia was mentioning, that cost and resources, sustainability are all relevant topics currently. True. So we cannot forget that at the end of the day, we will have to check on how the sketch that we have just made will affect the end product in terms of that. So there was this really interesting exercise we did very earlier in our practice, where we understood that the cost of the facade is one of the major cost component of a building. And then we started with optimizing the surface area of the facade to the floor area of the building. And just with certain iterations of floor area, we could, find multiple options of how much surface area was coming on the facade, and you can just optimize it to the least, the facade versus the floor area ratio, and you can actually exorbitantly save on the cost. So this kind of really groundbreaking stuff can only happen when you have a computer in front of you. It is not mathematically possible for a human being to make so many calculations at once, especially on a building of that size. So I think, these kind of interventions are inevitable, and I think kind of completely the need, because of course, the human connection with architecture is something that no one can take away from, because at the end of the day, only humans are going to occupy the building. So you have to have that scale in terms of that, because we know examples of Russian towns which are abandoned because of the scale of the building was so high that humans couldn't relate to it. And whereas you see the architecture in Europe, when you relate to it so much and you love going to Europe because the scale of the building is always manageable to the human eye. So that connection is never going to go away. Right. But I'm sure that we will be progressing and we will be understanding how to maintain that balance.
So are you saying if it is complex facades, you need a software, right? Yeah. With sketches you can only get the form, but you can't do the architecture of it. You can't get working drawings with without any complex software.
Yeah,
right?
Definitely not. And more often than not, we also get the form with our process. So we take informed decisions on our way with different constraints.
Of installation. Like in the rendering, it looks very nice. You may have a curve which is 10 meters, 15 meters, but when you start putting materials, like you go for aluminum or you go for any material, there are joints which are not seen in the concept. So how do you relate that? How do you come up with a solution?
So actually, we use certain softwares which actually use algorithms. So suppose I have a curve with a perimeter of say 2100 meters, right. And it's a large complex facade, and I need to divide it into glass panels of certain sizes. Now I have divided that into that software and made sure that the entire building is coming up like that. And now the glass vendor says that this panel is not available, only the other panel size is available. It was 600 by 400 initially. Now it's looking too small. The client is saying that we need larger facades. What do? We can't be going back to the drawing board and making the entire working drawing again, right? So we actually changed the data from the start, and instead of the 600 by 400, suppose it's 500 by 700, we change it and we get the entire information again. Right. Again, we also get how much wastage there is, how much extra, there will be some, obviously because it's a curve facade, there will be some elements which will not be uniform. We'll also get that. We can also change the curve in order to get to the panel dimension exactly. So, I mean, yes, algorithms is the answer to this, that to move into a more complex facades, we will have to start coding as architects, and we will have to start understanding how to manage these kind of complex facades. Keeping in mind that all the materials are all standards, all the glass facade systems, everything is more or less standard. There will be, of course, more digital fabrication techniques that we will have to incorporate. But I would just like to mention that most of these fabrication techniques are already present in India, because it's not just our industry that is using it. There is a lot of other industries which are using these technologies. It's basic like CNC machinery, 3D printing, all of this. KUKA robots, which are these 5-axis or 6-axis robots, they are used very standard in
like all of y'all, I think we can ask the audience for questions now. But I'm just saying, in terms of if we have all these tools, like we have everything in our office now, everybody's working, all the clients are, forcing us to use these BIM 360 and all that stuff. But then the contractors are still not equipped to it. Most of the contractors, in the facade industry at least. So that is one challenge we have as a facade consultant. But the second challenge what we have is, what is the advantage at a later stage? Because currently, if you look at, if you give a Revit model to a contractor, he won't do it. You have to give him AutoCAD drawings. So that is the stage right now in our industry. Now, what is it in your industry? How are you making it simple for the client as an architect?
I think agreeing upon how the project is going to be delivered right at the onset is the key to it. There is no point in, the architect spending all their time creating a Revit file and then spending another 4 hours per sheet, because it doesn't look the same in AutoCAD and they are not able to figure out the line weights.
Right.
There is no sense in that. So it is to be driven by the team. I think clients play a very important role in that. We have got clients who tell us that all consultants need to be on Revit.
We get the same.
That's it. So then I think we need to buckle up. Like we said, today, Suresh, you are comfortable on AutoCAD, but the 4 people who join your organization are not going to know AutoCAD.
Right.
They are going to say that
come on here, let's get the things, let's get people inside. Anyway, it's a very interesting topic. I think impactful influence of facades. The good point is that fortunately I picked up 3 topics from 3 different verticalities, one being civic space, one being healthcare unit, and one being institutional project. So I come from a place, Navi Mumbai, and it's a developing city. Many actions are happening over there, and we get many opportunities to introduce new systems, new ideologies. I being flagship, you can say brand ambassador for sustainable passive architecture. I think we start all our projects from that design level and then proceed to using facade as our final cumulative end product, which has the impact on society for whatever we do. With this, I think let me start this presentation. The first topic which we took was National Cancer Institute. It's a complete 100% oncology center, which was envisaged in 2014 in a place called Jamtha in Nagpur. And it was a whole vacant plot next to Mehan, so there was no neighborhood to have an impact upon, but general architecture of Nagpur and all we saw. And we had a particular question that how do we go on this particular project and how do we proceed with this? The site was it was a complete south-facing site. And so we thought, I think the basic principle which needs this meaningful architecture is a product of synergic process, tailored to create built and unbuilt form that are life-enhancing, sustainable, and timeless. These being hospital, we thought it won't have any expiry time like most of the residential buildings and commercial building has. So we need to have the philosophy so strong in our planning as well as in our enveloping facade system, so it becomes ageless. So with this, we actually turned out to a particular form in which it was a single. So we had an option of creating different buildings and conducting room corridors, but seeing the future requirements of the number of rooms and the demand of such kind of places, we realized that we should leave enough space for future expansion. So that's why we came out with the 200 meters long building, and with this particular building, the whole particular things were envisaged at the various levels. Subsidiary infrastructure like Yatri Niwas, Nurses Hostel, and all those things are also placed on the particular side of that particular thing. So the whole access systems, the roads were not existing at that time, and we created a complete network of our roads, and from which the city developers aligned with this particular project. And since this is Zak World of Façades, so I'll restrict myself to just facades and enveloping systems. Nevertheless, the challenge was the south-facing facade and a linear facade in which we had so many of different functionalities which were to be placed inside the whole envelope system. So there were lots of internal courtyards, light wells, and all those things which were created, which actually spoke about the whole philosophy. And functionally, before we took the first step, we actually did lots of environmental analysis on the basic planning and floor-wise for the structure which was designed. And before coming to a solution for enveloping this particular thing, we were very clear about what is the kind of light indexes, what we have, light quality which we are getting as per as a part of the design which has been developed. Where is it that we want to economize our intake of lights, avoid glares, give a better impact to the people from the main road, signages, and so on. There were so many factors which we wanted to include in the whole thing. So finally, the whole concept was created, like the basic concept of NCI. If you see the logo of the client is a bird, which had a basic principle which says freedom from fear, fear of cancer. So that itself became a very tempting point for us, that why can't we just simplify it and use client's philosophy for this particular project as a part of our design. So the whole project was designed, the whole envelope was designed as a bird first. If you see the two wings, which is on the west and east side, are basically 21 meters long cantilevered arms, which are three level live on the things. More clear on the vertical face. Central core, we visited a couple of hospitals with high index like Tata Hospital and all, and we see what are the difficulties which were faced by them. First of all was the lobby, which was always cramped up. how do we divide the lobbies into different parts, the light and ventilation systems which were inside the particular thing. The building becomes so dense that it becomes so dark and so enclosed that you hardly get to feel the environment around in this particular, and it starts looking depressing. And so those are the particular points in my philosophy that we wanted to avoid in this particular project. So we started creating multiple level of gardens within the particular buildings, open spaces wherever the waiting lounges is. So initially we splitted the whole project into different zones. Zones which will be done by, used by patients, zones will be used by doctors and administrators, and zone, most important thing, the zone which is to be used by people accompanying the patients. For every patient we saw there were 3 people coming to the hospital. So the whole planning, the facade systems, the landscape had to merge with each other. And that's how this was the endeavor where we did it. You see this typical kind of 4 levels of terrace gardens, which we termed as healing gardens. With each healing gardens, my facade philosophy had to change. It had to be a reflection to what we are doing outside so that it can be replicated towards inside. At the same time, the dominance of the whole facade, which is dominating on the main highway itself, had to be encompassed in such a way that the whole vision remained always clear to the people, so that it's noticeable. And similarly, on the terrace, when you go, it should look organized so that people on the upper floors do not look like a drab pathways or driveways, which you generally see in most of the best of hospitals in and around India. So those were the particular things that each and every part was looked into. So I won't say that I had a single solution for the whole thing. I think Upendra was our facade consultant, and we had a tough time, in putting up the kind of materials, the kind of detailings to encompass all these versatile datas which we had or which we have thought of to put it into one particular project. So going from outside to inside, again, the language had to be repeated itself. So similarly, we had used lot many projects, elements which were used outside, which turned out to the inside. These are some of the interior views which have been created there. Then even the operation theater and all, I think I visited during my Armstrong visit to US in one of the hospitals where I think Armstrong and DuPont had collaborated for a CSR activity in which they had created suits made out of Armstrong ceiling and DuPont by itself. However, I mean, we had larger areas here, so at least the operation theaters, we tried to give that 100% hygienic and sterile environment using such kind of finishings and such kind of finishes in our facades and elevation treatments. Similarly goes with the room. So this is the kind of cantilevers which we're talking about, in which we had different lobbies. So we had an entrance lobby, if you see at the down portion where you see an escalator over there. So we had this as a 8 meters high volume, in which we created sort of a 6 meters long. I didn't want to go for mullions, and the whole pressure was in Johar to create such kind of systems. Glasswall was tackling with this particular thing, because immediately from semi-unitized, unitized to such kind of this thing, we used FS1 as a part of a solution for this particular thing, and the whole lobbies and everything looks so brilliant. I think next month it will be handed over for people, phase 2. These are the under construction photographs. If you see how the whole cantilever was working, you see the engineering, as soon as you go for such huge cantilevers, the engineering for glass facades also change. The moments and the kind of deflections which you anticipate are very different than most of the regular structures what we design. So that itself was a major challenge about the whole thing, which were to be incorporated along with the structural designs during the facade. We had whole structure in BIM, and somehow it took more than, it took unusually more time to finalize the right kind of detailing for this particular thing, and here we stand. So we had a composition of different material, like even the glazing. We wanted at the top level, I wanted a sort of a rhombus shape, diagonal shape cut glasses, which was the face of the particular facade. Then we had a vertical linears, grids kind of semi-unitized system which came in. Now, where the southern face was there, we worked on the louvers, horizontal and vertical louvers, which were very deep, I think 600 deep louvers which were created so that they becomes excellent sunshades for the whole project. And this is how we went out. The consolidation of facade was that we were working on 3 lakh square feet. I think this will be one of the largest Asia's project in which the solid surfaces like LG and DuPont can be used on the complete exteriors. Exterior does not have any composite panels or anything, just has 2 surface glass and solid surface. So we have, I think, 1.5 lakh square feet, 1,75,000 square feet of Korean, LG, which is used. Grey we couldn't get because of that war, and we had to get it from USA during this lockdown period, which was a challenge by itself. Now, each and every louver, as I said, when we do detailing and we incorporate inside with outside, how the facade detailing was used into this particular way, and each and every ingress of sunlight to the patients, all the common areas, we had different solutions for different spaces. So residential zone had louvers perhaps extending to 700 with some spacing. Mind you, we did detailing for each and every louvers, even the tilt, which should be horizontal, which should be at 20 degrees, to make sure that whatever we get inside should be most appropriate. So there were some case studies which we have in which we used our performance glass in and out on the systems. The challenge became the slab, and when this diagonal facade was going on, how to do a smoke shield and the detailing to handle that particular thing. So competitively, the interiors, we came out with different solutions. And because of these angles, the cantilevers went at 3 different extremes. There was some maximum extreme which was at around 3 meters also. There was a gap of 3 meters between the diagonal at the topmost floor and the slab which was created. So these were the challenges which we sort of were able to pick up in interiors. These are a couple of site photographs which we won, the values, the performance of each and every system. I won't say we did the performance only for the glass. I think we did the performance analysis for the whole structure by itself. So these are the shading coefficients as per standards, 0.1 to 0.9, where we were able to get at 0.21 at one of the faces. These were the typical detailed sections in which we saw the harvesting which were happening, the top details which we're working on. We also incorporate the lighting parts into these particular facades. So all these particular fins were actually elements which look like fins in the morning. By late evening, the lightings will play a very prominent role to keep the same impact on minds of people going here. Couple of coefficients, but in fins, why it should be 900, where 450, where 1050. I think we did case studies about these particular things. And technically, you cannot just quantify, you cannot just pick up your lucky numbers. You need to quantify quality and quantity by seeing what are the effects it has on the indoor light qualities. And similarly, as for in August, I think this was the phase. I think next month. So my special thanks to Mahimtura, SKM, Aluvision, Godrej, and of course Glasswall, who did the whole structure by this thing. My next study is Panvel Municipal Corporation. Now this actually was a site which was, everybody had seen my NMMC head office, so I think all corporation wanted the corporation buildings to be equally strong, equally demanding, a good selfie point, I must say. So all these people wanted that things to be worked out like this. So Panvel, we had a competition last year, I think we won during COVID. And there is where we started it. Unfortunately, it was not as good a site in terms of location as I had in Palm Beach Road for Navi Mumbai Corporation. But nevertheless, I think where the challenge comes, the opportunity also shows the way. So we took a particular concept in which the site was dominated by a flyover from one side, which goes to Pune. And the site a little looks submerged down with the eye level, So, but anyway, we started with the concept of national emblem of India. We had different concepts talking to us, to the clients, which way we wanted the pride in Swadesh Bharat as a part of our communication skills for the facade. And the derivation of this particular thing started where we had the emblem, and we deciphered the elements of emblem into different particular parts. And that is how the whole story evolved about how the horses have been placed, how your bull horses and lion synergize with the bottom of the album, and that's how we try to replicate each and every volume of the spaces which we create till 50 meters high structure. Very interesting again, I don't know, somewhere down the line I've seen government has lots of fascination about these domes. So I was not able to convince anybody that we should try something else. So dome had to be there. So anyway, so what we did was we saw the site. It was open from 3 sides. Again, I want to give impact. The impact of any facade starts from the contextual location of a project where it is happening. I mean, maybe the solution for a corner plot may be different than a solution for this particular plot. So in this particular case, I was open from 3 sides by the roads and highways. So that means any structure what we want to design, I couldn't have called the elevation as front elevation or back elevation. All elevation had to be front elevation, or the facade which had equal importance from all the 4 sides, because finally everybody wanted such kind of civic buildings as monumental buildings. So that is what the basic thing started with. Again, we created that 4 horses we replicated into 4 different arms of the whole thing. We had a central atriums. We had the facade, the brown kind of screen wall which you see was like the emblem which we had horses, and the total philosophy of the emblem which rotated around the emblem. So it was replicated again with the flag which was very dominating, which is very dominating location. Then we had different features. We realized what we missed out in certain thing. In NMC head office, for example, I thought we lacked some spaces where the services became a problem in little time, in passage of time, in a decade's time. So you learn from your processes. So you added more catwalks in the elevation. We added more facade sunshades in the elevation. And again, the philosophy remained the same. So all these particular sections were actually worked out together to come out with a prominent solution about how the facade should be incorporated so that indoor air quality as well as light quality, again, as I may be repeating again myself, it gets enhanced by it. So I had a feeling that inside and outside should actually flow with each other. And that's how we came up with this particular thing. Here we have around 19,000 square meters of facade. The glass dome at the top covers around 20,000 square feet area. We had the top ribs, which we have tried GFRC earlier, which came out to be a good solution because I was able to match the color content of my stone cladding with this particular material. So we restricted ourselves to GFRC for the particular thing. Similarly, we have columnades and the huge cantilevers, which gave a good shaded portion and the prominence to the elevation for the whole central circle of Mahasabha halls, which have been placed for all the mayors and all those assembly things where all the major decisions happen for the city. Then on the vertical, if you see, we've divided the whole bottom mast to the top mast with a strip glazing, in which we have placed, again, with the same kind of thing. So we avoided such kind of different masses at the lower level. So we gave it clean because we were able to get a good chhaja and a sunbreaker to avoid any kind of solar intensity happening inside. And mind you, all the 4 sites have actually different solutions, though the characters which we have used remains the same in the whole say. Similarly, I think we did again the analysis in which we have used performance glasses for the whole particular project. And Jali and sunshades play a very important role in the whole enveloping strategy, which actually makes the indoor quality, indoor light quality a very prominent importance. So the idea was that wherever the glares are, again, one of the major sides was south sides. I think something wrong with my vastu that we always get south-facing plots. But south sides become very important because there's the time when you need to actually analyze the building the most of its aptness and efficiency. So these are a couple of columns, the kind of treatments which we have done. We actually wanted to have very delicate kind of elements which break such bold masses throughout. So we actually created these huge projections with perforations. Then we had the lobbies, which were frameless. Again, 5-meter tall glasses to be used. Again, value engineered to see because they were inside the particular huge podiums. So we created the clean glass and all those kind of things to make sure the glasses are efficient to the requirements of the space, the need of the space. Again, we tried to go for circular domes, but I think finally we have because of some geometries which were created on the top, we were able to come up with a solution, elliptical domes. Again, which have fabricated steel structures for skylights. We recoated glass and having the thermal performance. So I want this particular glass, the space inside this particular glass to be a city museum later on. Maybe in the next phase when we are entering into doing something spectacular. Again, the team here, thanks to the team, Mahimtura, Anil Verma and Eluvisions. They're a great team to work with, and I think hopefully this comes as good as what we are hoping this to be. Now, talking about third. So story goes like this, that 2008-9, I was appointed to design a garden, 28 acres garden. So it was supposed to be a dump ground for the city in Nerul. And when we started this particular designing, we did found that there were 3 major environmental parameters which were not looked into by, or which were compromised by different authorities. There was an existing lake, which was Talao, which was there in the garden, which we came to know through some village maps. This place, there should be a Talao. And we started our cleaning process of the particular site with that. And we found that there was a Talao, which had dried up, of course, because all the mess which was there. And we thought that let that be the concept of my landscape garden. And going flows, a whole garden was designed in such a way that we increased the depth of the pond. We had the complete flow of all 40 acres in and around that building going towards that particular pond. So the pond eventually, after handing over 8 years before, the pond is a perennial pond. Simultaneously, I thought there needs to be a meaningful project within this particular 28 acres garden. So in 2010, we had decided that we allocated one particular plot for a museum. Navi Mumbai doesn't have a museum, and as a Navi Mumbaiker, I always had a pinch that I don't have a museum or a science center for various reasons. So 2018 or 19, I think, 19, we got this particular thing that finally our concept was approved. And then we started with the concept that what it should talk about. So we thought let's 6 more impactful things which can impact human being, life, energy, machines, space and environment. So those particular kind of concepts, we started moving things around, the whole concept. And with whole that garden, if you see this particular impact, this particular plot was a leftover plot which we had designated for this particular space. Irony was that the rear portion or the southern portion of this particular plot already had fire brigades and all those kind of structures which were existing. So the challenge was what should be the architecture of this particular thing. Planning is fine, I know, understand, the floor plannings can be divided. The storyline was that what should be the part of the building, how it can become impactful, because definitely for museums, I'm not going to go multi-storied building. So maybe 3 floors or 4 floors maximum. At the same time, when I see the 4 floors is being dominated by my fire brigades and fire stations on one side, so automatically the answer came that it has to be a facade which has to be enjoyed or celebrated by people who come to the Wonders Park. So the name of the park is Wonders Park. So we started with those particular things, and step by step, the plot started talking to us. We started talking to the plot again and again, adding so many things and drama to the whole thing to make sure that this project does not get rejected by the authorities. So that's where we started. So we actually thought, playground, I mean, we didn't have any definitive form for the playground, so let that get replicated in this design itself. So it's going to be a build form with 4 walls. So let's eliminate a concept of 4 walls. So let it be a free-flowing energy, a space which defines that kind of energy. So we took a very amoebic form for the whole particular project. Then we didn't want any walls anywhere, so we thought whatever envelope we do it with, it should be one envelope starting from ground floor going to the top floor and So I didn't want any walls or any floors kind of defined from outside for the building inside. So we thought that let's have the complete structure steel be a part which envelopes the whole space inside. Then we had the massing, in which we thought, how do we create like southern faces and other areas where we needed the shades to be there for the even the for the elements which are going to be inside. I needed some spaces where I was not very happy with the kind of direct lighting which I was getting. So we actually envisaged a particular fabric, and I think the fabric is still being designed because it gets correlated with the elements which we are going to put in, exhibits which are going to put in the science center. So this fabric, if you see, the facade skin has undergone many changes, and will be taking, I'll be taking more time to define each and every puncture which gets included in this thing once our exhibits are ready. So this is how the whole mass came in with different floors and with different levels of interventions which we were taking care of. Parking again becomes a very important part because we didn't have much additional parking for this thing, so we had to raise the whole structure to the upper level and then start the whole structure from the podium and so on. So this is the kind of thing. So what we thought was the stilt was looking out of context with the particular project. So we had of course in the view it's not there, but we have a very heavy foliage in around the whole structure, which is defined with the same amoebic form, which is going to be formulated in the whole structure. So again, this was a sketch earlier when we were discussing and putting exhibits in different level. Now we are having these are multiple seams which we were trying to create out of the materials which are available. Again, not forgetting that this is a government project and we are tight on budgets all the time. So we were trying to work out the materials which would come in. I think again, Upendra and we broke our heads to a number of solutions which could be there for the thing, and most importantly, the workability from the government contractors who might come in. So the decision was very important for us to what kind of things we need to go. So these are again the outside turning it to inside. So some of the interior spaces how we would envisage once the complete design gets ready. So these are the floor plans which I've created. These are actual renderings on the upper level, how we've created the whole volumes. Again, to check what kind of intensity of lighting and shades which get evolved out of this very prominent facade design. Again, escalators in the central core where we had created the whole circular staircase which goes around until the top level with the core which is inside, and the whole particular thing is being designed according to the same geometry or non-geometry, whatever. So this is how the different things look from inside, couple of SketchUp models. So the facade, you can say the external strategy was very simple. We wanted the solid surface on the top. Actual solid surface means we had various options where we can go, but considering that we were allotted only 100 crores for the whole project, we thought that we'll go for a simplified thing. So I think we're using Calzip now for the whole facade. The transparent roofing, we had options of the close to our heart was glass because of its performance and other things, but finally because of budget we went for TGU, a 3-layered Danplon for the whole facade. Now we're just working out because Calzip were able to do the 5D bending, which they said it's possible, but we're still working out the detailing with Danplon, that how we can break the segmental look of the whole thing when we put it across. Got it. I should be tired, yeah. Anyway, so we had the facade, so we had this glass on the vertical faces which we see from inside. Again, they were considered as a part of our interiors because I didn't want the glass to have its prominent look towards the whole volume, so I wanted it as transparent as possible. And again, I'm sure the AC will not be utilized 100% because finally, you know, whenever there's less people off the ACs in such kind of things, so we have kept a hybrid system, air cooling and this particular thing, depending upon what areas we are going to do. Spot cooling seemed to be a better option for this. And CalZip, of course, we had some design flexibility, costings, and witness of this particular thing itself was quite sort of dominating for us and tempting for us to use this for the roofing material. These are the final looks. Again, the similar kind of team, and that's all. Thank you. Bye-bye.
Thank you, Hiten. Our next talk is by Malvinder Singh Rooprai, who's going to be talking about designing laminated glass with advanced interlayers. He is the Senior Technical Program Manager, APAC region for Curare.
It's not working. Thank you very much, Mrinalini. Good afternoon, Mumbai. Good afternoon, Mumbai. Yeah, I think this room needs a little bit more of energy because I can understand it's a post-lunch session. So once again, good afternoon, Mumbai. Yeah, that's better. So my name is Malvinder, and I'm representing Curare here. And Curare is the leading manufacturer of the interlayers for laminated glass. So I have taken the liberty to modify the title of my today's presentation. It's redefining laminated glass with our advanced interlayers to make the content more apt with the title. Yeah. So as I mentioned that, we are the leading manufacturers of different types of interlayers for different applications of laminated glass. And you can see we have interlayers from safety, decorative, acoustic, security, and specialized applications. And today's presentation will have a special focus on security applications because we see the demand for security glazing is picking up. This is a new trend in the market because of the rising incidents of terrorism. Okay, so glass is a very versatile material, and because we hardly come across any building which is not making use of glass. Architects like to use glass because it gives a glamorous look to the building, and they have to consider a variety of design elements while selecting the right type of the glass for the building. So it could be the structural strength, the post-breakage strength, transparency, security, cost reduction. So different elements are there which need to be taken into consideration while deciding the right type of the glass for any application. So let's see if the glass is not selected correctly and it is not engineered properly, how the things can go wrong. Maybe some of you have seen this videos. 4 years back, this incident happened because the engineer, I believe, forgot to take into consideration the live loads that need to be considered for designing a balustrade. So quite often the live loads are given they are ignored. I come across so many inquiries where the clients are asking for, okay, I want to design a balustrade for so much given wind pressure. But quite often they forget to consider the live load, which is the primary function of any balustrade to make the people safe, on the other side. I have one more. People are enjoying the view outside. It's raining quite heavily. Not good, huh? Okay. So if you design the glass properly, you can do unimaginable things, Here is an example. This picture is from a glass exhibition which happened 6 years back in Germany. So the glass construction that has been used to support this load is just 2 layers of 2 mm HS glass. Just imagine only 2 mm thick glass. So of course, it's not only about the glass thickness, also the connections have to be designed properly. So it's a very good example that glass can be made to withstand unimaginable loads. Another one. So this is a working glass seesaw beam with no metal connections, all glass connections you can see here. And this has got 11 layers of low iron glass. It's a castellated beam, and the thickness of the beam is you can see at the end there are only 2 layers of the glass. it's a really a working model. People can actually, you can see the people are enjoying the ride over the seesaw. Yeah. So another beautiful application of curved glass, you can see this is a glass light which was demonstrated. So actually this was a demonstration of the capabilities of the laminator, how you can just read the radius of the glass is 450 mm. So such a tight radius of the glass was bent, and this shattered many myths that that our interlayer century glass, which is considered like a very stiff interlayer, and even that can be bent into a very tight radius. Yeah. So you may be wondering that what's a practical application of such applications. So yeah, so I will come to that as well. So because of the climate change applications, I mean, there are new applications are coming where glass barriers are coming into consideration. Like this is on the picture on the right-hand side from the US. Like US countries like considered as a very well-developed country where the drainage systems are believed to be excellent, But even in spite of that, because of the climate changes, even the facades are now required to be, capable of withstanding such high loads. You can just imagine the depth of the water on the other side. It's like almost 1 meter. So this hydrostatic pressure is expected to be, safely borne by the glazing here. And on your left-hand side, this is a test for the glass barrier. The middle glass panel is intentionally broken so that you can check the post-breakage or the residual strength of the glass, and it is still bearing the load safely. Yeah. The picture on the right-hand side is a very recent photograph from the Hurricane Ivan, which struck the Florida region very recently, last month only. Yeah. I think Mathieu also talked about this particular project where this is the largest carbon fiber roof which has been supported on all glass panels, and it has been designed in such a right way that even if alternate panel is broken, it can safely bear not only the self weight of the glass dome, but also very high earthquake loads, like magnitude is 8 on Richter scale, because San Francisco is known for very high seismic zone. And if you see the picture on the top, this gives an impression that the carbon fiber roof is floating in the air. Yeah. Yeah. So this is one project which we did in Hong Kong. Again, very tight radius for the glass panels, and the glass is anneal glass construction. So when you have anneal glass, that is considered to be the weakest form of the glass, and so it was able to sustain very high wind pressures up to 5.1 kPa, because not only the geometry helped achieve this high sustainability of the loads, but also the right selection of the interior was also important for 2 reasons. Because when you do the autoclave process, the high melt flow ratio of the interlayer, so that once the glass is put into the autoclave, the interlayer flows very well, and there are no pockets of air left over there. And the other one is highest edge stability. So when you have exposed edges to the environment, there is a high chance of interlayer picking up the moisture. Yeah. So when we talk about edge stability, what is edge stability? So once the laminates are exposed to the environment, depending upon the chemistry of the interlayer, it has a tendency to pick up the moisture. So we have a comparison of the standard PVB interlayer, which is shown by yellow line, and then we have the blue line for the stiff PVB or the structural PVB, and then we have the red line for century glass. On the y-axis of this graph, we have the edge stability number. So the lower the number, the higher or the more durable is the laminate when it is exposed to the environment. And on the x-axis, we have the duration in number of years. So you can see for century glass, the edge stability number remains 0. And on your right, you can see how this edge stability number is calculated. We can have more discussions. You can come down to our booth and we can explain in more details how this number is calculated. But just as of now, you just have to remember that whenever there is an open edge application, on like the picture you see over there, it is always recommended to choose an interlayer which has got the lowest edge stability number. Okay, then we move on to the security applications because of the rising incidents of terrorism, or maybe then someone public is doing some demonstration against the government. They are not happy with the system. We come across these kind of incidents when public is trying to loot the showrooms, whatever. We call this as forced entry, and this requires the glass to be resistant against incidents of vandalism, or then it could be fire attack, firearm attack, somebody is shooting a bullet, and then it can go even higher when we talk about some infrastructure building like airports or other important buildings where an explosion can happen outside the building. And how do we expect the glass to behave in such scenarios? So it is expected that the glass should have a long lifetime, less warranty claims, and lower reset and refurbishment costs, and it should be lightweight as well. Yeah. And transparency is of course important because it shouldn't develop some kind of defects which could be like fogginess in the interlayer. So, and its performance is durability, low density, good optics, and easier to process as well. Okay, so when we talk about security applications, BRGs or the bullet resistant glazings, these are very important. Or I would say this is the most common form of security glazing that we come across. And this is the conventional BRGs which are made with polycarbonate and polyurethane construction. So the polycarbonate sheet is put on the on the protected side, and sometimes it has got an anti-scratch hard coating as well. Yeah. Now we have come up with BRGs with advanced materials. Those advanced materials are, of course, one of the layer is sentry glass, and then we have on the protected side one special unique product which is called Spall Shield CPET, and its primary function is to prevent the splinter formation on the protected side. So CPET stands for coated PET film, yeah, and Spall Shield is our trade name for that. Yeah. Okay, so let's do a comparison. So as I mentioned, conventional BRGs are making use of multiple layers of glass and PVB, and whereas the advanced BRGs, they make use of sentry glass, and the sentry glass has got a high stiffness, so which enables down gauging of the glass thickness, so which means the BRGs made with advanced interlayers, they are much lighter, up to 20%. So polycarbonate is a good material when it comes to embedment depth of the bullet. So it is quite strong, but when it comes to durability, it doesn't perform so well, yeah, because it is bonded using a PU material with the glass, and PU is the weakest link in the BRG construction, yeah. Because PU is not able to withstand very high temperatures, so it fails to perform the mandatory test as per the EN ISO 12543 standard part 3. Yeah. And Spall Shield, this has a proven performance in working range of temperatures, and it passes the 16 hours high temperature test. Yeah. Yeah. Okay, so this is a very simple demonstration of what is embedment depth. So how long or how much is the penetration of the depth when it is shot into the interlayer. So we did this study on different types of interlayer by creating a block of different interlayers. So what you see in this picture is a block which has been created from PVB interlayer, and you can see the bullets entrapped in the block. So there is no glass over here, just PVB. Yeah. So this indicates how the test is done, just for your easier understanding. And this is the comparison here. So on the top, we have our Trocifol B200, which is PVB. So this has got an embedment depth of 75 mm, and sentry glass, it had its embedment depth almost half of that. It is 37 mm, and sentry glass extra, this is 31, and polycarbonate had the lowest embedment depth. So this is what I mentioned before, that polycarbonate is a good material when it comes to embedment depth, but not so durable when it is exposed to high temperatures. Yeah, so this is the test certificate as per the EN ISO standard for the high temperature test done on Spall Shield laminate. So nothing will happen if the Spall Shield laminate is exposed to these high temperatures. Yeah. So this is the unique or the unique selling point for spall shield as a material as for anti-spall solutions, because no other BRG can actually withstand these extreme temperatures. And when also BRGs can be exposed to a variety of chemical solutions when the glass is cleaned, let's say in automotive application, you can see the performance of acrylic and polycarbonate materials which are used as an alternate for achieving the no spall solutions. Yeah. And it has a proven abrasion resistance as well. Yeah. So we have been talking about polycarbonate as a material for BRG applications. So you can see this is hurricane resistant glazing done at one of an airport at Florida. So it's a glass clad polycarbonate solution, which means the polycarbonate layer has been used on the outside to prevent the windborne debris objects flying into the or making a penetration into the facade. So you can see then the durability of polycarbonate is a big question mark when it is exposed to the environment. Yeah. And this is how a facade done with spall shield on the outside in the same region, which is Florida, and after 28 years, and it is still looking great. So let me show you through a video what is spall shield. Yeah. So this is a video of a BRG glass which has been shot from, the camera is from 2 angles. So this is shot 1, this is this side from attack side, we would say. And let's see what happens on the protected side. So there is no splinter formation on the other side. Yeah. Shot number 2. So a lot of splinters on the attack side. Okay, then we move on to one step higher when we talk about blast resistant glazings. So here the impact could be even more severe, because when you have a blast happening outside the building, so all of a sudden the air pressure or the ambient air pressure rises in a few milliseconds, from 0 to so you get a big spike in the ambient air pressure, and then all of a sudden the pressure starts dropping down, and this is what we call as negative phase or the suction phase, and maximum damage to the facade happens to the negative phase. So such tests are very expensive, and we can simulate those conditions in the lab, and this is a shock tube test where you can save a lot of time, and there is no need to explode those explosives. You can simulate those in the lab itself. And also we have a very special software which is WinGuard, where you can you don't have to explode the bomb, so you can simulate the explosion and check the behavior of the glass construction, how it will behave, whether the glass will be broken, and if it is broken, then whether it will retain in the frame. So we can support you with those kind of analysis if you have the right input from your blast consultant who is involved in the project. So we will need the peak pressure, impulse, or the duration of the blast. Yeah. So when we talk about the behavior of the glazing, so this is how the behavior of the glazing has been categorized as per the GSA standards. So level 1 is the most safest level, where the glass is not broken at all. Level 2, the glass is broken but retained in the frame, and so on. So from level 1 to level 3A, these are the most commonly used levels. Okay, so then we move on to very important topic, which is Sentry glass versus SGP. If I go back to the history, DuPont invented this product, Sentry glass, in 1998, and the product was named as SentryGlass Plus. But later on, the name or the acronym SGP became so popular in the industry, people still love to call it as SGP. But SGP is not the official trade name, and the official trade name is only SentryGlass. So you have to be very, very careful when you specify SentryGlass in your projects, because if you call it as SGP, there is a high chance of the product getting used somewhere from China, which is not SentryGlass, but it's SGP. So you may be asking for SentryGlass, and they may be saying that, yeah, we do have SGP. You want SGP? Yes, we have it, yeah. So please be careful. If you really want that, if you want to get your client delivered the same product for which he is paying for, you need to be very careful what you write in your specifications, yeah. So Curare is the only company which has got the registered trade name called SentryGlass. So this is all from my side. Thank you very much. If you have any questions, please do visit our booth, and we will be happy to. Yeah, sure, please.
Just one small question.
Yeah.
What if Sentry is not available?
Yeah. So yeah, SentryGlass. Yeah, I do have to admit that there was a supply constraint with SentryGlass for a variety of reasons, because after the COVID period, the demand for SentryGlass, and not only SentryGlass, I would say most of the construction products, it was significantly high all over the world, not only in India, but all over the world. And I have to be honest that, for any company to sell its material, they will definitely sell it at locations where you get the maximum price, And China used to be the place where the price was the highest, So bulk of the supplies, those were getting diverted to China. So that was definitely one of the reasons. And the other reason was definitely there was, Dow is the company who is making the raw material for SentryGlass. And they had a supply crisis with the raw material, So they are making use of that raw material for some other applications. And we were getting lesser allocation with those raw materials, yeah. But now the things are getting streamlined, and now we are in a much better position than last year, yeah. So things are getting back to normal. Thank you.
Thank you, Malvinder. I'm sure you'll have a lot of queries coming your way outside. So better buck up. But our next session for the evening, we've got Rajan Govind, who is the director of BES Consultants, who's going to be talking about advanced design techniques for new age challenges.
Thank you. Good afternoon, all. A special thank you for our sponsors, organizer. Congratulations for 100th edition of Zak. Congratulations to Ahmed and his team. There are a lot of speakers. Great minds have spoken to me before. So I just run through, make a little bit of interesting, not too long. We can run through some techniques we have used, implemented, on project has been delivered. So we could see something in a real world. So it's not in metaverse or visual. Yeah. A very brief introduction about BES. We do facades, anything complex, interesting, we love to do it. And we work from office in Singapore and Mumbai. So we will run through a few of the topics where what is a complex, how do we crack the complex, something we can make it a buildable solutions. I could see there's two different approach, generally what we do here, which may work for a typical constructions. So you have pre-construction design, we have a concept, detailed design, maybe is resolved or not resolved. Unfortunately, it's passed to contractor to resolve it. This all happens. And then there's a construction stage. Contractors come in, design either adapt or design change or design scrapped and redo the design. So this all reality we have been facing it. And then there's an implementation. So this, everybody knows this process. So when it comes to something, a complex element or iconic element which has a complexity, then we feel it has to be dealt in different way. A typical approach won't be enough, where we have to do design once. So it's not multiple design team is working and abortive work is not efficient way of dealing with. So what we see based on our experience is when something iconic or something complex, we are building it, and we are building in India. So you have to rely on the skills, what we have as skills, we have to work with that. So we could see a construction design is very important before it's getting built. So we can't just start building it, something, oh, this is not working, can I go and measure? So which is not a good way in modern construction. So we have to have a lot of focus on, have a very well resolved design at the pre-construction stage. So this communication is important, especially when we do the complex design is communication, where the designers use computer or skills. Eventually it has to be translated to the site team. The site team, unfortunately, like automobile, we don't have a robots, we don't have a sophisticated. So we have a limited skills available at the site, and they don't know what is 3D, what is the design, whatever you're doing. So we have to translate. So communication is a key. Any communication is well going to the site, to the lowest skill, the design could be successfully implemented. So there's a project I want to go in detail, which this is a project I want to show with our experience, has been built. Project is called Brigade Tech Garden, which is a large development, about 3 million square foot. They just built this for a meeting room, like a facility. So we did a model construction, shop drawing, which is a construction designs. Whatever we have done is been constructed. So the approach for a complicated design or a 3D design is more important is approach, pre-plan. So you can't think anything or we can't change anything when you're at the site. We should have a form something practical versus aspirational. Something can be good in design, but it can't be built. So it has to be balanced between aspirational and realistic and understanding the limitations. So we still have lowest skill in construction industry. So we have to build it. And a solution to be able to implement with, as I said, low-tech skills. And construction documents. So it is not just a design and document. The designer should convey to the something buildable, how it will be installed, fabricated. There's a much more detailed focus on the construction documents. The skills we have used on this particular project, I will go on the next slide more in process. So we use, to build this geometry, we use Rhinos, Rhino 3D. And we use advanced tool which is basically scripting and coding with a Rhino. Rhino is only powerful if you use a lot of computer skills, which we have used it. And everything got construction. It goes to construction. So the 3D model, unfortunately, we all talk about 3D model, beam construction, all happening, but it is not going to the construction. The model is becoming a process. We do a model, and the model is dead. It's not going for construction because the contractor doesn't have a skill. So we have to do something better than this, means you have to give a construction drawings. So this particular geometry is evolved from this way. It's an ellipsoid, but it is not an ellipsoid. It is something similar to not an egg shape. It is not a symmetrical. So the process we did is, you could see there is an ellipse at the back, and there's another ellipse at the front. We have merged it, and we need to extend the footprint. So that's the process we have done it. What we have got from the architectural is a 3D renders. It's not a 3D model. It's a floor plate. We have built this. There are certain limitations, sizes, dimension is given. We have followed it. It basically is not an ellipse, not an ellipsoid. It's two ellipses. We have merged it, and the footprint has been extended. So the process, this is how we have evolved from that model. Yeah, the last slide you can see there's an ellipse and another ellipse, and the footprint has been enlarged. That's how we got this. And we have just to our interest, what was designed, what was built, we just checked and see. Until we get this, we are not satisfied. So we have to make sure what is designed in the computer, what the form has achieved. Otherwise, there will be a compromise. So this is a design process we can run through. It's a video. So this is part of the big development. We have the small buildings. It's about 21 meter and 53 meter long. This is the image we got from architect. This is a process starting in Rhino. If somebody familiar with the Rhino, everybody is working on a Revit. So it is done in a different platforms Rhino, where we check the planar. So anything curved, you need to check. It's not using the curved or bent glass. It's simple flat glass. So whatever you see, that's a power we have. You can build anything. You have a finest control on your model. So it is selecting the surface, and then we have a panel optimized. We can give some tolerance. We can't have a 1500 panels or different. So it's optimizing the panels here. So we can do any level of finer control with the software, with the tools. You can see the form is tested. So it is a planar surface. It's not a bent surface. And we export everything for a construction design. Whatever you see here need to be exported. This is all the glass dimension, center line dimension. We will get this construction dimensions. This process we are figuring out a lot of different ways we can modulate. So we know this model will not work for the curved. So there's a wider model, taller models. Because there is no time is involved, everything is done instantaneously. You can check in a second, so just click a buttons, you can see it. So we know this model will not work for that curved geometry. We have gone with the triangulated. A good thing is this 3D is going for construction, so it is not just stopped in the process. Just after the next iteration we have finalized, so it will have a triangulated panel. Yeah, we have done with the process. So this has an integrated model. It has a roof, structures, everything. In fact, the roof is done by the civil contractor, but everyone has used the one model. So we are going for a detailing, everything steel rafter, all detailed design here. So this are the GFC drawings. Is good for construction drawings. It's a one model. Everybody has used this for roofing contractor, steel works, everyone. So that's a process. Sorry. Okay, so we have then explored the different ways we can modulate. I think this is covered in the previous slide. I can skip it. But finally, this is achieved with a triangulate because we are not bending the glass. The easiest form to get is triangulated glass. But if you see the detail, if you put a triangulated on that geometry, it looks too dense. It's not a very big building. So we have decided to remove this member, and it is just a glass-to-glass joint, sealant joints. So it's still relying on the workmanship. This is just a design process we can run through. The structure is concrete structures they are building, and this roof is supported with this tree columns. A steel structure, so they all using, in fact the facade is not big area because we have done an integrated model. Steel contractor, concrete contractor, they all refer to one model. So this is the structure. Concrete, the good thing is the client has taken a conscious decision, they don't want to put a cladding. So they have gone with lightweight ferro-cement concrete, which is a sprayed concrete onto that shuttering, and they have done with the concrete. I think it's a better idea than cladding it. You will have a lot of workmanship problem when we do cladding here. So this structure. So what we see here, this is all supported by the main structure with the steel works. It's a metal roof with a lightweight concrete, and they have done mosaic tiles on the top. So these are the, actually these are the facade works. So everything below the ring beam is done by the facade contractors, different trade. All the steel work, those are two different contractors, but they all refer to the same model. Yeah. Glasses are triangle glass. There's no curved glass, it's a triangle glasses. Yeah, as you know, anybody work on a curved geometry, it brings a lot of complexity, like a portal, entrance door. A door must be straight. So how do you put a curved on the straight doors? The geometry comes very well. It is smooth. We don't see any kinks, and it has taken the smooth, even though it's not used curved glass. It's all straight glass. There are few other slides we can share. The things we have done are similar on many years before. There's a zinc cladding done on a shopping mall using the same technique like 6-7 years before we have done this. Same done. It's a diagrid geometry done with the same techniques using a rhino. And where glasses are triangle glasses, but it uses a diagrid structure. There's no aluminum frame here. Done by glass wall. There's a small project is done in park which is just completed. It looks simple, but it has a lot of different planar, and everything is sharp. So we have done this. It's just a second last slide. We do a lot of things interesting using the IT and our 3D design. So this is one of the tools we use internally where we want to automate the things. So 3D is powerful when you automate the things do faster. So we, just for our word interest or somebody interest for architects, we will run through with instantaneously. You can see a lot of options is generating. Everything happen in instant because in the fast world, we don't have to wait. So you can generate hundreds of options with this automated. Thank you. I still finished 7 minutes early. Thank you. Yeah.
Thank you. I think we all appreciate that. That was quick and very informative. Thank you so much. We will quickly move on to the next. We're going to try and catch up, but move on to the next session. I'd like to call upon Ashish Mittal. He's the Director for Engineering of Hilti India. And he will be talking about fire protection of curtain wall perimeter joint systems.
Okay, hello and good afternoon everyone. My name is Ashish Mittal. I am Engineering Director at Hilti India. And today the topic I am going to present in next 15-20 minutes is on curtain wall fire protection. But before I start my presentation, there is another important topic I quickly want to address, and this topic is about life safety. Now, this is not a new concept for us. We all know that today, all the modern buildings are designed based on the concepts of life safety. And when we say life safety, primarily, it is protecting and evacuating all the occupants of the building in emergencies of earthquake and fire, right? Now, a lot has been done in India on both these topics. Today, we have codes and standards, how to design earthquake-resistant buildings. And similarly, on fire safety also, codes and standards are ever evolving. But is it enough? Are we collectively as designers, consultants, contractors doing enough to ensure fire safety? Well, as per me, the answer is no, and I will prove it with some hard facts. On this slide, you see some numbers. There are numbers like 135,000 or 3,15,000, 25,000, 45%, 10%. If I start with first, any guesses from the audience, what's that number? 315,000. What is that number? Any guesses? And the topic I'm here talking about is fire safety. Okay, good guess. So the first number is the number of incidents, fire incidents in India that have been reported in last 10 years. So that means on an average, around 30,000 fire incidents happens in India. Now the second number, sir has already guessed. It is the number of deaths reported every year in India due to a fire. Now this fire can be any fire. It can be a building fire, house fire, oil and gas fire. Any guesses on what is 45%? okay? So 45% is the total. If let's say India collectively, if insurance companies are paying 100 rupees for various types of insurances, out of 100, 45% of the money they are claiming or giving against the fire losses or losses caused by fire. And one hard real fact today, that only 10% of the buildings, I'm talking about existing buildings, abide to all the codal requirements laid as per NBC and other international codes and standards for fire stop. All of this could have been prevented, no deaths, no fire incident, if we would have proper fire safety measures in place. And when I say fire safety measures, I'm not talking only about fire brigade or firefighters. In fact, there was a famous quote by one of the firefighters who said, firefighters should be our last line of defense. That if nothing is working, then only we should call firefighters. Now these numbers gives us a reflection, there is still a lot to be done. And fire safety as a topic is highly critical. And it's even more critical when we talk about complex constructions. And one of the examples of complex constructions is high-rise building. Now high-rise is not a new trend, it is, I would say, the new normal. With more urbanization and more limitation of space, high-rise is a new trend, is a normal trend. If we just look Mumbai as a city as an example, there are more than 200 skyscrapers and over 12,000 high-rise constructed buildings just in Mumbai, which makes Mumbai 7th place in the world in terms of existing and upcoming high-rise construction. When we talk about high-rise construction, there are many advantages with respect to high-rise buildings, but with higher advantages also comes higher responsibilities. I hope you have all seen Spider-Man movies. There was a famous dialogue, with greater powers come greater responsibilities, right? Similarly, if you are talking about high-rise construction, fire safety becomes one of the most important elements for the building design. And when we talk about fire safety, primarily there are three things we need to ensure. And this is a very common fire triangle I hope everyone would have seen in their, through some presentations or some seminars. We always talk about detection, that as soon as there is a fire in building, do we have the right active system in form of smoke alarms, sprinkler, the fire alarms in place? The second is suppression. Do we have fire extinguishers? Do we have the fire sprinklers working in place? And then also one principle on which all the buildings are designed is containment. That if there is a fire in this place, can we just contain it to this place for, let's say, 1 or 2 hours till the time fire brigade arrives and all the people in the adjacent rooms can evacuate the building safely. And these are some of the common systems that we use. I already mentioned for active fire protection, there are sprinklers, there are alarms. When we talk about passive fire protection, commonly known systems that we all know, fire doors, fire dampeners. But I'm sure all of you are also aware about fire stop system. But through this presentation, I just want to highlight that maybe enough emphasis is not given on this topic, what is a fire stop system and how it is a very much integrated part of overall fire safety. Now, what is fire stop system? I would like to explain you through a small video. Now this video just showed us what are the different openings in a building that has to be sealed properly, otherwise fire and smoke can travel from one compartment to another compartment in case of a fire. These are some of the examples. Whenever you have electrical services passing from one room to another, from one floor to another, wherever there is a gap, that gap has to be sealed with the proper fire rated material. Similarly, for mixed penetration, curtain wall, mechanical openings, pipe penetration, and also the top of the wall joint. Considering the theme of the event, which is Zak Façade, I would like to focus more on one application, which is curtain wall joint. Now, what is a curtain wall joint? A very simple description or visualization can be this, where the gray portion, the interior you can imagine as a concrete slab, and the blue vertical you can imagine as a curtain wall. It can be a glass facade. Now, whenever there is a glass facade installed on a building, there is always a gap between the floor slab and the glass facade. Now, imagine if there is a fire, let's say at this level, right? There is a concrete floor, there is a glass facade. If this gap is not sealed properly, the fire and the toxic gases, the smoke can travel from the bottom floor to the top floor, right? So this gap has to be sealed very properly, right? Now this is one mechanism by which the fire and the smoke can travel from level down to level up. There are other two mechanisms also, which are one commonly known as frog leap effect. That means if there is a fire at, let's say, lower level, the fire and the smoke create so much pressure that they breaks the glass, and through this glass, the smoke and the toxic gases one more time creates more pressure on the top glass and further enters into the upper floor, right? And then there is a third mechanism through which the fire can itself burn the entire facade and can propagate to the upper floors. But for today's discussion, we would focus more on how to properly seal this gap between the floor, the RCC floor, and the glass facade. Now, we are all familiar, I'm sure, about this incident that has happened in London. Unfortunate incident happened in 2017 with Grenfell Tower. This was one of the examples where the facade burned first, and then the fire propagated to the interiors of the building, right? Now, the question that comes in front of us, are we prepared to avoid such fire incidents in India? Does a building have fire protection measure in accordance to the National Building Code? And finally, most important question, all of us should answer all the time, how can we continuously put our efforts in saving life, protecting assets, and enhancing building performance all the time, right? Now, there are solutions available, and these solutions are not only that I'm from Hilti, I'm talking about that. In fact, the Bureau of Indian Standards have also recognized that this is one of the critical applications, fire stopping, and we have some code standards and certifications in place. So first, I will quickly talk about code. What is a code? Basically, in India, for any building construction, we follow National Building Code, NBC 2016. Code, basically in simple words, we can say, it tells us what needs to be done. Now, the code tells us that fire sealing needs to be done, right? What is a standard? The standard tells us how it has to be done, right? So in a simple terminology, you can read code as a what part and standard as a how part. Now for this example, this application which I just talked about, this curtain wall application, if you have to seal this gap, so first of all, NBC says that this gap has to be sealed, right? So code has done its job. Standard says how it has to be sealed. Unfortunately, in India today, as on today, we do not have any standard on this application. We have standard for through penetration and for many other fire application, but as on date, we do not have any standard which tells us how to seal this application when you have this perimeter, this curtain wall joint. And that's why in absence of Indian standards, we sometimes, we most of the times follows UL guidelines and American ASTM guidelines, and I will tell you why we follow these guidelines. And then finally, if a product has been tested as per these standards, there is an approval and certification which is required. Now, one of the most important reasons why certifications and approvals are required, there are in fact two reasons. First reason I will tell you, or in fact it's my question to the audience, unlike many products that we test at the job site, can we do a fire test at the job site to test our product performance? So we do a lot of testing at the job sites, right, to check the product performance. Can we test a product, fire-related product at the job site? Can we simulate a real fire on the job site just to do a testing? It's difficult. It's almost impossible. You would not like to burn your building just to test a fire product, right? So since we cannot simulate a fire condition at the job site, we have to rely on certain labs, certain institutes, which helps us in getting those approvals. This is the first most reason. Second, third-party approvals or third-party agencies like UL Intertech, they provide that genuinity and neutrality in the certification. It is not, they are not influenced by vendors or manufacturers. So if I go to UL and if I tell them that, please, I have developed this product, can you test it under this system for a 2-hour fire rating? They will test and they will give me a report of pass or fail. They will not just give me a report of pass. So if my product doesn't comply to this standard, they will not approve it, right? So having proper certifications and approval for a product guarantees the performance of that product and assures you that it has been tested by the right agencies, by the competent agencies, and not by any manufacturers. Now, just to go in bit detail, I talked about NBC. So NBC 2016 clearly says that all gap between, and I'm just reading it, all gaps between floor, slab, and facade assembly shall be sealed at all levels by approved fire-resistant sealant material of equal fire rating of that of floor slab to prevent fire and smoke propagation from one floor to another. Now this is clearly written in NBC 2016, which is the what part. As I mentioned, how part is still missing. So in that case, as on date, we rely on ASTME, which are American guidelines, and to test this assembly of curtain wall, this is the standard that is being followed, ASTME E2307, which tells us how to test this assembly and how to provide a fire certification for a product under these challenging conditions. Now, if I talk about this curtain wall application, clearly you would not want your fire to propagate, you would not want your smoke to propagate. Is there any other dimension you will be looking for this product? Any idea, audience? Sorry? Sorry? Droplets, okay. Okay, very good. Anything else? Okay, maybe one more I can tell. So we know high-rise construction and there's always some kind of expansion contraction that happens because of temperature, because of winds, and maybe because of seismic. So you will also want this system should not collapse. Imagine there is 2 mm expansion, you will not want this system to go down, it should remain intact. So there is one more additional attribute that is as per part of ASTME testing, which is called movement capability. And I will just show you a quick example. If you can look at this video, it is basically checking that this sealant which you are using for this joint should also have that movement capability so that it can withstand that expansion and contraction. Now, this is not all. As I said that for curtain wall application, NBC says it has to be done. In India, we do not have a standard which talks about how part, so we follow ASTME standards. And a lot of time, designers and architects, contractors often tell us that, you know, this is India, why should we follow ASTME? Our common reply is that BIS is working on a standard and it should be rolled out soon, but we cannot wait till eternity till BIS comes with a standard. So as a manufacturer, what we also do, we also partnered with IIT Gandhinagar, which is one of the most premier institutes in India, on this topic over last 3 years. And just 2 months ago, we conducted a big workshop with them on the topic of design, installation, and inspection of perimeter and through penetration. After the workshop, we actually did a fire simulation. So this is a real building constructed in the premises of IIT Gandhinagar. You can see side B and side A. One of the sides, we put the right tested system, which is a Hilti system as per US and ASTM certification. And one of the sides, it was conventional system. Conventional system is just fill that gap with any wool or just put the GI sheet, no fire sealant, right? We did the testing, the results are still awaited, but primarily in that 5 minutes, what we can see that with a proper system, the smoke was not able to travel to the upper compartment, and with the non-tested system, the smoke propagation was so fast that within 5 minutes, the upper floor were filled with smoke. And this was also highlighted by IIT. There was an article which was published in Times of India. It was written by IIT Gandhinagar, one of the professors, on the significance of fire stop system and establishing that why proper fire sealing needs to be done at all levels if you talk about curtain wall application. These are some of the solutions that Hilti offer. As a designer, as a facade contractor, if you have spander glass, then also the Hilti system, the Hilti sealant system works in a different configuration. And even if you have 100% visible glass, then also we can design that system for 2 hours fire rating as per your requirements. Overall, just to summarize, there is a critical need to address this fire stop topic in our industry, and I would request all the designers, architects, contractors sitting in the room to start emphasizing also on this topic in your buildings, and how Hilti can support you. Hilti can support you in end-to-end, right from the design stage. We can come and we can discuss with you on the proper design of the system. If there is no standard certification available, Hilti also do an engineering judgment. For the installation stage, we have our trained installers, which are called HFSCs, Hilti accredited fire stop installers, who can come and do this application. And finally, for the inspection and management, we also provide with professional report that can be used at the time of execution and even post-execution also. Last slide from my side. If you want to learn more on this topic, if you want to get more knowledge on this topic, Hilti has done one more initiative. We have published a book. This is a Hilti, written by one of the Hilti employees. The book name itself is Fire Stopping Everything You Need to Know. Hard copies are available on request, and soft copies can be downloaded on Hilti India website. And there's also a firefighter's handbook that we have recently published just for the firefighters. So this was my time. Thank you so much. Any questions? Yeah.
Thank you so much, Ashish. I think that was very informative and important. We don't pay enough attention to these things in the built environment. If you do have any questions, please feel free to approach any of our speakers outside in the networking area. We will go on to our next session. I would like to call upon Nivedita Vibhaw. She's the head of business development and marketing at Fundamax India, and she's going to be addressing cladding high-rise buildings.
Thank you, Brunalini. I hope I'm audible. Yeah. So good evening, ladies and gentlemen. And as Malvinder was mentioning, the session after lunch and before the networking tea is always a challenge. And I'm sure that you all would agree with me on this, right? So once again, a very good evening. And as Brunalini already said, introduced me, I represent Fundamax for you to create not something which you are not aware of, because we've been in this journey for long, since the World of Façades started. I'll just take a moment to congratulate the World of Façades team. You guys did a commendable job over the 10 years we've been, and all of us would agree who are here that it becomes synonymous to the word facade. So not to take much of your time, can we please have the AV to tell you about Fundamax. It's one of the leading brands in the HPL industry, and a brand which is having design at its crux. So we will run a short AV to tell you what Fundamax is. AV, please.
Design is where aesthetics meets functionality, where beauty touches the surface. It is art making itself useful, touching the heart all the while. Individuality is what we want to offer. Uniqueness is what you make it. We see ourselves as co-designers of your design wishes. That's how we become partners in your success. Our origin is the book in which we turn the pages to read the future. Since we know where we come from, we also know where we want to go. Our products know it too. They want to find their way to you. Perfection is more than a claim to our skills. It is our way of showing respect for natural raw materials. Our way of bringing production and processing to perfection. Change has been our constant for 130 years, and we're doing it again. We change, we think ahead. We are open for new things, for inspiration, for innovation, and collaboration. Open for you, and open for you to create.
So this is Fundamax for you, ladies and gentlemen. 15 years in India with more than 15,000 projects and 1.5 million square meters, which has already been done. And what a better place to be in Mumbai and talking about high-rises cladding. So we have done umpteen number of projects as far as high-rises are concerned, and today we're going to be talking about cladding high-rises, the prerequisites which are required for cladding high-rises. So can we please move on to the presentation? So this is what we're going to be presenting to you. To take a snapshot of the history of world's tallest skyscrapers, I don't think we are unaware of this particular fact. And this is the history. You can see, where we started. The definition of high-rises and skyscrapers has changed. We still find it to be a thin line of difference as we say skyscrapers, but yeah, of course, there's a difference between high-rises and skyscrapers, right? So you can see at the moment, the Burj is the tallest which we have. Not much to talk about this. It's known, nothing new, no rocket science. To give you a snapshot of high-rises, and especially in the Indian landscape, some statistics, some figures to throw. Mumbai has the highest number of high-rises. It's 6th in the world for skyscrapers. 200 skyscrapers and 12,000 high-rises, which you have in this particular city. I'm sure many of you know, but thanks to Google for giving us the figures. I would not debate on the figures because I do not know if they are right or wrong, but I'm sure that they are. Yeah. So 52% surge in the number of high-rises in India. Ladies and gentlemen, I was myself appalled when I was going through the statistics, and there is a dip. It used to be 63%, and post-pandemic, it's like gone a bit less, and now we are at 52%, the number of high-rises we are designing and we are having in our country, the surge. I'm talking about India, please, noted. The Palais Royal in Mumbai, and I'm sure people who are from Mumbai would know that this is the longest. It stands tall at 320 meters, and it's soon going to be replaced by Imperial 3 again. Information from Google. So I hope, and if anybody can correct me, I'm hoping it's correct that Imperial 3 is going to be 396 meters, which we're talking about. So you can understand the length and the height we're talking about. Sky is not the limit. Glass and MCM are the most highly used cladding material which we often see in high-rises, and I'm sure that you all will be agreeing to this, that the glass, everywhere it's glass, it's ACP, the aluminum composite panels, and of course other metal cladding which we often see in high-rises. So if any one of you who are not from Mumbai and haven't seen, this is the Palais Royal which we're talking about, right? It's still under construction if I'm not wrong. Not? All right, okay. So prerequisites of a high-rise building, ladies and gentlemen. Aesthetics. As we say, in the vernacular, jo dikhta hai, wo bikta hai, right? And we definitely, to give the identity, to give that individuality to facades, we, architects, as designers, you definitely pay a lot of attention to how the look and feel is going to be, because these are addresses, these are high-rises, and one would want to use the best of material which enhance the aesthetic of your high-rises. Energy efficiency, right? We're talking about sustainability. We're talking about, environment. We're talking about protection, fire behavior. Ashish gave a wonderful presentation on fire behavior too, right? So energy efficiency is very crucial and a very, very important factor when we do designing, and it's definitely a prerequisite for a high-rise, not only a high-rise, but any other design and architecture which in today's world is required. Wind load, not talk much into the technicalities, we will cover it as we go ahead. Fire behavior, I think many of us have seen, I mean, you know, and just now, the previous presentation, you saw the Grenfell tragedy, which he talked about also, so very crucial, very important for high-rises. Ease in installation. Yeah, I'm sure you would agree that there's a lot of cost, labor, and everything when we talk about, you know, installing and vis-a-vis different kinds of materials which are used in cladding. Of course, you know, one of the materials which Fundamax makes, manufactures, has got this ease in installing and maintenance, right? So these are broadly the prerequisites which we require when we design the high-rises. Moving ahead. Aesthetics, crucial as we said. At Fundamax, we have a very unique material which gives the design fraternity the liberty to choose the decors. It's not that monotony. We believe in breaking the monotony which has been there for long, since decades, since years. And we take pride in saying that our legacy is making new decors, new options, new textures, right, for you to use and break that monotony of facade and cladding. So we have more than 100 plus decor options for you to choose, unparalleled features of flame retardance, impact, solvent resistance, crash resistant, all of it, right? And as all of us have been speaking, you know, your facade is your outer view. Your facade is your identity, right? And to impart that character to the building, you would definitely go for the best. And we give you that option, we give you that liberty, we give you that freedom to choose the right one. Energy efficiency, we believe in the concept of rear ventilation, and we call Fundamax panels as the breathing facade, right? Because we leave gaps. As you can see from this, it's a very, very simple diagram or a sketch which just tells you that, you know, we believe we give solution, you know, to design and customize your buildings for energy efficiency. We are adopting, we were rather, you know, one of those organizations which in India got into the rear ventilation concept also, wherein we say that we leave gaps between the panels so that, you know, there is ample scope for the panels to expand, contract, and of course the air to circulate, which in turn reduces your air conditioning costs and all of it. So from the cost perspective also, that's taken care of. Wind load. Of course, high rises, you know, you have to be very, very cautious and careful when, you know, the materials are used. So we have the technical expertise to do the wind tunnel analysis, all the simulations and stuff, to ensure that there is no issue as far as the high rises are concerned and when you're using panels like these. And the beauty is that we have different thicknesses for us, you know, available at the moment, which you can use as far as the panels are concerned. And you can see the structure. We have just given a short glimpse of that, wherein, as per the wind load, we do all calculations, and we also give you the solution for the structure behind. So it is not a rocket science, not at all. And we have had enough discussions and presentations which talked about, you know, the substructure and things. So this also is taken care. I would not elaborate much on this, but just to tell you that we have a portfolio which consists of both A-class and B-class material. We have a special product called the Fundamax M Look, which is A2 material, and it contributes a lot as far as, you know, safety is concerned. Worldwide, there have been umpteen number of projects which have been done using the M Look panels from Fundamax, and it has very well fared at places, at locations where there is a high risk of fire. And we have, anyways, when we do the designing, when the technical team gets into it, we use the fire seal and the smoke seal at relevant locations wherever it's required. I already talked about the M-Look, and Fundamax's panels are also B-class, so there's a lot of flame retardance property which they have. So safety is taken care of in all spheres and in all aspects. Faster construction, undoubtedly, there's no curing period because the material is a new age material. installation because, we can also do a unitized system. We can do it at our location, at the factory, and then get it installed. That's what we can do. We have customized solution. If you have a design, if you have certain requirements which which is required for the building or the high-rise, our design team is going to be helping you with the solution which is required. And of course, it's ideal for the PFBs and the PEBs both. Maintenance, hardly any maintenance, ladies and gentlemen. I cannot say it's no maintenance, but trust me, it's a no maintenance product. It's not like a glass or any other product wherein you require that frequent cleaning, and you have the manpower requirement for cleaning it very regularly, otherwise it looks shoddy and shabby. But you can just install it and forget it, and it looks amazing for that matter. Lower costs and better resilience. Apart from high-rises, which we have anyways been doing for quite some time now, the other applications where you can also try the Funamax panels, just to give you a glimpse of those in facade, you can see, just to give a facelift, different sunshade systems, different colors with perforations and all of it. Sunshades, as I said, it's very, very much used, as far as Funamax panels are concerned in the building and the design. Perforation, we can do a lot of perforation as well as far as the facade is concerned, as per the design. So there is no constraint in doing the perforation, and yet the strength and the durability can be maintained. Soffit, we were just having a discussion outside, and there was a lot of question on, if you could do the soffit application, you could do the ceilings. Of course, we have special systems which are designed to cater to this particular application, and the entire solution is given. If you can drop by, you can also see we have the small mock-ups which could show you that how the installation can be done for that. More than 20 plus floors, and we have done the cladding, right? And we take pride it stands tall, the building. It's been more than 10 years of these buildings, and you can see they stand like this. Applications like this where we segment the panels and give a different look to it. Entrance arches. So there's a lot of design freedom which is allowed. You can think of it and we give you the solution for it. So it's nothing impossible when it comes to these panels, because it's a new age material, as I said, and there's a lot of scope for designing, a lot of freedom which we impart, and there's a lot of solution too which we give as far as the panels are concerned and the design is concerned. So all I would say, not taking much of your time, let's design for the present with an awareness of the past, because future is essentially unknown, ladies and gentlemen. We have to be very, very careful and conscious when we select a material. It's not just about making a product and always talking about the costs and things, which definitely is pertinent in today's world. But as we saw in the previous presentation, that it's about safety, it's about security, it's about sustainability, and of course it's about durability too. So let's collaborate, to create designs, create architecture, create addresses which are long-lasting, which are durable, which are sustainable, and definitely would stand tall for the next generations to come. So thank you. As I said, let's collaborate to create better designs, and I would just want to run you through a few more applications which we have, which we just wanted to show. The other video, the other AV, please. Just running you through a few projects which we have.
Design.
Not this, the other one, please.
Is where aesthetics meets functionality, where beauty touches.
Thank you, ladies and gentlemen, and you have a great evening ahead.
Thank you, Nivedita. Loved how you talked about the past, present, and the future. Our next speaker is actually going to be talking about design and engineering importance in facades. We don't have Rahul with us this evening, but we've got Hitesha Thakur, who is the Vice President of Estimation and Technical, Yeah, for glass wall systems. So very warm welcome.
Hello, everyone. I know you were expecting Rahul to present this, but due to certain medical emergencies, he was not able to do. Please excuse me for certain fumbles or long pauses for this presentation. As you know, that facade trends are changing with every day. The evolution happened with more of solid facades than more of glass. It is inspired by nature, what you could see here. We sense, we respond, and we adapt. This is what we do in our day-to-day life, and similar thing what we do in facade designing too. By it, we mean just like any other skin, facade is a skin of the building. And similarly, it is sensed and it responds to the weather, and hence we need to design it appropriately so it adapts to the environment. There are certain stages involved in the design stage of a facade. There are, I could say, 5-stage process. One is to empathize, like to understand the intent and requirement of a facade. Every facade is different. Every facade is designed different from the conceptualized stage. The architect pursues certain things and we deliver certain things. So we need to know what is the intent of the facade. We need to define the viability of material. What materials we use in facade should be workable to the fullest. We should conceive the concepts from the sketches, what we receive from the clients. Of course, by means of that, we should not compromise on the performance of the facade. We should always do prototypes to know what we built should sustain. And of course, this testing. Every facade needs to be tested because it will be on the building for a long time, really long time. And it should undergo all the weathering effects. The performance of the facade depends on its integrity, thermal and physical qualities, and of course, the aesthetics of the facade. By integrity, we mean structural, like loads, all wind loads, dead loads, the movements what building takes, the thermal movements, then the moisture, the seismic movements, and of course the weather tightness we require for the facades. Then is the thermal and physical qualities of the facade. We should know what is the heat gain and loss, the fire resistance, of course, for the facade, the acoustics, which again plays an important role while we design certain facades for hotels, and of course the finishes. This plays an important role where we have to have the aesthetics, as we had seen a lot of presentations in the morning where architects has given a lot of importance to aesthetics of the building. So of course the aesthetics plays an important role in facade. Now when designing is a process, wherever you say, as architects design a building, even designing a facade is a process for everything. We develop it from a conceptual stage. We get certain concepts from the architects or the client, like what are the intents, how they need to do it. On basis of that, we prepare certain initial designs, which of course are more adapted to the concept. And then on that basis, the detailing of the facade system is done, like the calculations, the structural calculations. After designing a system, we should also know that it should be friendly in terms of execution. If you design certain thing and if it is not able to perform well on the shop floor or on the site, then the design is not of use. So execution also has to be taken care of. Manufacturing and assembly, that's what I was going into. Like if you design it, we need to know that it is executed well on site, it is manufactured well on the shop floor, and maintenance-wise, during the life size of the project, there is, the minimum maintenance required for that facade. Of course, for facades, you require maintenance and it should be done. But of course, we need to know what are the, wherever we can save on maintenance for these facades. How do you select, like selection of a facade? What criteria it depends on? It depends, of course, on the operational cost, then durability, and your entire life cycle of the facades. There are certain parameters we consider while designing it. Like, as I said, we get the intent from architects, the functionality, the stability of the facade, again, selection of a material, which is very important, the feasibility in terms of execution and maintenance of a facade, because once you build a facade, it has to see that it stays at least for the 40, 50 years on that building without it fading out, the building fading out. Again, the transport and panel mobility on site by means of site logistics. Value engineering, if you can do certain value engineering for a project where you can save cost in terms of a product or give a better solution to the project. Vandalism, of course, we have seen many abuses to the system because considering the facade, we have recently seen many structural systems in the, residential buildings. And during that, we have seen many of the interior person, abusing the exterior facade system, which tends to then leakages and all that, So we need to, again, educate our end users about it. Aesthetics of the facades is, again, what we said, very important. Then sustainability against the natural calamities. This is taken care in terms when we design a system, certain parameters are always considered, certain safety factors are always considered into it. Design and innovation and optimization, how do you optimize a facade to give a better result? And most important is the cost, because that is what the client always harps on. A building design, again, the climatic conditions, the humidity, because a facade design probably depends on the different zones. Acoustic requirements, seismic requirements. These are certain structural parameters we need to consider while designing a system. Selection of a material, which is very, very important. What goes on a building stays on a building. As I said, the facade should last for more than 50 years. So selection of a material plays a very important role. How do you select select something? Okay, aesthetics is a part of it. Then cost, of course, is a part of it. Then energy consumption, what does, that is a major component to it. So all these components needs to be studied, and then we can have an effective facade. As we see, there are a lot of LEED certification done on the facades recently. So to do that, we need to study all these criteria beforehand. As you know that you have electrochromic glass, media glass in the facade. So this is very beautiful. As you can see, On the right side, this is a clear glass, and the same glass can be tinted with just then certain, electromagnetic current passing through those glasses. So we have done a world largest project that is Google's headquarters in Bangalore with the electrochromic glass. The entire glass is electrochromic in this. If you can see, you can shade it as you want it. You can have it gradation or opaque. What does it do to you? It gives you more floor space because you can have your furniture close to your glass. No need of curtains or anything to, blinds, which again gives an ugly look from outside to the building. Some of the new materials we have, cotton steel, which again give a rustic effect to the building. Korean cladding, it gives very beautiful. Then terracotta, 100% natural material. Again, the amalgamation of glass and terracotta combination, it gives a very wonderful effect for a building. We need to know that there are certain limitations while manufacturing and logistics in terms of transport, constructability, handling. So while we design certain facades, we, of course, everybody likes to have larger panes of glasses where you have beautiful views from outside. But again, we need to know what are certain limitations. Are we able to manufacture those? Are we able to transport those? Are we able to construct those, handle those on site for installation? And then again is the replacement. One time, okay, fine, you do it, but can it be replaced if it is broken or if it is abused? So all these parameters needs to be known well while designing the facade. As I said, there are certain criteria we need to know while designing the facade, because what is the height and width of the system? Are they able to take those system to the particular height of the building? Again, the free-flowing structure, what you can see right below. A designer can design any free-flowing structure. We had seen in previous slides, in previous presentations also, beautiful free-flowing structures. But again, free-flowing structures require a lot of engineering and a lot of facade designing. Main is the movement, because you need to cater all the movements into that facade. So there is no air. So there is no air or water ingress inside the facade system. This is one of our projects we did in JW Marriott, Kolkata. This is a beautiful free-flowing facade where we have a cantilever 9-meter canopy. Nothing is impossible to design. Only thing is we need to know the proper criteria, parameters, and constructability to design a facade system. Of course, maintenance and plays an important part. We need to avoid damages while installing the facade, last-minute errors. Access equipment needs to be proper while installing. We need to know what are the access equipment going on the facade, which will give us good results in installation. And of course, the value engineering. Everybody looks for value engineering option, but many things that value engineering is just a cost cutting. But please, let me tell you, value engineering is not just a cost cutting. It is not without any technical compromise. We don't need to compromise on technical issues. Of course, we'll have a lot of variations which we can propose in the system. We need to have a better functionality, low cost, reduce risk at a later stage. As I said, facade takes many abuse during the course of time. What you could say, vandalism, external harsh weather, bomb blast, graffiti art. All this the facade takes, and we need to design certain facades which of course will be able to take we should sustain this parameters. So there are mechanisms that can cause a facade disintegration, roughly divided into 5 categories. One is the material defect, if you don't choose your material properly. Second, of course, is a design fault. If you are not designed your system correctly, then there are installation errors sometimes, environmental attacks, and of course damages which might be accidental or deliberate. Now, this is very important in terms of how do you select who is a proper facade contractor goes for your building. So there are certain things what you can look into, like what is the experience they have, what is the industry position they have, how many projects they have done of that scale, what is the design team this consists of, their factory setup, their site setup, their quality, safety, and past records, the client references. This is the timely completions, what mega projects they have done, any international projects they have done. So these are certain criteria one could go for a facade contractor qualification. And understanding from a facade contractor to what we do while we design a system, we understand, of course, the intent, the client's budget. Then on basis of that, we design a system, we engineer a system to it, which of course, passes all the structural calculations. We take the responsibility of the system, what we design and what we deliver on site. I think, thank you all.
Thank you, Hitesha. Some bad news, we're not going to break for coffee just as yet, in the interest of time, but what I have been told is that the wait is going to be worth your while for the break at the end of the session. So I'm going to call upon my next speaker. His name is Bhesania. He is the Director of Architecture at Talati and Partners, and he's going to be talking about solar facades.
Good evening, everyone. I would have preferred to have more of an audience here, but I'll try. And the worst part is to start after being given bad news that there is no break. I know your lower backs are already in pain. Well, I'll try to keep it as short as possible before we start hearing the bell. And I've been, I think, given 20 minutes. So I'll try not to keep you longer than 20. So firstly, yes, thank you, Zak, for having me here. Congratulations on your century. I'm going to talk about something which is very close to me personally as well. I'm going to talk about solar facades. Now, solar facades is a topic which you can't really summarize in the 20-minute span. And I'm not going to really, I wouldn't say bore you all more, but I'm not going to really focus on charts and facts and figures and calculations. I'll leave that for the experts. We have a lot of manufacturers, European manufacturers, all over the world for that matter, who are doing a stunning job. Every day they are redeveloping and they are finding new solutions for solar facades. So I'm not going to get into the absolute detail of solar facade. However, I am going to talk about the importance of solar facades from an architect's point of view, especially for a metro city like Mumbai. And I am going to talk about 2 project examples which I'm currently designing where we've tried to integrate solar facades in our projects. One is a commercial building and the other is a residential high-end tower, both in Mumbai. Funny thing, somebody told me outside, a former colleague of mine, that why is Talati talking at a facade show about solar facades? shouldn't you all be talking about how to convince clients to do golden bricks for claddings? I guess we have that kind of a reputation. But we are turning a new leaf at TPA as well, and sustainability is very much part of our design ethos. So I'm going to kick off with a fun fact. Did you know the amount of sunlight that strikes the earth for an hour and a half is enough to handle the entire world's energy consumption for a full year? Now, this could sound a little weird that, you know, its sun is shining and then you have so much of energy, but I've actually Googled it. A few articles say this, so I'm assuming whoever has found this is factual, but it is a fun fact. Therefore, various solar technologies are in use since many years to convert the sunlight into electrical energy. We all know that. So just to hit upon really quickly about the advantages of solar electricity, which I'm sure you all anyways know about. One is your monthly bills would reduce as you yourself are the ones who are generating the energy. You have a chance to receive payments for the surplus energy exported back to the grid. That's where net metering comes in. A lot of cities now, the governments are pushing this agenda forward so that more and more people start using solar panels. Building maintenance costs, of course, reduce as the electricity generated is used for common areas. Solar power is a renewable energy source, so it's available every day. Unlike other energy sources, solar energy will not run out. As long as we have the sun, we are going to have solar. Now, these are pretty basic advantages which we all are aware of. Now, what is a solar facade? Again, it's pretty simple. It's nothing but a building skin which is designed to absorb and reutilize the solar heat and integrate the energy generated in the building's functional performance. In short, what it essentially means is you basically pick up the floor-mounted solar panel, which you have all over these terraces, and you just pick it up and put it on a wall. Now, I don't mean to undermine the complexities that go with solar facades, but yes, it is actually that simple. The solar panels which are actually mounted on your facades. Now, there are essentially two types of solar facades. One would be the building integrated photovoltaic facade system, which can be used on dead walls of a facade. Again, I'm not really getting into the technical aspects of what kind of energy would be created and with the kind of span of the glass and so on. I'll leave that for the experts. But essentially, you could actually install solar panels on flat surfaces now as well. Although there are certain schools of thought, certain manufacturers who debate this when they say that the facade is not really aligned with the sunlight. So this doesn't really give that kind of an outcome which one would want from a solar facade, the kind of energy that would have to be generated. Another way of looking at the facade, a solar facade, would be to install it at an inclined surface. Now, this is something that I've done a study on. I've been to the Netherlands. I visited a company a month back because I wanted to use something similar for a project. We've seen live projects actually install sites, and this really makes sense from an architect's point of view when you align the facade in the direction of the sun. However, there are architects who would really not want to be, taken down by this kind of a look and feel. There are other alternatives, especially when you have curtain wall systems wrapping around your commercial surfaces, your your facades of the building. You can actually install these inclined facades on spandrel areas as well. This is just a very basic understanding of how the solar facades could be installed on your walls. There is another system as well, which is electricity generating clear glass panels. Now, these panels itself have the film so transparent. There are a lot of people, a lot of companies who are doing a lot of R&D in this, wherein your actual clear, the glass still remains a clear glass and it still generates solar energy. The technicalities of this, again, very easy to find. You can just Google it. So, but this system is out there and this is the future. Now, two crucial aspects while designing a solar facade. Two very crucial aspects. One is aesthetics, of course. As I said, certain architects are finicky in terms of not wanting to see those facade panels on their walls for their buildings. However, for this, I don't want to boast here, but we have architects like me and others in the audience to tackle this issue, wherein we discuss it with the right architect, with the right manufacturer, can create the right amount of aesthetic that is required and still achieve a good solar facade. However, there is another more crucial aspect to this, the most critical, which is a cost. Now, that is where actually the client comes in. A younger client in this case, but still unhappy to shell out money, especially when you want to try something new and different. All of us here are consultants, manufacturers, vendors, suppliers. We all have clients, and I'm pretty sure most of you would like to have a client more like this rather than the earlier one. So this is the cost factor that comes into play, and it's very important to convince the client and justify why you want to make him spend that additional amount of money to do your design, to your solar facade. So now I'll move to the second topic, why solar facades are important for a city like Mumbai, especially for Mumbai. Now for that I need it to be a little interactive. You need to tell me the first thing that comes to your mind when you hear Mumbai. Now I'm not going to point fingers and tell each one of you all to stand up and spell it out. But just for a second, you should think, what's the first thing that what you think of Mumbai when you hear the term? Let me go first. You don't have a choice. So for me, when somebody says Mumbai, I think of this beautiful signage that is plastered all across our beautiful city, which we've been seeing it even before COVID, and it's a piece of art in itself. So the first thing I think of Mumbai is this sign, which all of you all must be seeing it all across. Mumbai is upgrading. And every time I see this sign, the first thought that comes to my mind is the buffering symbol. You know, ho raha hai, patience, patience, it'll happen, it's buffering. However, for some, it could be some architects would think of certain Mumbai landmarks, some would think of Marine Drive as the first thought. I don't know, somebody could even think of street food. The worst time to show you this image, especially after the bad news. So that's the worst time. But y'all can appreciate this more than my presentation right now, I'm sure. So someone would think of street food here as well, and I can see a lot of mouths watering as well. Of course, Mumbai locals, the heart of the city, someone would think of Mumbai as a concrete jungle, which is rightly so. Traffic jams, for us, this is probably what we call this as Western Express Highway any time of the day. Somebody would probably think of slums. You like it, you hate it. Slums are very much part of Mumbai. You buy a 25 crore apartment, you will still be overlooking a slum somewhere or the other in Mumbai, especially in South Mumbai, or you enter and you have to bypass a slum lane. However, everyone will have a different opinion. Does anyone want to shout out what they think of Mumbai? Anybody? I was so sure that's the gentleman who's going to say something. Yeah. So anyways, I paid him to interact with me. Okay, so yes, sorry? Yes. Parsi colony? Ah, that's nice. He gets an extra sandwich. Achal yaar, theek hai yaar. Okay, and so now, yes, but with all these thoughts in mind, I'm sure no one thinks of Mumbai as a green city. You all must have thought of anything and everything, but not termed Mumbai as a green city. So this is quite a shocking statistic. For an article in 2020, Mumbai's development over the past 3 decades has come to at a cost of 42.5% decline in the urban green cover. Another article reads that Mumbai is the least green metro with only 12.3% of the city classified as green. Now these are quite shocking. So now how do these solar facades, how are these linked with a green Mumbai? Now when I talk about this green, I don't talk about, I'm talking about the literal green, the flora and the fauna. I'm not talking about the sustainable green. And this is my take on how solar facades could be linked with a green Mumbai. Now, excessive construction in Mumbai is resulting in something called as the urban heat effect. I don't know how many of you all know about this term. But essentially, what it means is these occur when the cities replace the natural land cover with dense concentrations of pavements, buildings, surfaces that absorb and retain heat. And this effect ultimately increases the cost of your air conditioning, air pollution levels, and heat-related illnesses. To just explain to you very quickly, graphically, you would take a particular location in a suburb or any part of a city like Mumbai, say, call it downtown, and you replace that same thing with a rural farmland, you will notice that at a particular time, the heat that is generated at that spot is more when you have it as a concrete jungle. And that's simply because you don't have enough of evaporation that happens when you talk about an urban scenario, whereas when you replace it with a rural scenario, the surface absorbs less heat, greater cooling comes from evaporation and plant transpiration. So it's pretty simple. The reason when we feel, and I'm not even comparing Mumbai suburb to Kashmir, replace the suburb with a greener bed out there, and then you'll certainly see a drop in the temperature. That's the urban heat effect. Now the solution essentially is, I mean, you increase the green coverage of Mumbai, right? But there is no space, that we saw in the concrete jungle. So as an architect, it's our dream, is my dream, that we start converting Mumbai terraces into forests. An architect can dream, right? I mean, we'll need a good client to finance the dream, but we can dream. So then this is what Mumbai terraces should be, year on end. That sound effect was also part of the presentation. So this is what we dream as Mumbai cityscape to be and the Mumbai terraces to be. Now there is another angle to it. And of course, a lot of developers are now promoting this as an amenity. You'll see all the buildings, even if it's a narrow terrace, they're going to write a jogging track on terrace and so on and so forth. And fortunately, the developers are doing it for a marketing perspective to add an amenity, but in turn, subconsciously, they're actually helping in reducing the urban heat effect, subconsciously, which is a good thing. However, developers now are also very keen on green certification. It's not just because of the marketing angle, but the realization that the buildings cause a significant environmental degradation has driven developers, corporate houses, and other real estate professionals to shoulder the responsibility. All of the earlier speakers have also talked about global warming. It is a reality. And developers have also consciously started understanding that this needs to be tackled. Now, many developers are leaning towards green certification for their buildings, and in these certifications issued by various agencies, the solar strategies and systems are recognized under the energy efficiency and are basically allotted a lot of points. In short, if you put in the more solar energy that you generate, the more LEED certification that you get more points. And another reason, builders being builders, in areas outside the MMR region, they are actually offered additional FSI if you go for green certification. So that becomes an additional incentive for the developer to get that 0.5 FSI if he achieves a platinum rating. And if you see the breakup of what defines a platinum rated building, the solar energy takes a lot of chunk of it. So then, of course, and of course, not to forget the additional advantages which we discussed earlier for the solar energy. Now, the majority of the projects who go in for these certifications as well have their terraces filled with mumties, services, and floor-mounted solar panels. In fact, all the commercial projects that we are doing, all our clients are telling us that the MNC is going to take this place for lease, wants a platinum certified building, nothing less than that. So, of course, you see all the terraces are filled with these large solar panels occupying a lot of space, and there goes our dream of having a terrace forest. So the question is to ensure that the clients get their green certification and get to generate the solar energy that is required for various usages, and at the same time utilize the terraces for creating additional amenities and green space. What do? You free up the terrace spaces, and by taking the floor-mounted solar panel and again placing it on your vertical facades. I am going to explain this to you with a project example. So we are doing this commercial building in Mumbai where, again, as I said, the MNC requirement is there that they need a platinum rated building. It's a commercial building in Mumbai. So what you see here is the entire terrace, this was the first cut, the entire terrace is filled with solar panels. So, I mean, this is a no-brainer. We need to get rid of these. So we need to replace them with our terrace forest. And what we have done with this is we are actually integrating the facade with the solar panel designs, and we are taking these vertical strips all along the facade with a solar facade. And we've integrated that as part of the design. And you'll also see we are doing a lot of biophilic architecture as well. We've actually convinced the client to count all these terraces in FSI just to promote biophilic architecture, and so that each of these offices, well, majority of these offices have these terraces, green terraces as well, decks. So just a zoomed in image of how we have integrated the facade with the zigzag solar facades is what you see here. And the statistic is that we may have covered just 10% of the facade area. Yet the area of the terrace was around 39,000 square feet when it was completely filled with solar panels. And just by converting the elevation into this, we have achieved 54,000 square feet. And this is just 10% of the elevation that we've covered in solar facade, and we've integrated that with our design. The second example would be a residential building that we've just launched. It's going to be the second tallest building, well, one of the second or third tallest building in Mumbai. But the plot is very tight here. So we don't have a large terrace. And this is a very, I wouldn't call it a unique building, but a different building, where if you see from down, we have around 10 floors of podium. And then over that, we have an additional 10 floors of a mechanical car park. Now, the amount of electricity that this is going to consume is crazy. But at the same time, we have to understand that when you need to fit in 600 cars in South Bombay, there are no other solutions but to think out of the box. So we have a mechanical car park coming in at the top floors. And again, the terrace plan was pretty basic. We are going for a platinum certified rating here. It is pre-certified platinum already. We had shown a lot of terraces on the facade. Later on, the client said, the building looks good, I want to live here. And then he wanted his penthouse on top. So we ended up making, so these were the solar panels. So we ended up making a lounge for him at the terrace with its own private lawn. And both brothers are going to share each side of the building. What that resulted in was a minuscule amount of solar panels. Later on, once the apartments started selling, he came back to us saying that the clients are demanding access for the terrace. So then there goes our dream of having solar here as well. And then we converted these as a terrace for the apartment owners as well. So again, solution for this comes as a solar facade. What we decided was we are going to, because we have a mechanical car tower, we are going to we don't really need natural ventilation there. So we are going to fill this up with integrated solar panels on the facade as well. And again, the fun fact here is after doing this integration with just 15% of the facade, the entire terrace, which was around 10,300 square feet, you have 11,600 square feet of solar facade out here, just by incorporating it in the design. This is where we architects with the manufacturers have to work closely and come up with such solutions, integrated solutions. So in conclusion, I'd just like to say that the solar facades help open up terraces for amenities and green spaces, in turn helping reduce the urban heat island effect. With the amount of construction ongoing in Mumbai, all dead facade area of a building can be turned into an electricity generating facade. However, it's a cost-sensitive market and developers are not going to implement solar facades unless the government makes it mandatory one day. Just like they've made the sewage treatment plants, the rainwater harvesting, etc. mandatory for a certain quantum. Until and unless the government doesn't make this mandatory, we don't really see a shift happening unless an architect is able to convince his client to spend that kind of money. So lastly, we at TPA believe in turning entire building facades into vertical power generators, paving the way for the dream of net zero buildings, a green Mumbai, and a greener world. Thank you.
Thank you, Carl. That was fascinating, and it's very encouraging to see firms like TPA taking the lead on this. Our next speaker is Edward Thomas Oommen, who is the manager of Facade for Fisher India. He's going to be talking about innovative solutions for facades. We have this session and a panel discussion before we conclude the evening.
So before I start, I would like to start with a congratulations to Zak World of Façades team for their 100th event. Great achievement. Wish you many more to come. My agenda is pretty straightforward. We'll be talking about a bit into the company, undercut anchors for dry cladding with subframe systems, passive fire protection systems, casting channels, and anchors, both mechanical and chemical. In terms of our company, we are based out of Germany. We are still a family-owned company. We are a billion-dollar company globally. We have close to 5,400 employees globally again. But the fact remains that we have close to 1,500 patents across the industry. So that really shows you into the amount of innovation that we are into. Just a small video. So greatness is built on great solutions. So I'll start with a couple of references. This is La Grande Arch in France. It was a refurbishment of an existing facade done with Bethel white granite. Stands at 110 meters. Then we have the Al Hamara Tower in Kuwait, which stands at 412 meters, which is the highest natural stone facade in the world, which was designed for 5.4 kPa wind loads. Then we have one project which is 99 Hudson, one of the reasons which stands at 271 meters. One of the reasons I wanted to show this, highlight this, was the stones were drilled in Germany, prefabricated in Miami, and installed in New Jersey. So the amount of flexibility in terms of transportation as well. And then, of course, we have the Bai Temple in Chile, where special glass and translucent stones were fixed. Now, one of the common factors for all these projects was the Fisher undercut anchors. So we have anchors in our portfolio ranging for the entire product range. That is natural stone facades, ceramic panels, thin material panels like HPL and fiber cement boards, and glass. So this is how the drilling happens. So first we do a drill cut, depth cut, and then we create an undercut. The anchor is placed. And the bracket is installed. And this entire system can be installed on a subframe system provided by Fisher itself. Of course, we also have standoff anchors which help you with undulations that you may come across in a stone while getting a stone panels supplied. So we also have the complete range of products for subframe systems as well. So we ensure that the entire product, the application is provided from a single supplier. You don't have to go to different sources for different products. Of course, fixing undercut anchors, the major advantage is because the fixing happens inside the panel, the bending moment reduces, your panel thicknesses can be reduced, which in turn reduces the load on the structure as well. So you can play with bigger panel formats, greater safety in calculations, achieve slimmer panels, and more freedom in design. Just give you a small video. We also, of course, support you with the entire services, that is in terms of stone testing, in terms of panel calculations, subframe calculations, the entire details.
Standards for facade durability, energy efficiency, and design flexibility are increasing continuously. The Fisher Facade systems fulfill all of these expectations. Fisher Facade systems, subframe systems and undercut anchors from one single source. The system provider for ventilated rain screen facades. The Fisher Facade systems are the optimal modular system for all requirements and materials. This visually most appealing solution is achieved through concealed fixing using FZP2 undercut anchors and suspending clasps in horizontal profiles. The innovative assortment is the perfect choice for visible and concealed attachment of all common cladding materials for ventilated rain screen facades. Fisher Facade systems utilize the effect of a rear ventilation to create an energy-efficient facade and provide optimal weather protection. With high quality, a long service life, and a consistent recycling circuit, the matching shape of the undercut anchor creates an interlocking and stress-free fixing in the conical undercut drill hole. The fixing is not externally visible, creating a visually appealing facade surface. Setting the anchor using undercut technology allows the user to select the best structural position in the facade panel. This significantly reduces the bending moment of the panel. The consistent residual wall thickness as a reference in drilling holes allows panel thickness tolerances to be compensated. More freedom in aesthetics and materials for visible fixing using rivets and facade clamps, and for concealed fixing using undercut anchors and cassette solutions. With more than 50 subsidiaries, Fisher is your global project partner on every level. We support you in all areas of facade construction. Fisher Facade Systems, subframe systems and undercut anchors from one single source. The system provider for ventilated rain screen facades.
So that's for the undercut anchors with subframe systems. Then moving into passive fire protections, our friends did pretty in details talk about it. So I will just touch upon a few points. Of course, why is it considered in facades? First is dropping material for anyone who is trying to escape. So safety and security of the people around. Of course, fire can spread through curtain wall joints around the perimeter, also in rain screen facades as well. So again, I'll just move in case of a fire, you can see in case the perimeter joint is not sealed, the fire can pass through. So once we provide the sealant, the fire does not pass through, but fire and smoke does not pass through. But again, because of leapfrog effect, fire can pass through the glass. It can break out of the glass and pass to the next floor. So Fisher products acts as an extension of the edge slab, concrete edge slab. So what we can do to take care of perimeter leapfrog effects, one is increase the spandrel area, second is use of fire-rated glass. So the concept of fire stop, we are talking about compartmentation of fire in vertical and horizontal manner. We have the product range available for the perimeter joints, where we have FCFCL, RFS, and FFBES, all as per UL, ASTM, and EN standard requirements. Of course, orientation of the safing material is important. It always has to be installed along the compression zone and not other way just because it looks better. Another major installation challenge, the mistake that we see is generally if there is a 100 mm depth and a compression ratio of 30%, a lot of times people talk about it being 130 mm requirement of min wool, whereas the actual requirement is 143 mm. So this gets missed out a lot of the times. Of course, it is also required in ventilated facades where compartmentation can be done. Otherwise, through chimney effect, the fire can pass through into the windows and get into the next floor. So Fisher does have a product which in case of gives you a ventilation, but in case of a fire, expands and seals the gap up. So just a small video.
When a fire breaks out, active fire protection systems such as fire alarms and sprinklers are not an effective solution on their own. Despite having active systems in place, fire can spread rapidly, and the greatest damage is often not where the fire has started. The spreading of fire, smoke, and toxic gases can be effectively prevented only with additional passive fire protection systems to prevent property damage and save lives. The Fisher Fire Stop range offers everything required for effective fire stopping for all types of applications. The Fisher FFB VS VentiStop system is an effective fire protection option in ventilated facades. By using FFB VS, the rear ventilation essential to the building physics is maintained, but closed in the event of a fire to prevent the spread of flames, for horizontal cavities between the inner and outer construction elements. The Fisher RFS 640 Rapid Fire Seal, as well as the Fisher FFB ES Elasto Seal, are used to seal perimeter joints in curtain facades and can reliably accommodate both shear and lateral movement of the construction components. Both products are real all-rounders and can also be used for construction joints and service penetrations. This means fewer products required on the construction site. We are your global partner for those involved in the planning and construction of passive fire protection measures, represented by 47 national subsidiaries. Fisher Fire Stop, the full product range for passive fire protection applications, including European ETA assessments and UL Underwriter Laboratories listings.
So that was our second product portfolio where we talk about passive fire protection systems. Now just moving into casting channels, I'll briefly touch upon. We have a different entire range of casting channels available in our portfolio, both hot rolled and cold formed. We have various sizes, but if you notice the bottom two sizes, bottom row, you will see sizes which are generally a lot more efficient for facade requirements, because with cast-in, load becomes a standard. So if you have a larger channel, it might take the load, but then the cost efficiency goes up. So we also have that advantage. Of course, we do design, we do support with design, and the entire product portfolio has been designed in line with ETA. And we, as mentioned earlier, we do support you with entire design supports. Moving off swiftly into anchors. Now, one of the things that I would like to point out, a lot of times, a lot of discussions, we end up over-specifying anchors. So please note, if you don't need a seismic requirement, you have alternative anchors available for the project, for cracked concrete. So there's no point over-specifying, because if your structure is not designed for seismic, there's no point putting a over-designed anchor. So we here as a company are here to support you with designs. Softwares are available online free of cost where you can download and design for your own self, and we can support you as well. Of course, we have concrete screws, nylon plugs, and chemical anchors as well in our portfolio. And of course, as I mentioned earlier, the design support can be provided from the company, but also the software can be downloaded free of cost online and can be used at your end. So with that, I come to the end of the presentation. Thank you so much.
Thank you, Thomas. There are a lot of people waiting for you to get done. Sorry for this interjection. All those people behind, if you can just occupy your spots here and be seated. I know everything is getting stretched and delayed, but we promise this is the last half an hour here. So can you all just be seated, please? All of you out there to the left.
It's an order. Please be seated. No, it's a Zakir style. Sit down, please.
So Gautam, I don't know where you are. Just give us maximum 10 minutes for this 100th edition celebration. I think they deserve this. So I've been asking Ahmed for the last 3 weeks or whatever, what are you doing special on this event? Because I think to start off with, we discussed this in the morning, but they deserve, again, a very big round of applause. And if I can request you all to please give them a standing ovation.
Please. Come on.
And I would like to call upon Zakir Uncle, Ahmed, Azan, all on the stage, please.
So while we cut the cake, I want to call 2 more people on stage who actually were the first MCs. Tariq, give me a second. MCs of our event, Esha and Arvind. And me, I was fired. I was the 3rd guy to fire. Tariq got fired recently by Ahmed. But I want to actually give this. Zakir bhai, I want you to open this. It's got a special message in it.
You know what, Amit Malhotra? He's such an opportunist. मैंने बोला उसको, let's go in a sequence. The sequence will be, we'll let the balloon go, but the hotel people took objection to it, saying that it being gas in it, it's not safe. And then we have this pop-up, and then we cut the cake. And I said, Amit Malhotra, जो भी करना है यार, केक काटने के बाद करना है. वो बोला नहीं, मैं पहले में ही दूंगा आपको. चलो क्या है देखेंगे.
बोलिए. No, sorry, you're not that pretty. Come on, you have to be realistic in life. I mean, come on, you can't do this. But this is for the industry, and I want to applaud Ahmed. I have known him from the longest time. Zakir bhai. Indian company making it all over the world, 30 plus countries, events round the clock. This is not a fucking joke. This is reality. God bless you. Ahmed, my friend, God bless you.
Yeah.
And Zakir bhai.
And I have to tell you, we've been
hold on. Azan. So this is 100 going on 1000. So your job just starts now. I wish you all the best. And all of us are standing. Please, a nice big round of applause. Arvind. Esha, where is Esha? Arvind. You have to say 2 words.
Deeply honored and blessed to be a part of this great organization. I am who I am because of Zak, and I owe it to you, sir. And this is one of the biggest platforms, and I'm so proud that this has come from India. So a big round of applause for these wonderful people who are taking the flag of India all over the world. Thank you, sir. Thank you, Ahmed.
Few words from you.
Yeah, just go ahead and say something.
I'm very humbled by the support we've received over the years. Thank you all for being present and supporting. And I hope we can do many more events like this. Inshallah, 1,000 events, and I look forward to your support going forward also. Thank you so much.
Thank you. The people who made a difference to Zak World of Façades, I want you all on stage. I will not call the names. They know it themselves. They have to come. Suresh, Uday Shetty, Naveen Keswani, Rohan, then Amit. Come. Suhail, do I need to take your names? Come on, guys. People are part of this movement. Please come. Everybody. All. Mathieu, please. I need about 150 people on stage. Quietly, out of 300 here, I need 150 on stage. Praveen, aao yaar. Der mat karo. There's a panel discussion. Come on, people who made a difference to Zak World of Façades on stage. I need 150 people to cut this cake. Boss, this is 40 kilo cake. I can't eat it. I want to share it with you guys. Please come on stage. Come, Srini. इतने शर्मिंदा लोग यार जापान में आओ अभी जापान करके आया Zak team come on stage everybody everybody come on stage
call your AV guys yes
लो Mitesh आओ where is the Mitesh स्टेज अच्छा बनाया ये बार आओ. A big round of applause for Mitesh.
He's somebody.
I can say so many people.
You all don't know, but I
thought of
have to
this.
tell you this. He's somebody who always works behind the scenes. So jitna bhi all this jazz you see behind on these LED screens.
जल्दी आओ स्पॉन्सर्स, अपने पैसे दिया ना मुझे, आप ही का पैसे में मैंने केक बनवाया.
with me for another 15-20 minutes more to end your day. We have good representation on the panel. We have architects, we have developers, we have system supplier, people who are in the supply chain. And I've sort of broken it down into sort of 5 subtopics. The first one obviously is about trying to look at the role of the design team and how well dovetailed it is when we start talking about a design team led by the architect, multiple consultants on board. How well dovetailed it is. So I think my first questions to the developer, Ananya in this case, how well defined do you think are the roles multiple design stakeholders, multiple parties, be it architects, be it consultants, to sort of lead to less confrontational, more collaborative approach in design?
Thank you, Gautam, for the first question to me. I think the processes or the stakeholders, as one would call, are very much well established in the industry. So if you're a developer who has, who's of some, considerations, you would have a proper RACI in place, right? Which is, various different roles and responsibilities. And you would thereby, if you are really new in the world, you would get a professional to kind of spell out the processes, and especially on the procurement side, which needs to be absolutely elaborately, and minutely figured out. So it's not something that you later on realize who's going to be the person who's going to be responsible for the process. So we generally, as a developer, we would get one of the big Bs to set up the entire process for all the various departments and stakeholders microscopically, so that when it goes to the final procurement, there isn't very many changes that we are expecting to happen. And you've done your multiple round of cost planning, you'd had your rounds of value engineering, and you've actually got the stakeholders, which is a procurement and the costing team involved in day one.
Wonderful. I think we hope that all the design processes are as structured as that, hopefully to not have people pointing fingers at each other in the middle of a design discussion and get an optimum outcome out of that. Next question, obviously to the architects. I think as the principal gatekeepers of the design, and I mean, you guys chase us with a danda pretty much all the time to, get optimum inputs into your design, get the best informed engineering decisions into your design. What do you think more can be done to get the best optimum outputs from the design process? I'll open the stage. I mean, either Nilesh or Anuja, anyone can take the question.
I mean, I always... Hello? Yeah. First of all, I always believe that architect is a captain of the ship. So whether it comes to right from the conceptual level till the execution, till the end, you have to be there in the entire process. Whether it's the design, it's the execution, and even is a part of the procurement. Because eventually you have to make sure that what you are proposing, what you have conceptualized from the day one is getting executed. So I really look at it as equally my responsibility to make it happen, what I have shown as my concept. And it happens as a process. There are several times the challenging situation comes, but you have to be there and you have to make sure that the whole process has been done. That's how I look at it.
Nilesh?
Glad that you asked that, Gautam, because that's a slightly shifted scenario that we see nowadays. Gone are the days when you would actually go about the design, put up a design in place, and after that you start with the whole usual dialogue that ye cost mein nahi baithta. Now let's try and fit it in the cost. We are gladly welcoming this particular change, and we are seeing this on many of our projects now. A few of them which have been of the yesteryears that we have designed, and now we are greeted with the
procurement guys and the tendering guys who tell us that this doesn't fit in the cost. But the newer projects which are coming up, all the global trends in terms of the commodity prices rising, the metal prices rising and everything, we see that there is an opportunity where the procurement guys, the tendering guys, they can probably add to the project brief when you actually start the project. And if you have that sort of a data, the architects can probably look at the problems a little bit differently. That
So
would
instead of
help.
construction managers and procurement guys walking in right after the tenders floated and they said, chalo, value engineering karte hain iski."
Let's
let them come in a little
Correct.
early in the
Yeah.
design process as well, right?
Let them give some pointers. Let them probably bring up case studies of their past projects where they have required to do a value engineering. They need not really tell us how to design, but they can give some intel on it, and they can give some probably mistakes that have been done in the past because of which the design had to be cut down, or it had to undergo a major de-specking is what I would say, and it's a sorry face of what it was actually supposed to be. If there are mistakes, it can be learned from, and they can contribute to the design process as such. That can get an optimum output out.
Right. I think as a follow-up question, which I have for you, you play a very specific role at in your firm, where you're the head of facades. I'm sort of almost thinking that you must be involved in all the projects from day one, where you start providing cost inputs, you start providing feasibility inputs to projects.
Yeah, actually, facade as a main contractor is just one part. As a main contractor, we have got so many packages, like it can be roof or interior elements, structural steel. So imbibing or containing all these packages together and collaborating to have a master schedule, it becomes a challenge to us. And in that case, generally in facade, what we find is the structure is not ready and facade vendor, it comes on board, or vice versa. Interior things cannot take place because facade vendor is not on board.
Right.
And the reason is the procurement. The procurement is not on time. There can be certain lead time items which are not procured on time. So this actually makes a critical effect on the total project completion. So yes, we have to actually collaborate all the efforts, and we have to actually dovetail all the activities to have a full-fledged completion project on time. Yes.
Wonderful. I think I might have an addendum to that, which is in my follow-up question. The next one obviously is talking about the structured innovation that we need to bring about in the design process that actually helps procurement. And again, back to the architects, my favorite. How inventive do you think is the design process to allow use of newer materials, greener materials that are easier from procurement perspective? How early do you start thinking about that in the design process?
I think from day one. That's how today's process have to be. Otherwise, if you start thinking later on about the green initiatives, it's not going to happen. And of course, it would differ from project to project. It would differ from kind of a genre of the project. But it's wiser to start that process and make your even client aware about it. Because if he starts thinking that I want to now imbibe sustainability into it, then maybe he has missed the bus. But as an architect, right now, whatever projects we are doing, we try to work around it where we could get the sustainable product. Of course, you have to analyze at every stage that what additive cost it has. At the same time, I think now all of us need to think about the life cycle analysis, and the time has come because now we have completed one cycle of various kind of building users. I think decade back, it was a new trend where we started working on the high rises, we started working on the mixed use. Now we have passed one decade where we have now experienced that what is happening to all those I mean, right from the elevators to your facades to your glass. And then we are analyzing when we have started maintaining all this product. Now it is very important. What is the sustainability? How your entire project or your entire build form is going to perform after certain years, and what changes you have to do in your specification to make sure that the occupants are not burdened with all this, and you have that kind of recyclability. So as an architect, we have started making them aware, because even we have also learned through the process that what is happening, what the specification, what we used to give decade back, and what we are specifying today. So that's what even the journey has happened as a designer to us. So we have to definitely think about all this.
And you have an army of consultants helping you on the technical side, but as an add-on, do you get enough support from a procurement understanding perspective, whether we can buy it or not, can we afford it or not? Does it fit well under the cost plan early in the days?
Definitely this particular subject is a lot more challenging, and we have to all work towards it. So right now, if you ask me, no, the industry is yet at the nascent stage or young stage where we are still building that kind of expertise. So slowly and steadily, we all have to move towards that direction. Still, the awareness is not there 100%. I think slowly we have to be aware. Like green building a decade back was just started. Today, the green building is something which is different. We have taken that subject very seriously. Even our bylaws, MOF, everywhere it has become a coherent part of our design. I think Carl had given a good presentation where he talked about solar panels, and he has said that implementation through the bylaws is very important. How we have incorporated STPs and rainwater harvesting. Similar way, this has to become a part of our DNA, and then it would start. So somewhere we have to start, and we have started. That's how I look at it.
Your thoughts, Nilesh? I know we are trying something very different on a project. Do you think that kind of process is well supported
Yes.
from a procurement standpoint?
So just to add to what Anuja was saying, I would put it to an extent that we have to challenge the conventionals to an extent. There have been ways we have been doing buildings. We have been certain typology, and this is how you would expect a building to happen. For example, if it's an office building, it's a given. If I say now, most of our clients, they expect that it has to be a glass building. Okay, and if you're not able to give some tolerance to that, you will not be able to get great amount of influence in terms of choice of materials. The array doesn't change much. You would just be limited to selectivity of glass. You would play with the selectivity of glass. With the prices going high, you would want to keep the solid surfaces to be minimum on the glass and everything. So it's a joint effort. The client needs to be taken on a education trip a bit. Things have to be unlearned a bit, and the conventions have to be challenged. There has to be an acceptability to see some amount of porosity on the surface and not make it completely transparent. That opens up the choices a bit. It's a much more collaborative approach that we can take to the design, and that can actually bring the green materials a lot more choices can be brought in.
Yeah, amen to that. I hope we are able to successfully implement something like that on our buildings.
I mean, I would rather say that the day on which we have to start specifying the green material, everything is green, then that is the day when it is percolated in the industry. Right now we are isolating and saying that the green materials, but why not each and every material is a green material, and then you have a wider choice that anything you take it, it's green, it's sustainable.
Great. And then the next question to you. Again, sort of a follow through to that question. How early do you typically start questioning when an architect shows you a beautiful render and it's like, iska ye material kahan se aayega? Glass kaun dega? Is it possible to do here? Can we do it locally, etc.?
I honestly feel architects have a role to play, but it's not everything, because they give you the initial intent on it. What you can do is look at it roughly in terms of what's the square footage on that, and what kind of facade systems, or if it's a fenestration building, are we looking at system windows or whatever. But if you want to really look at is the specifications which the developer is looking at. Performance, for example. I think the cost on the facade is not just on the square footage. It is the various specs that are inbuilt into it that makes the cost of the building go up or the facade go up. So if you're looking at higher performance facades, it will definitely be way more expensive. If you are looking at already established extrusions that are available, the cost would be cheaper. What are the size of the panels? What are the logistical requirements of the site? Whether you have proper storage, how the installation at site will happen, whether you have to actually give a crane for the installation, or you will be able to use your elevators. So it's not just the building which is going to add, a render which is going to add on to the cost. It's a whole loads of things. And I'll tell you, the cost of the material is not even 50% on the cost in the facade. The majority cost goes in the fabrication, the transportation, and the installation. So it's not just the material or the procurement of the actual facade materiality that is going to add. Of course, the specs on the glass and so on and so forth, or the heat performance or the fire standards, for example, that is going to be a big driving force. The panel sizes that you have. I think those are the conversations that are, of course, connected to the architects. As I said, it's just the material cost is not what the cost is.
Yeah, that was the leading question. I think you almost completed the whole conversation. It's not just about the materials. Obviously, when you see a fancy renders, like, okay, how am I going to put that facade up on the building? It's not just purely about the cost of the panel or the materials that go into it. So I think that's, I would certainly want some of your thoughts on it.
Basically, what she said is right, like more than the material cost. A lot of times we face or we put a lot of cost into the installation process, the logistics, and bringing the panels and defining the installation methodology. It takes a lot of efforts as well as it takes a lot of cost. And we need to actually channelize all the processes to have a smooth installation of facade, apart from the other packages what we do. Like if roof is also going on and facade is also going on, then the logistics and all that we need to actually define in a proper way.
Agree. And I think that has to be an early design discussion to be able to inform the process well. I'll come to you, Yasmin. I think you give the buildings the physical appearance eventually. You guys are the ones who build it eventually. How early in the design process are you guys involved? I mean, do you ever get called in when there is a very schematic render in place, or we're just talking about facade systems? How early do you get called in by consultants, by architects, by developers?
This is a very important factor actually, and I'm glad to say that the industry is moving towards the level wherein we do get called in at an early design stage. As Arvind during our presentation has clearly showed that we get involved at the design stage, at the schematic design stage with the client and the architect, and then we come as a partner to the consultant on the advisory as to what system can be proposed over there. And that's the best time, I would say, that a system can come into picture, because that gives us the time to evaluate the performances that are required, the specifications that are required for the for a particular project, and if any new developments have to be made. That gives us the time to come up with solutions which are more accurate to the project.
Do you think something more can be done? Obviously, Arvind's presentation shows a lot of possibilities where you guys can actually contribute a lot more.
Exactly, that's the point. The earlier we are involved, the better for the project and for us. And that gives us a better time, because usually it's a lead time which comes. A lot of products have to be developed, they take time, the extrusion takes time, new die developments take time. All of these processes cannot be rushed. These are the processes which by default have that process time which we cannot jump. If a die development new, we all know that it takes about 6 weeks. We cannot jump it to 3 weeks. It's something we cannot do anything about it. So we really would prefer to get involved more and more at earlier stages with the architect, with the consultant, wherein we can come up with better solutions. We are coming up with a lot of green products we are talking about. So we have solutions in green products also. So the earlier we are involved in a project, we are able to give better solutions, and we are able to reduce the later on procurement time as well, if we are ready with the solution earlier.
Right, so the earlier you're involved, the better
It's
visibility
better.
everybody has into the procurement process, and that informs the program better.
Yes.
Right, I'll come to my next favorite question, that's the cost. And I'll start with the developers, obviously. You guys are the ones funding the buildings. How do you strike the balance between cost and performance? I mean, when we talk about high-rise buildings, high-performance buildings. There is, on one side, you have a cost that needs to be balanced out, and on the other side, there's performance aspirations. Where do you draw the line saying, okay, this is where?
Yeah, meaning, look, everything drives from the selling price on the project, right? And the kind of, customer that you're looking at. It is not to say that the customers who are not able to pay as much or their property value is not as high, you shouldn't give a, high quality product. But you have to obviously create a balance. And there are certain things within the company that you could have your own, brand standards on the performance. And I strongly feel that we do not use simulations and the calculations to our, use. For example, if it's a 30-story building, we won't even think of going and doing a wind tunnel test. We wouldn't want to know what the calculations are on the project or whether we should, optimize the facade. You would say that this is the, standard and it should be from the ground up. You should do, this is the typical window and let's just put it. Whereas you could do a better window but at the same time be little vary where you require higher strength, where you require more performance and where the wind pressures are more. So I think if we kind of evolve the, the entire process of facade design more technically, I'm sure we would be able to give, better product in the similar kind of cost.
I'll just pick on one thing that you said, which is about the end user. Do you see end users demanding better buildings? Do you see end users demanding better facades? Like, I now see my banker friends know what a DGU is. So are they demanding better buildings? Are they coming better informed?
I think, look, if you're doing a good product in terms of facade, the developers also should talk about it. It's all about marketing, right? So if you are doing a good job, why not market it? Why not educate the people what they are going to be getting? So it is definitely slowly and gradually becoming a big talking point for the customer and it is important for them.
Yeah. I think they know what value they're getting out of their buildings or the products that are being put in the building, so they might be willing to shell out a little more, hopefully in the future.
Yeah, meaning, of course, everybody understands the, if you're standing next to a building and if, there is a heat element there. So if you talk about better glass, if you talk about, air tightness and things like that, people have faced failures in some place or the other. I think it's, customers are not asking for it, but people are valuing it.
Wonderful. Nilesh, I had a question for you. You guys draw that first lovely building render with all your heart, and then you suddenly realize कि ये cost पे नहीं बैठ रहा है. How do you guys strike the balance?
We ask for an extra budget from the client, and it's that simple.
Do you get it?
I mean, we attempt it every time, though.
But do you get it?
No, that hardly has been the case, but that's the first step that we put together. Yeah. So coming back to the point, it's more about common sense when you have when you are strapped by the budget that is being provided to you, and you would want to spend it wisely at places where it would matter the most. That you would there is, taking on your second question that you were asking, Ananya, about was that whether people are expecting better spaces to happen, better buildings to come up. Yes, definitely they do. There is a growing emphasis about monitoring indoor air quality and seeing that that's being implemented. And that's not just by active ways of doing it, about your AHU filters and everything. There is an increase in acceptability and in fact a demand to have biophilia probably integrated within your spaces. These are the places or the strategies that you may probably implement and get costs not just from the facade down, but from somewhere else so that you can spend it on the facade. So it will have to be a bit comprehensive in terms of a strategy. Those are the sort of things.
Yeah. You want to wear good shirt outside a very slim, skinny body, right?
Yes, that way.
I think what we are also missing out is the point of safety. A lot of cost goes towards actually creating a very safe facade or envelope. So safety parameters or the thresholds that you're establishing for your building on safety, I think that's also is very, very, cost-driven.
Yeah, that was my 17th question, but I've just been reminded by Zakir bhai we need to cut it short. I'll just ask one last question, Yasmin. I think you guys are at the receiving end right at the end where the design is established, the cost is still a question, and you have to supply a very high-performance facade in that much money.
Unfortunately, that's always the case. And I cannot emphasize enough that the earlier we are involved, we are able to give better solutions. There are multiple reasons why we keep on insisting on this fact. Primarily, site limitations come up, and facade, when it comes to facade, we are usually the last people to enter. By the time most of the things have been finalized, site is almost sometimes halfway through, or all the designs are frozen by the time we get involved. So it's, we are left with very limited creativity to give a solution. Many a times we would be given, okay, no, the sill depth is only 120 mm, we cannot go more than that. So we have to come up with a solution within that depth. So it's nice that if we can get involved sooner, we can give better solutions, we can give more informed solutions at the earlier stage, and that gives us enough time to even work on the costing factor as well.
Okay, better budgets, early procurement involvement, early vendor involvement. I think that can be the takeaway from this. And I think with that, I'll close the discussion. Thank you. I think everybody who's now surviving will get like a night stay at ITC Maratha, courtesy Zak.
Don't we all wish? But thank you so much. Gautam, I request all of you to please sit on stage for a second because we have Sam Robinson joining us to give out the mementos. Is Sam here? Yeah, I'm just trying. Okay. But a fascinating conversation. You might want to ask one more question. Oh, he's here. I was like, just kidding. Yeah, that might be good, no? Put him on the spot. I'll give him a mic again.
Hello. Yeah. So, anytime you have come up where you have given a cost-effective solution and the developer asked you to say, how could you give me such economical design? You should give me something expensive. Is that happening to you?
I can smell the sarcasm in that question from like a mile away. It's...
It has happened to me, that's why I'm asking it to you.
Yeah.
That the question which you asked Nilesh, that you always show a good elevation.
Yeah.
But there are occasions where really we have proposed something which is really cost effective, just apt for the project, and the developer came up and said that, why this is such a elevation you have designed, you are supposed to give me extraordinary.
Then we'll get a question that jo pehle dikhaya tha wo acha tha.
No, after the value engineering, it's like in architecture college, your first plan is the best plan. That's what has happened.
Well, let's all hope that we all are blessed with clients like that in the future. But Sam, yes, thank you so much. Gautam Basim, thank you so much for hosting our final and concluding panel discussion. So Gautam. Anuja Sawant. Dr. Ananya Gandotra.